I'm not going to keep it too long because we are on a very, very tight schedule. So I'm going to call LZRS to the stage. You are building modular cloud, and you're going to tell us something about the economics of modularity. So please give him a hand.
Hey everybody, thank you for coming. Do I just go to the next slide with the... Oh, no. Don't look. Spoilers. Okay. Yeah, my talk was originally called The Economics of Modular Blockchains, but I realized that that was a very broad topic and it'd have to cover a lot of breadth and not go very deep on any specific issue. So I thought I'd kind of apply some of the principles I was thinking about in that original topic towards answering a very practical question that I think that the industry needs. And what I want to answer is, if somebody is an app developer, meaning they're building software for users that serves a purpose, why should they consider to include modular blockchains in their tech stack choice? And before I answer that and go into this, I do want to introduce myself. I'm LZRS. I'm the founder of Modular Cloud. We we have a cloud infrastructure for modular blockchains, and I am on a panel in about an hour from now, and I encourage you all to attend, and we're going to talk more about the specifics of those services that we provide more in depth in that presentation. So, okay, now on to why should people use modular blockchains for their apps. So here's the common narrative of why somebody would want to use, or how a blockchain works. Essentially, there's a user, and this user creates a transaction, and they securely send this transaction to some sort of decentralized network. And once this transaction is off into the internet on this decentralized network, there's this group of nodes that come to consensus, and they verify that this transaction is valid and update the state, and it's broadcast and finalized and sent out to everyone in the world. Now, I think that this is like a common explanation, but I don't think that there's some parts of this type of common conception that I don't like. And the one I want to highlight right now is that I don't like that when people when they say, okay, the user uses the blockchain, because I think that really takes out a really important point and part of the equation. And in doing so, it kind of makes people that are building apps not really understand where they fit into the picture. Because the reality of the situation is that the user is not using the blockchain, they're using a device like a phone or a computer, and on that is some code that's run that's written by some sort of third party, like it's some sort of project, which that is the app. And the developers that are building that app are integrating with the APIs and SDKs provided by the blockchain. So the app developer, in a sense, is the true consumer of the blockchain. And I think, like, as we go on over time, we're gonna transition more from everything being where we tell people, like, okay, this is a crypto app, this is a blockchain app, and a lot of stuff will be going on behind the scenes once developers realize the power that blockchains can provide them just as a technology in their technology stack. So, okay, so imagine you're an alien and you're like coming to Earth, you have no context about this, and you look at these two apps. These are undeniably apps. They're both on the Android Play Store, so you can install these apps on your phone. These are apps. These are not blockchains. They're not decentralized networks, right? There's the Venmo app and the Mycelium Bitcoin wallet. Now, I would ask, what's the difference? I mean, you can say there's a different UI, different name, stuff like that, but by the way, oh, sorry, I thought the time was frozen, but it was actually moving. Never mind. Anyway, I'm trying to be mindful of my time. Anyway, so if you compare these apps, like they both connect to the internet. One of them, you could say, connects to the Bitcoin network. The other one connects to Venmo's servers. But that, in and of itself, is not a particularly meaningful distinction. What I would say is the difference between these two is that the Bitcoin wallet is actually not only retrieving some data from the network, but it's also doing some sort of verification on that data. And and the way that it does this is it connects to this very powerful API that you can call the Bitcoin node RPC. And what I want to do is I want to, in this talk, propose an abstraction that we can use when we think about talking to RPCs. And this is going to apply to all blockchains, not just Bitcoin. I'm starting with Bitcoin because it's a very simple case. It's basically an app chain for payments. And over time, we've modularized these and expanded the scope of what these protocols can do. But this is going to be an easier case to explain. So I have this abstraction that I'm going to present to you called a cost function. And this is how I think that app developers should be conceptualizing blockchains. Like, they shouldn't be thinking about the internals of the peer-to-peer networking and cryptography. I mean, it's important context. You need to be aware of that. But it's not the fundamental thing that you should think about when you're considering how or if you should integrate a blockchain into your app. So what is a cost function? A cost function is essentially, if you given a statement, it's the cost that the person making that statement would incur if they were to commit fraud. So in the case of Bitcoin, this has a very narrow capability. So if someone says, I sent you 5 Bitcoin, and I'm going to be very much abstracting this process, I'm not talking about actually how this works. This is a very high level description of this process. But if someone says, I sent you 5 Bitcoin, you wouldn't want to necessarily trust that that's true and like do something irreversible like sell your kidney, just trusting that it's true. They could be committing fraud. And the difference between something like Venmo and Bitcoin, both are hard to commit fraud on, but if you use Venmo, you don't actually have the information for how much it would cost to commit that fraud. So you'd probably be fine with Venmo, but there are situations where having that additional information would be good. So in this case, this person claims to have sent 5 Bitcoin to this person in exchange for some service or goods, and this person realizes that the cost to commit fraud in this scenario is lower than the value of the transaction, and now they can make a risk assessment and they can model the risk based on their use case on how confident they are and how they want to interpret that data. Between the two, but I think that they're actually connected. At the last Modular Summit, I gave a talk on the subject. I encourage you to check it out if you're interested in learning more about that, but I'm not going to talk about that here. So how does the cost function work? Essentially, you start off by having this assumption that you have access to the open internet, and through accessing a peer-to-peer network, you're able to scan and get all the possible chains, or maybe not all the possible chains, but among the chains that you can find when you scan the internet is the one that you are looking for, which would be called the canonical chain. It would be like, for example, the longest Bitcoin chain with the highest difficulty. That would be the canonical Bitcoin chain. And what happens is you retrieve data from the network, and then you apply a rule set to actually determine which of these potential canonical chains is the canonical chain. Because you can't, of course, trust anything you hear on the internet. Just because someone says this is Bitcoin, it doesn't mean that it's true. So the way that this works is you can break this down into 2 pieces. First is validity, and the second is a fork choice. So if you think of all these things as just raw bytes, like just blobs, binary data, you will parse that and you'll check if the structure of that data follows the rules of the protocol. That would be checking the validity. And then, even if you have 10 chains, maybe there's 8 of them are valid and 2 of them are invalid, you still have to decide which one is the canonical chain. So a fork choice rule will take 2 potential chains, A and B, and it will return either chain A or chain B, depending on which one it prefers. And if you go through all possible chains that are presented to you from the network with this connectivity assumption, assuming that you're connected to the internet, you should have, by the end of it, the preferred chain out of the whole list will be the canonical chain. And so how this plays into the cost function is that there's this thing, I don't really know what we should call it, but maybe we can call it like security units. Once you have this data, and you're able to, and you know what the canonical chain is, now you can actually statically analyze that binary, and you can determine what would be the security units that it would take if someone had these security units in an abstract sense. Could they commit fraud into the system? So let's go through a concrete example of this. So what we're talking about, Bitcoin, it's proof of work. So there's a certain hash rate, and like a hash rate would be a unit, perhaps. And if you had enough hash rate, you could do a 51% attack. And now, in and of itself, that's not actually that useful, because how do you know like how hard it is to do that hash rate? Maybe you can use your laptop or something and commit fraud. There's another assumption that goes along with this assumption that you have access to the open internet, and that's access to market data. And this is not built into the protocol, so it can be kind of counterintuitive, but this is actually really key to properly utilizing blockchains. And so with this market data, basically what you want is the cost of the hash power. So in this case, essentially, I don't actually know how people really calculate this, but I assume it's basically like the electricity costs and maybe something to do with like hardware. But there is a way that you can model the cost of getting the hash rate that you need to commit fraud. And from that, this is what you would have as the cost function. And you can now say, based on this statement that I'm verifying, how expensive would it be to commit fraud in this case? And then now I can determine, based on the circumstances for my application, how I want to interpret what is on the blockchain. And then of course, like, who uses proof of work anymore, I guess, right? So, I mean, proof of stake is exactly the same thing. It's like you have your tokens that can be slashed, and there's a price of a token. You have access to market data. You can do the same exact thing. It works the same way. And so I'm not going to go into this connectivity assumptions, but I do think that this is one area that really does trip people up, because there is an assumption when you're using blockchains that you have access to the open internet, and if you don't, actually a lot of things break down. I think when a lot of people think about it, they just look internally into how the protocol works, and sometimes not all the answers are there. And so that might be a disconnect why some people don't understand the value prop of crypto. But I'm not going to go into this because we just don't have time. But I do want to talk a little bit more about selecting the canonical chain, just to be a little bit more clear about how this works. Essentially, you're getting all the chains, this is the pseudocode. You're filtering out the valid ones, so now you have a list of valid chains, and now you're just literally running a reduce of the fork choice rule on all the valid chains. But what's interesting is you can actually collapse this down, and you can combine validity into the fork choice rule itself. And it would look something along these lines, where instead of a function that takes A and B as an input and returns either A or B, depending on which one is preferred, you also can return like a nil value if both chains are not valid. So you're just both basically checking the validity at the same time as determining what is your preferred fork. And so this is actually, I would argue, like the most concise abstraction on for how a blockchain, like what is a blockchain? Like all this other stuff is implementation details. Like, are you using proof of work or proof of stake? Do you have like Merkle trees? Like a lot of these things are like just it's to achieve this, but this is the actual conceptual like the essence of what we're actually working with here. And but the thing is, though, is again, I want to reiterate that the fork choice rule by itself is not really useful, because you say, okay, this is the valid chain, but like, what's the implication of that, right? You need to have what I call this like broader thing, which is like this cost function, to understand how, like, what does it mean? Like when you find data in this chain, what is the what kind of guarantees can you expect from it, and like how expensive would it be? Like how much can you trust this data, essentially? So I want to now build up from Bitcoin to modular blockchains so we can see how this all ties together. So Bitcoin had two problems, and I want to focus mostly on this first one. And essentially, the problem with Bitcoin is that it's hard to engage in commerce with Bitcoin. And one reason for that is, of course, you have to get a bunch of people to get Bitcoin wallets. You have to get businesses to put their payroll or their point of sale system on Bitcoin. That's all very hard, and we've made very little progress on doing that. But there's also kind of a more fundamental reason why it's hard, and that's because it's really hard to bridge on-chain and off-chain events. And like the people working in real world assets and like dealing with oracles and stuff, they face this all the time. And I won't go into because we just don't have time, I won't go into the theoretical reasons why, but I think there are some interesting things for why this is true. But I'll give you an example to make this more concrete. So like this was the example we went, so like someone was gonna sell their kidney or something, and this person claimed to send them 5 Bitcoin, but really did not. And they were able to not trust that because they could calculate whether that it was likely that they could be profiting by committing fraud in this scenario. Now, this works in this narrowly defined scope of saying, I sent you 5 Bitcoin. In because essentially like that's what the Bitcoin app does. It's a payments app, and so the cost function can let you verify that the cost of how much it takes to commit fraud in this case, but it can't do other things. Like, for example, if they claim to have provided the service, you wouldn't be able to verify that that actually happened. You'd have to introduce some sort of oracle, and then that introduces additional risk into the system. And all this kind of risk, the more risk that you introduce into the system, the more you have to have a margin of error on anything that you're calculating. And eventually, if you have enough error, that's going to all compound, and it's going to be a useless value. So you want to constrain any of those things. You want to have as much to be directly verifiable by the cost function as possible. And so there is a way that Bitcoin could have addressed this and expanded the functionality if they wanted to. And I'm not saying that they should have. I'm just saying they could have. And the way to do this would be to hard fork and add more opcodes and increase the power of their scripting to do the other things to do other things that people want to do. And the more things that you'd want to do, the more different types of statements you'd be able to verify with this cost function and understand understand the context around how expensive it would be to commit fraud in these scenarios. And but they didn't do this. And why did they not do this? I think this is a really important point. I actually think it's exactly what you would expect. So there's this thing called Brooks' Law, and it talks about how you add engineers to a project, and it makes it harder to actually complete the project. Because essentially, as you add more people, the lines of communication increase combinatorially. So what this means is, as you add more people to a group, the communication overhead gets way more and more and more difficult. And the implication of this is, at a global scale, you really can't coordinate. It's not possible. It's prohibitive. And that's why these permissionless networks are really great, because you actually don't have to coordinate. And I'm not going to go into this, but I do want to say, like, just this idea that that blockchains allow people to reach consensus, I think is not a good way at all of looking at it. I think blockchains allow people to verify things and calculate the probability of fraud, but they actually work because you can't come to consensus. Like, for example, a 51% attack or a 66% attack, like, these would require consensus among the participants of the network. And the fact that those don't happen, because that's very hard and very expensive, is the reason that this works. So we're actually playing off the fact that you can't reach consensus. It's kind of it's maybe not important, but I just thought it was worth mentioning. And so essentially, it makes sense that Bitcoin wouldn't be able to upgrade, because everyone's verifying their own thing independently for their own purpose, and you'd have to get the people sending it to upgrade and the people receiving it to upgrade, because you want to be sending what someone's trying to receive and receiving what someone's trying to send, and it's very hard to do. So Ethereum actually fixed this problem, though, because what they did is they modularized the application logic of Bitcoin. And so if you remember, I'm not going to go back a bunch of slides, but I had this diagram where it showed that the cost function, or where the canonical chain is determined by the validity rules and the fork choice rule. Well, essentially what Ethereum did is they modularized the validity rules. And so you're able to essentially do something like this, which is where you can make a statement like, I did X according to module Y. And that module Y would be a modular validity rule set that can be loaded all into the same blockchain. But the thing is since this is modular, you don't actually have to fork the network and breach consensus with the entire developer community and all the users that are verifying the chain. So this allows people to build this stuff and use it in a modular context without the coordination overhead. So allowing you to not just have a modular validity set, or validity rules, but also a modular fork choice rule. So you're able to define, so like if you think about like a rollup on Celestia, for example, essentially that rollup has its own fork choice rule with its own validity rules and its own fork choice, but it also uses Celestia's fork choice rule as an input. So it's not just a function that takes A or B, it's a higher order function that takes A, B, and another function, which is a fork choice rule. And so in this kind of way, you're able to you're able to import the verification capabilities of other chains into your chain, and that's what a rollup essentially is in its essence. And so this allows you to express a greater number of things that can be verified, and you can understand the cost of fraud in these systems. And so I'll just kind of go through this little three-dimensional diagram. Like initially we had like an app chain, which was Bitcoin, and you could just basically have different wallets, and they're just verifying these very narrowly useful statements, which is I sent you this many Bitcoins. Then we had Ethereum that would allow for dApps, and this had so many more use cases like NFTs and DeFi and stuff like this, and there's a lot you can do with this. But now what we're going to have is, with modular blockchains, we just kind of added this other dimension here. Since you can customize the full fork choice rule, you're actually able to even do more interesting types of things. Like for example, you can customize, you can like decrease the level of security, and so but you can increase like performance as a result, and you can verify things you have more customizability in actually setting the parameters for for detecting fraud in the use case that you are actually building for as an app developer. And so, yeah, I think that's my time. So this is like a great place. The conclusion slide was here. So thank you, everybody. I appreciate you coming.
Thank you, Liam. That was Liam. Next up is Andres. Ah, there we go, the pointer. From Range, and you'll be telling us something, I think, tacking onto this on security of modular chains. There you go.
Hi, everyone. I'm Andres Monti, co-founder of Range. And today we are going to talk about sovereignty and security, and also how app-specific rollups can be the answer to the security problem in crypto. So I have a couple of questions before I start talking. And yeah, here for you, which is who in the area, in the room, thinks that Ethereum would fork if the staking deposit contract would get wiped out and all the ETH was stolen? Like, raise your hands if you think would have another DAO fork, contentious fork. Okay, who thinks it wouldn't? Okay, maybe we have like 75% that we would fork. Who thinks here that if Lido, all the TVL of Lido, all the ETH, which I'm not sure if it's between 10 and 20% of the ETH supply, got hacked, who thinks here we would fork as with the DAO fork? No one. Okay, that's interesting. So then, like, if all the TVL of MakerDAO got hacked, nobody here thinks that we would fork, right? Okay, that's interesting. We'll come back to these questions later. But yeah, like, let's start kind of stepping back and understanding what's the level of security in crypto. We are doing not fine. In 2022, more than $3 billion were affected. Some of these were recouped, but definitely, like, we are not doing fine. This is a huge number, and I always try to make analogies with kind of more real-world numbers. So this is, I think, almost 20%, like $3 billion, almost 20% of the annual defense budget of my home country in the European Union. So we are talking about very, very big numbers, right? And I think everyone in this room agrees that security is important. I would go even farther. I would say that, I mean, I'm biased, but I think that is the key unsolved problem in crypto for mainstream adoption. It's great that we are working on solving scalability. It's great that some people are looking for product market fit, but security, like, nothing of that matters if we don't solve security. A good example is Axie Infinity. Axie Infinity, like, was the product that kind of crossed the chasm, right? Like, and was more like mainstream adopted, like very adopted in Philippines. But then at some point, like, the running breach was hacked for more than $500 million. And, you know, all the users, all the mainstream users that were using, like, Axie probably are not coming back because they got wrecked, right? And so I would like to ask you here if we are ready to build, like, secure modular blockchains, and if we are ready for thousands of rollups or tens of thousands of rollups kind of talking to each other. Yeah, I come from the security background, so I have, like, you know, we have certainly some challenges, what I call modular nightmares. So, like, modularity implies that there is more external dependency. So we have like a sort of like a supply chain risk for the counterparties that we are kind of integrating our modular stack. we're also like using cutting-edge tech, right? Like Rollups, zero knowledge. Like this is like super cool technology, but it's mostly not battle tested in production yet. And then as well, you know, like this world of many rollups and blockchains implies that we are, like bridges are not going anywhere and cross-chain is not going anywhere. And bridges are complex, bridges are hard. So, I mean, we should understand as well that not all bridges are created equal. And I think like as a community, and in particular, this sector of the crypto community has done a lot of progress moving from centralized to trust minimized and trustless bridges. So this is great. But the reality is that most exploits that we've seen, and we've seen in 2022, more than $2.5 billion, were actually due to implementation flaws. So in this infographic, you can see, well, the yellow bars correspond to like poor designs. So this means like, for example, the case of Ronin and Harmony, yes, key compromise on multi-sig bridges, but all the green bars are actually implementation flaws. So the point here is it doesn't matter how sound and robust your bridge protocol is, doesn't matter if you are using like a trustless bridge, trust minimized, like IBC, or even like a canonical bridge between Ethereum main chain and an L2, there can always be an implementation flaw. So I think as a community, and I think this happens already in Web 2, we need to internalize this statement. There will be always yet another software bug, so we kind of need to work on controlling the blast radius of these incidents. And particularly when we talk about bridges and rollups that are very complex software projects, which, you know, like complexity means a larger attack surface and a more error-prone type of code bases. But not everything is dark. I think like modularity is kind of bringing a new paradigm with all these challenges that I've been talking about, but also like a lot of opportunities. And I think like the opportunities definitely outweigh the challenges. And I genuinely believe that app-specific sovereign rollups might be the only possible way actually to build truly secure blockchains. And this is not talking about like 5 years, 10 years from now, right? Like the future is now. Like projects like Celestia are going to enable very soon that, you know, there will be thousands or tens of thousands of rollups, sovereign app-specific rollups talking to each other, and that every application is going to have its own rollup. And also like kind of aligned with this beautiful vision of like community computers where all the stakeholders are aligned. So in this world, sovereignty rules. And for this, I always like to use this analogy of seeing blockchains as countries and seeing bridges as sort of like international treaties or international relationships between these countries or blockchains. We are going to talk about these three things in this context. So blockchain jurisdictions, borders and trade control, and separation of powers. Who knows about like the BSC hack here? So this is a very interesting exploit. It was almost the biggest exploit in the history of crypto. I think it was around like $500 million hacked. But the most interesting thing about this is that the Binance validators, let's say, the Binance validators were able to pause the chain and hold the chain very quick to control the blast radius. So like the hacker was only able to get only, in quotes, $100 million out of the chain. So was able to breach out $100 million, but all the $400 million that remain within the blockchain jurisdiction, which is the BSC chain, were able to be recouped and recovered. So this is a very, very interesting example. There is this another one, which is, this is not security related, but it's also like a proof of the power of social consensus. So the blockchain community decided to confiscate tokens from a whale address that had received more than the community thought was okay in an airdrop that was flawlessly designed. And then this was through community governance, and they actually confiscated the funds. And of course, the DAO fork, which I would say is top 3 in terms of importance of events in the history of crypto. This happened a long time ago, like 7 years, which in crypto years is almost 50 years ago. But it's also like a kind of the importance of social consensus. So also like regarding the DAO, I would also like to question ourselves, how would this happen if Ethereum back then was connected with different bridges? So like if the DAO hacker was able to breach out part of the ETH, or if there were stable coins that were already like in this primitive Ethereum chain, right? So with these three examples, what we see is the importance of social consensus and blockchain jurisdictions, but also that the power of these jurisdictions starts and ends in the bridge. And this is specifically clear in the case of the Binance hack. And this, like the importance of the bridge bring us to this part. Some of these things are going to be a bit controversial, but yeah, like I think it's worth it to explore them. So the importance of the border in blockchain context and trade control. So I would say, let's build a wall, or at least let's explore if we should build a wall. Of course, this is not a political statement, but I think that we should explore how, like bridging works. Right now, bridging is binary, right? It's either we connect to a chain or we don't. I think like this is very primitive, and we should explore ways to parameterize this, to make this more granular, with mechanisms like rate limits, transaction delays, like the wormhole governor has implemented, and as well like with transaction screening and blocking. I'm not talking about theory here. Like there are many applications, Cosmos chains, that already do this type of blocking with blacklists. There is thousands of DeFi applications that do this as well, but this is not explicit, and that's why you need to pause the change and hold the chain because you don't have this type of mechanisms in place. I would also like to talk about IBC rate limits. I think this is a super powerful primitive. What I think is that it's the first governance configurable rate limited standard this is in production for bridging fungible tokens over IBC. And this is super important because it doesn't only cover you if IBC implementation is actually exploited, but it also protects you as a community, as a chain, or as a rollup if the source chain is exploited. So in the case of Binance, if we had rate limits in place, this attacker wouldn't have been able to get $100 million, but maybe $5 or $10 million, and also like the Binance validator set wouldn't have needed to pause and hold the chain. And also more importantly, it also protects if the destination chain is exploited. So like it gives community like sovereign rollups and blockchains as well sovereignty over how much you trust your counterparties. So there might be the case that you want to bridge with a new fancy blockchain, but you don't really trust their technology yet or their economic security. So the rate limits enable you to parameterize this and kind of position yourself in this trade-off space between security and liquidity. And this is just the present. I think IBC rate limits in the future are going to be like very different, much more complex and much more dynamic and powerful. For example, extending beyond fungible token transfers, but also like being able to dynamically adjust to events that happen on chain. So something that would be very cool is that if rate limits could be integrated with on-chain events like upgrades. So if a chain upgrades, you can define like a small rate limit because upgrades are normally error prone. And then as you get more confidence on the new version, you can gradually increase the rate limit. And then the last one is separation of powers. I think this really encapsulates very well like the power of modularity, the ability that you can kind of specialize every layer of the stack and build like customized mechanisms. In our case, build customized security mechanisms across all the layers of the stack. Something that I think can be super cool. I know that other teams are working on this, which are modular mempools. This is something, it's a concept that we've seen already in the wild. Cosmos chains like Terra define like mempools that have prioritization for different transactions. So for example, Oracle transactions are going to be always at the beginning of the block. And I think like this can be super powerful in the modular context, a modular paradigm, because we can really customize this combined like with app-specific sovereign rollups and really make this super powerful combining with security mechanisms, customized for the given application. This is the case, for example, for circuit breakers. So we could see a future where circuit breakers are totally adapted to like the app-specific rollup functionality and also have more priority in the mempool. So then we can make sure that all security-related transactions get put at the beginning of every block. And this is really like the future we are building at Range. So we are providing the tools for blockchains, for sovereign rollups in both the Cosmos and Celestia ecosystem to express their sovereignty and also the security. And how are we doing this? So we are integrating off-chain monitoring systems, and on-chain mitigation techniques like rate limits, circuit breakers, and more. And also we put a lot of focus on bridges. As we discussed in the call, we see bridges as the border, and this we should put a lot of security in the border, right? So we are building security mechanisms, security middleware around trustless bridges like IBC. And yeah, like as a little surprise, we have integrated Mocha in Rates testnet. So yeah, from tomorrow, from the second day of the Modular Summit, you'll be able to tinker with and start monitoring addresses, transactions, and messages in Mocha from the Range community app. And yeah, that's all. Join us at range.org. I'm AS Monty on Twitter, and I'm always super down to discuss all these topics. Some of them are controversial, some of them are less controversial, but I'm always super down to discuss this in Twitter and also in the conference. I think that we have a bit of time for Q&A. So if you guys have any question, or if you would like to, like come back to any of the slides, also happy to do that. Thank you. So we have 5 minutes. So if does anyone have a question?
No questions.
What's your answer on whether it would be forked right now or not?
Yeah, that's a good one. I definitely believe like if the staking deposit contract is hacked and all the ETH is wiped out, we definitely fork. I think that if Lido gets hacked and all the ETH gets wiped out, I think we would probably fork. Like I think like the room, only like 25% of you said that, or almost no one. I think it would. It's a meaningful percentage of the supply of ETH. There is a lot of, quite important stakeholders as well. So yeah, I think like there is like a more than 50% chance that it would. With Maker, I don't think it would. And that's, if I were Maker though, an application like that, and kind of tying back with the rest of the talk, you have a TVL of, I don't know what MakerDAO has in TVL, but maybe like $10 million. I'm not sure exactly. But I should ask myself as a community that I have like a TVL of $10 billion, but then I don't have the ability and the power with social consensus to be able to do this type of decisions, right? So you are handling a lot of money, but you don't even have like the power like to decide these type of things. And that's why app-specific sovereign rollups are so important and so like powerful in the future for security, because each application, imagine like this MakerDAO app-specific sovereign rollup would be definitely like able to decide like a fork if all the like ETH or all their TVL were affected in the hack. So that's kind of like really the connection, and why like teams like MakerDAO and others should definitely like consider launching a sovereign rollup with Celestia. Yeah.
All more questions?
Yeah.
All good.
Perfect.
All right. Thank you, Andres. Give him one more hand. Next up, I think we can save a few minutes here and there. So Bunny, if you want to come to the stage. Bunny is building Dora, a search engine / explorer for the modular ecosystem. This is your, there you go, the big green button. So okay. Give him a big hand.
Hello. Hi, everyone. My name is, actually, I'll say my real name, Mauricio Trujillo, and also known as Bunny or Conejo Capital on Twitter. We're building a multi-chain search engine. A block explorer is Caldera, and also thank you everyone for being here right now. Name of the talk, what we search for. Search engines in an era of modular existence. So first of all, what does this mean? How can Dora actually help with any of this? What does it, there you go. How can we actually use the search engine approach to approach, let's say, some stuff that have been talked about already, modular applications, being able to actually interact with specific chains, and also how do people actually, even to begin with, how do we approach infrastructure today? What are the different heuristics that we interact with? Some of the ones that we were already talked about, application specific, rollups, and so on and so forth, intents aggregators, multi-ecosystem type of application. Then search data, how do people actually relate to all of these goods and services day to day? How people start searching, let's say, through brands instead of searching for very clearly defined queries to engage with a good and service. Then externally branded monolithic chains as opposed to internally branded modular apps that may leverage infrastructure that is embedded exclusively, that is very opinionated as to what they may enable. And as well as, hey, how do we ultimately end up engaging with all of this? So first of all, I see a little story. So Jazz and Jacob, also from the Celestia team, approached me. They're like, hey, Bunny, can you actually speak at the at Modular Summit? I'm like, yeah, I'm more than happy to. Always ready to speak whenever someone asks me to. So one of the first things that I go is like, okay, I have no idea what people are going to be talking about Modular Summit or then modularity in the overarching sense of the word. So what do? I start searching. How do people actually start searching in their day-to-day lives? People start searching on their day-to-day lives in, let's say, at least within crypto. We've somehow stumbled upon the semblance of having intents. Intents meaning whatever your definition of it may be, as it being bounds on the end state of an action on the state change, constraints on the state change, or also, as Vlad said, something along the lines of they are a glimpse into your deepest desire, the deepest desires of someone's brain. No matter your definition of intents, they are something that we can all clearly agree expresses something as simple as I want to do X, and that's it. So how are intents able to leverage stuff like DeFi, gaming, NFTs, and identity-specific applications? They're able to leverage all of these because they don't necessarily make any concrete differentiator between them. They may not necessarily measure different security assumptions. All they really care about, and that is the nature of intents, is that your end interaction gets fulfilled, and that's it. What type of world do we build with all of this type of infrastructure? The type of world that we build is one in which composability is pretty much unquestionable, and we end up in a world in which we have an any-to-any type of relationship between goods and services, in which no matter what resources you have currently available, there will always be infrastructure that allows you to partake on any good and service you may wish so. How are we actually able to enable this? We have some multi-ecosystem infrastructure. This is honestly one of my preferred stacks. We have some of the people in the room from those logos there. You may recognize a couple of people from Caldera, Modular Cloud, Squid, Skip, routing mechanisms, rollup as a service, indexing mechanisms. They are all and of course, intents. They're all very much needed to be able to enable this type of workflow that people are very used to in the regular world. That regular world meaning outside of crypto. But is that how people really relate to? Sorry, is there a button to go back? This one? Sorry, thank you. How do people actually relate to all of these goods and services within crypto, and how do people relate to all of these outside of it? It's very clear. There's a point in which every single crypto app starts pretty much looking like each other. We call this effect recognizing patterns where there may not be any pareidolia. There's a pareidolia of the apps in which people start seeing stuff like NFT marketplaces on Uniswap. People start seeing swapping mechanisms within NFT marketplaces. People start seeing options where there may not necessarily be a need or a desire for someone to actually start leveraging options. So what we find is that all of these goods and services eventually become commoditized. Something very fascinating, though, is that while the goods and services may be commoditized, the providers are non-fungible. Every other provider will be selling you the exact same thing, but in a much different type of delivery packaging that some people may be used to. And that's actually good. That's very good, actually. So how do people outside of crypto relate to searching intents and fulfilling of any desires they may have? Where can we actually look at something like this? We can look at search data, which is honestly one of the most valuable data in the world, in my opinion. People don't necessarily look for goods and services in a very clearly defined query. They actually, if you look at the top 100 searches on Google or even across search engines, especially if you start very heavily localizing, people relate to goods and services through brands. they don't necessarily, it is very rare that actually something as concrete that is not brand heavy makes it to the top 100 searches. It's usually just related to like World Cup events, and even then you could argue that, okay, there are events, there are sports. So we have brands as a proxy for actions. We have Antimaria, in which the verification of nouns, not the announced NFT, of course, but where we get to is that we have these the first and second degrees of Antimaria. Where a lot of infrastructure is currently laying on is that we have ways in which you have protocols like, not necessarily protocol, an action at this point, emailing. People feel very comfortable saying, hey, email me, just send me a message. They don't necessarily specify which provider they may be engaging with, and that's completely fine. Another way of using, is not exactly protocol, but something akin to being able to emit a message, Twitter. People feel very comfortable using the anti-numeric word tweeted. This very easily allows us to convey, hey, I want you to express an opinion, I want you to tell that opinion to the world. People feel very easy doing that. So if this is how people search, okay, we understand that brands are very important. We understand that maybe it's actually good to have branding around certain applications, maybe certain chains, but is it enough? There's this concept of branding, externally branding your monolithic chain. In this sense, meaning that if you have an, let's say, a forked EVM chain is just done, it's the exact same thing as an EVM, but you just so happen to have an NFT marketplace in that chain, and that's all that you really do there. It's not necessarily optimized for NFTs. It's just a chain that has an NFT smart contract, and that's completely fine. That's pretty good for most people. Where we very much like to push for, though, is that we want people to be incredibly opinionated about the infrastructure that they leverage for their specific use case. In this sense, what we're actually pushing for is app chains. We believe that very tired approach will be to create brands around a generalizable chains applications, whereas what we should be aiming for, and forgive me, there's a typo there, is to create infrastructure around such chains-specific applications. In this sense, if your application, let's say very, very high-frequency trading specific application should have the shortest finality time and shouldn't be contested, maybe something like IBC should be considered. Maybe something that, I don't know, the YDX is a very clear example of that. Maybe there's applications in which you should rely more on social consensus as opposed to some very, very clearly defined cryptographic security mechanisms. Who knows? We can play around with this. The ethos of modularism is very much of build anything, and we strongly believe that if we should build anything, why shouldn't we actually build this in a way that we can actually start iterating on goods and services on monolithic ecosystems, which is precisely what we've seen, and then actually go into production and optimize for service providers, for different service providers' economic incentives on something like a modular stack. In this sense, one of these examples that is actually a paper that should be getting published either today or tomorrow by Tarun Chitra is in how sequencing and you can model pretty much every single DeFi app as a sequencing of liquidations. In that sense, if you start considering that sequence, then ordering becomes wholly incredibly important, and you can start arguing for the certain sequencing of of certain chains should be the most theoretically optimal for this specific DeFi application. That is a fascinating concept. I think it's very interesting to say every single application that is deployed on this chain will not have a competitive edge against this one DeFi application. That's fascinating. So now every single app is a chain. How do we actually go about searching every single one of these applications? How do we actually go about engaging with every single one of these providers once every single one of these providers starts looking the same, or hopefully they don't, and once every single one of these providers is able to leverage their specific infrastructure that makes their ecosystems blossom as much as almost theoretically no one else can. What we do at Dora is we like to take the approach of a generalized search engines. We very much believe that power users will end up engaging with topic-specific aggregators. We're all in Paris right now. I don't know how many people in the room are based out of Paris or even France or Europe in general, but I will bet that most of you ended up using at some point either something like an airline aggregator, maybe at first we started engaging when we first got into the industry. We're like, oh, I'm going to my first conference. I want to see what I can use for traveling. If we were in very experienced travelers before, we probably use something like Google. Then in the end, we of course narrow down into, okay, I want to use my Expedia. I don't know. There's plenty. I just use Expedia because it's very convenient. But what we see for an appropriate ecosystem that lends itself to being mass adopted is that users will engage with the most generalizable, meaning the one that is able to capture the most providers, has the most coverage, friendly, quite simply, just being able to understand it from the get-go. I thought it was fascinating. It was insane the first time I got into a plane. I was like, wow, how do people actually get this? And my parents told me, oh, you just go on the internet, and I was blown away by that. And provider-acknowledged search engines. If we believe that every single one of these brands is actually incredibly meaningful to the experience of a user actually engaging with these goods and services, search engines should be incredibly intentional as to what brands they're leveraging in order to provide all these services. What we do at Dora is, we have a couple examples of it actually. What we do at Dora is we try to be incredibly intentional as to, hey, these are the specific tokens that you're swapping. These, if we click on, let's say, the crypto.com to the transaction there, and you're swapping USDC, we tell you that this USDC is being provided by Circle. If you click on every single one of the smart contracts, we try to make it abundantly clear what types of organizations these smart contracts are associated to. That way, hopefully giving people their assurance of, hey, you don't necessarily even have to trust Dora, right? Whereas search engines, there's a very funny thought experiment that maybe the chain is dead and the block explorers have just been producing information for you. That could be true. Block explorers could be lying to you. But still, we don't want people to trust us. What we want is people to trust brands. That is who they seem to trust right now. That is who people, I mean, Celestia is also a brand. We seem to trust them to figure out modularism. They're doing an amazing job at it. So therefore, why should we actually change the way people just behave and think right now? And thank you so much. Love you all. Thank you for coming here. Thanks. If anyone has any questions as well, more than happy to. Yeah. If anyone has specific questions as to how our stack works as well, because it is infrastructure day as well, more than happy to dive a little bit more into that.
Yeah, feel free.
We actually, I think block explorers are actually really interesting on that, because we haven't found a world in which we needed to rely that heavily into our own proprietary technology up until recently. There was very much a rundown to the bottom on stuff like indexing within EVM chains. That was something that we found as, there were a plenty of providers that ended up showing up. There's been a rundown to the bottom as to how to actually go about indexing it. I think we've done a fairly wonderful job at it. Not only us, but also some of our close partners, Goldsky Simple Hash. I think it is an interesting question as to see what are we going to see a rundown to the bottom of indexing approaches on a modular ecosystem. I think that is honestly quintessential to be able to even begin to fathom whether or not we're going to be able to let these ecosystems blossom. Yeah, I think there's a couple really good teams doing amazing work at that. I think Modular Cloud is one of those teams. So let's see how we can make these ecosystems be better than everyone else.
Thank you, Bunny. Yeah, we're a few minutes ahead of time, so I don't know, looking at the panelists, I guess, whether you want to jump on stage already? You're ready to continue? All right, next up is the panel on developer infrastructure. We've got, again, Bunny. Jordan, you want to come to the stage from Astria? Celestia representative Josh. LZRS again from Modular Cloud. And then Steffi from Masari is going to be moderating the panel. Are there enough chairs to sit down? Oh, there's one more. No. There are plenty of chairs.
I'll take this side.
All right, so please give them a hand.
Testing's on, yeah. Well, Hey guys, thanks so much for being here today. I'm super excited to talk about developer infrastructure in the modular context. You want to get us started by introducing yourself and about what you're building and your protocols?
I guess I have the microphone, so I'll go first. Hi, I'm LZRS. I'm the founder of Modular Cloud. So we're building cloud services for modular blockchains. And our first product is a block explorer. It's one of the things that we do. We have definitely a very different approach to Dora, and we actually work with Dora, and we're very good friends. But what we do is we index DA layers, L1s, as well as the rollups that are on top of them. And there's a lot of really interesting implications to doing this, and a lot of different architectural decisions that we make as a blockchain cloud company that differs from ones that were previously servicing monolithic chains. So I'm excited to dive into this more on this panel.
Hi, I'm Josh, and I'm a solutions engineer at Celestia Labs. And we're building Celestia, which is a layer 1 data availability and consensus, layer 1 blockchain. And the goal of what we're building is to make it as easy for people to deploy a blockchain as it currently is to deploy a smart contract. So yeah, really excited to talk about infrastructure for developers today.
I'm Jordan. I'm the CTO co-founder of Astria. Astria, we're building a modular shared sequencing chain built on top of Celestia right now using modern DA. The goal of what we're building here is to make it such that when you make deploying a rollup as easy as deploying a smart contract, that it can also be done in such a way that it's decentralized. Today, the L2s and whatnot that people are familiar with using all use centralized sequencers, and so we're trying to change that and hopefully create a better future for us in that regard.
Hello, again. My name is Bunny, also Mauricio Trujillo, whichever is fine. I'm building a multi-chain search engine called Dora as LCRS or LSZRS. We work very closely with them. They're building a block explorer, a modular block explorer, a modular indexer, or also a rollup-aware indexer. Many names for it. We're building a multi-chain search engine. We very much like to, we made some interesting infrastructural decisions, let's say, as well, in order to be able to support this type of modular infrastructure. We're very happy to talk about it. A lot of that is just pretty much relies on very heavy collaboration amongst all of these very composable infrastructure.
So I think a common theme that all of you guys talked about and just building modular in general is how do we make it simpler to build blockchains or rollups for teams, right? But at the same time, you have to interact with a bunch of different layers, a bunch of different piece together a bunch of things you might not have had to before. So I guess my first question is generally, how do you think that developer infrastructure and tooling can support making things easier for developers, and perhaps if you feel as though developers that are thinking of building modular are a little bit intimidated, in doing so, and what can be done to support them?
Is that for me?
It's for everyone. We can. Okay. I'll take turns.
Yeah, I think that this is actually a very difficult problem in engineering, but I don't think that it's specific to modular blockchains. I think the general problem is, and this is something that we face building an indexer and a block explorer, is imagine you have 1,000 different chains. These are all going to be built slightly differently, and there's going to be nuances in the details of each one of these systems that you can't create a common abstraction on. You can't necessarily, for example, make an abstract block schema that you build your application on, and you can do that, but you're not going to have the depth that every single protocol, you're not going to be able to go in, you're going to lose resolution on the data. So this is a hard thing, and I don't think that it's necessarily a bad thing that we're facing this, but we definitely need to be making the right engineering trade-offs when we're building tools. So the way we think about it is there's kind of a spectrum whenever you're, as an engineer, when you're designing something, you're going to have two engineers in a room, and one of them is going to say, let's over-engineer this, let's make this super generalizable so we can upgrade it later, it's going to be very easy. And on the other end of the spectrum, there's going to be an engineer who's saying, wait, no, this is the requirements for the customer, so let's just build exactly what they need. And I think as tool developers and infrastructure developers in the space, we need to go way more towards that flexible side so that we can make our tools very adaptable. And so the tack that we're taking at Modular Cloud is we're really focused on acknowledging that we can't generalize across all protocols, but what we can do is we can make the developer experience of creating an integration, which needs to be done manually, but we can make that developer experience as easy as possible.
Yeah.
I was just going to say that I think that, you know, we talk about this in the context sometimes of modular blockchains, but I think it's really a like whole crypto blockchain space problem where, you know, my background is like more Web 2 and big tech. And the reality of, you know, someone in that world trying to get into this space is that there's a huge headroom to just jump in, you know. If you're and you're a front-end dev and you say, I want to build an app and I want to try and use a blockchain, you're trying to figure out, like, how am I going to run a local blockchain? Or if I'm using Ethereum, am I going to pony up, you know, whatever, like $20 a transaction to dev test this application? There's all sorts of hiccups along the way and so much tooling along the way. It's very complex and it's a huge barrier to entry to actually get some of these ideas onboarded. So, you know, when we think about building in modular, we see it as an opportunity to kind of correct some of that to an extent, make it, you know, I hear lots of people I talk to like, well, isn't launching something modular like more complicated? And I was like, well, we get to have a more narrow space of what we're focused on, which means like we can really work on tailoring that experience and we can make it a lot better and easier to use. And then that breadth can grow as we go more and more specializations and there's more pieces in this space. Much like if you use, you know, like Google Cloud today, you don't really know how networking works. Like the fact that we're sitting here and like, if you want to be a smart contract developer building an app, you're like, I need to understand exactly how the core protocol works. Like that in my mind is an abstraction that we need to kind of move past in order to, and so building the tooling so that we can do that in the future is important.
Yeah, I was going to say pretty much along those lines. I think one of the biggest problems, well, you've pointed out, like it's not really a modular problem, it's more of a crypto problem in terms of like where the industry is at. I think the most complicated part that needs to be figured out in the next like 5-10 years is those sort of common APIs and interfaces that allow composability, but also like optionality for people to pick what they want to use. So I guess, for example, like a data availability interface that would be somewhat standard so that people can use different DA layers, but also use the same tooling. I think that's something like Rollkit is working on, for example. Dimension is another example. A Rollup as a service provider. They've packaged together both their Rollup SDK along with the Celestia Lite node. So instead of having to go and start each one of those manually, you can actually do it all in one in the command line interface. So I think things like that, some of them might last, some of them might not, but I think whatever the happy middle ground with all of that is the way that this is something that we can take to the Web 2 developers and be like, hey, do you want to try this out? It's actually fun, and it's not gonna, you know, you're not gonna spend your whole day trying to set up the Lite node or trying to start the rollup. So yeah, I think we have a long way to go, but it's really cool to see things like dimensions, like Rollup SDK, for example, like that actually exist already, and excited to see where that goes.
I'll keep it brief. I think, first of all, we very much relate to the point of trying to create a very good, somewhat abstract, generalizable schema. It is a novel approach. It's very hard. Someone in the room is some people in the room are very familiar with that. I think, but yeah, very much resonate and echoing the fact that it is a lot of trying to create packages, trying to create bundles, trying to create any semblance of, hey, we maybe figure out the best way to go about building a DeFi-specific app chain, NFT-specific app chain, DeFi-enable NFT app chain. You can leverage composability. I think it's a very wonderful thing once you are able to come into an ecosystem and come into an entire industry and say, hey, there's a lot of people that have done a lot of the groundwork for me already. I can just get extremely creative with whatever I want here.
Yeah, I totally agree with that as well. And I think, you know, the challenge then is on you guys, in developing your protocols to, make it easier and abstract that away so they don't have to think about it. So I guess a question for all of you again is, what are some of your biggest challenges in doing so? What are the biggest hurdles that you have to go through to be able to, make it simple for everybody else?
Things are always changing. And I think in the early stages of all this, we don't really know what the best way to do it is. So like speaking of like the DA interface with RollKit, for example, like we might have like a beta version of that, but at the same time, we don't know that that's the final version. So I think it's just I guess a factor of like where we are at in the life cycle of this modular ecosystem and crypto ecosystem as a whole.
Yeah, I mean, I'll definitely echo that. I think that the amount of attempts on goal is the key. So the cool thing about this, and like one thing, like for example, that Astria enables is for, it lowers the barrier of entry of having like a decentralized chain. So it used to be really hard to deploy a blockchain-based application, and now with Celestia, with shared security, and now shared sequencing and stuff like this, it makes it really easy. So from the perspective of people actually building applications, we're going to have so many more shots on goal on trying to find out that one thing that hits a zeitgeist like Bitcoin did. I mean, I think people don't realize, like when Bitcoin came out, like nobody thought that would be something that people would actually find valuable. But that application was very valuable, and that's why we're all here today, because everyone got inspired by this, we started trying to improve it, and now we're all here at the Modular Summit. And I think that's one thing that's going to happen. We're going to find out like the killer apps through making it easier to experiment. And we're also on the tooling side, also trying to build systems where we're basically right now, the approach we're taking at Modular Cloud is we're finding services and like APIs that people want. Like for example, people want NFT APIs for EVM rollups. So we have an NFT API. This is something that there's clear demand for, and we're trying to build a collection of these things. And then what we're doing is we're finding, we don't know what a generalized platform is. We don't know how the design should be for a generalized platform that can provide cloud services to all protocols. That's a really hard problem. But what we're doing is by making a bunch of attempts, we're finding out these general patterns, and we're discovering how these things should be built.
Yeah, I think I resonate a lot with the idea that like you need a lot of attempts, and I think that's one of the things that the modular space really enables. And one of the things that we think about trying to enable as a shared sequencer is launching these rollups and what's the likelihood that of the first two blockchains that like really became big, that those are like the final end state, and like enabling more iteration on what you can actually do. And it's I think that's really important. The difficult part is that if you want to be the base of that foundation, you have to make it such that people can actually innovate. And so I think there's a lot to what Josh said here of like, we're building things for the first time, and then like we're building things on top of things which are iterating pretty quickly. And there's a lot of interconnectedness in bootstrapping your own project. And so I think that one of the big things that we do internally is like just dog fooding what we do. It's, it's, hey, we have this, and it's like, cool, let's go build a roll up on top of it. Like you have to actually make sure that what you do, and it's not perfect. Dog fooding, we come with our own biases, and you try to work through that, and that's why you get product out to people and you get it in their hands, and you find out, and the same as any like iterative development approach, it's like, okay, what was wrong with it, and what can we do and learn from that?
Hello. Can you repeat the question again?
Oh yeah, I was just saying, like, what do you think are the biggest challenges for you, in your protocol, having to make things easier, for the user or the developer?
I think one of the biggest ones is honestly, again, to echo everything that everyone said in the room, but actually to give a very concrete example, we got a chance to, because we're building a multi-search engine, we got actually the chance to chat with a bunch of node operators throughout this week. It was a very enlightening, they were very enlightening chats, because we got to see how one of the very core entities on the stack is able to reason through whether or not to support a certain ecosystem. We all formed these very implicit types of equations, some more explicit than other, some not very large node operators have a very concrete equation that they use to actually figure out whether or not to support a certain ecosystem. Won't disclose which, but something interesting is that one of the very key components of that question is just how much is this ecosystem iterating on their nodes. Being able to actually tinker around with your nodes is something very powerful. It's something that you can get very incredibly complex with. I mean, there's nothing necessarily intrinsically wrong with it, but there is something where there is a point in which infrastructure providers really want to feel comfortable saying, okay, this is going to be the one version of the client that I'm going to be able to spin up 28 nodes per ecosystem, per chain, whatever, and I'm going to be able to provide industry-grade offerings on top of it. And yeah, that type of offering is just something that has presented to be a very insane straw for everyone. Like, yeah, like we might be able to standardize schemas and such, but still it's something as simple, quote unquote, simple as defining, okay, this is a node client can prove to be a very hard thing to do.
Totally. And I think going on to the idea about different, building in one ecosystem first and then perhaps moving to another, I think, some of you were starting with the Ethereum ecosystem, others more so in the Celestia ecosystem. I guess, why would you select one over the other? Like, why did you, if everyone wants to let me know, like, why you kind of went with one direction first? And if you feel there are times where it's just best to stick to one ecosystem and not try to integrate with all of them, like there's just a certain level at which it just becomes too complex.
Like, you want? Okay.
So I'd say a couple of honestly very practical things. I do tend to think a lot about infrastructure as being the byproduct of current economic incentives. In that sense, incentive alignment at this point is one in which let's say we do incentivize a plurality of validators within the Ethereum ecosystem. You run a validator on Ethereum, on the active set, you can get paid to be able to secure Ethereum. That's great. You run a full node, not so much. So from this standpoint, there's very much the approach of, hey, I like this technology. I find it very cool. I think it's very impressive. I think it's the most secure, the most optimized for whatever my use case is. That's great. Is it a viable economic solution long term? And that is not to be, let's say, incredibly cynical of a lot of really wonderful technology, but it is also just to say, hey, we do need to make infrastructure is only as sustainable as the economic mechanism holding it. So from that standpoint, that is something that we took very much into consideration. We looked at all the different ecosystems that were the ones that had the most just plain and simple demand. The most demand of people asking us, hey, can you build this? Can you build this sort of thing? I'll pay you right now. I need to get my hands on whatever you're building right now. And that is a very clear-cut example for it. However, we also know that we're in crypto. There's the ecosystems that are very, very wealthy and powerful still, and they may not lend themselves to give us as much flexibility as something that we can actually do within a modular ecosystem. So that is also why we decided to build on top of it. We very much think that people can get very creative with it, and there's nothing more powerful than very creative infrastructure.
I think, to that point on the economics of it all being important, I think I take a slightly different approach. I 100% agree, but I go down and I look at just kind of a first principles of like, okay, if I'm trying to build something scalable, right? We talk about like, oh, we want like actual useful applications in crypto. And one of the things I always say to that is like, okay, I used to work at a Web 2 startup and we had a database that had 2 terabytes of information. That's like 6 years of Ethereum data. So the question is like, okay, if we want to actually have these useful applications, we need like scalability at not like we need a huge multiple. And so coming from a first principles of that is like, okay, how would I build that? And that's, I think modular is just, if you're building software in the world, for the most part, if you want to scale, you end up going more modular. You have specific specializations of what you're working on. And so I think that's a part of why, I look at this space. And then to the point of the economics, it's like, okay, well, like Ethereum can also make these changes, and they're working on things that'll help with scalability availability, but it's a question of also just like velocity. You have all that economic security. It's all in this like one space, and you have all this liquidity. It's difficult to move. It's a financial product with a ton of money. It's like, how quickly are banks changing their banking systems, right? Like, it just doesn't happen that quickly. So if you want to actually be like, come in and challenge the incumbent and be like, hey, we offer something like better, I'm not going to do the exact same thing as what the incumbent is doing. I'm going to actually try and change a lot faster.
Yeah, so we first started off supporting Celestia. That was our first integration, and that's a Cosmos chain essentially. So when we launched our Block Explorer, we only supported Cosmos, and we've since added EVM support, and we do have proof of concepts of other VMs that are compatible with our infrastructure. But those are the two primary ones. I just think, like, on a practical level, if you support right now Cosmos and EVM for your tooling, I think you're going to have compatibility with a super majority of apps that people are using. So that's a really good starting point. But I think on a theoretical level, the reason why we started with Celestia is back to this point that we were talking about earlier about getting a lot of shots on goal. And essentially what is possible with, let's say that you have the Ethereum virtual machine and you want to improve it. If you wanted to contribute that upstream to actually the Ethereum network, as something I talked about in my talk earlier, coordinating with a large group is extremely hard. So that's a very difficult process. If you want to change that execution environment, it's very difficult to do so. And there's actually, if you look at a blockchain, there's actually a lot of things in the monolithic architecture that's all bundled together. And these things, they don't actually have to be. So what needs to be bundled, we need a lot of people to all provide security to the ordering of the data. And there's a strong network effect in that. And if you subdivide that into many different L1s, I'm not saying that there's not viable. I think it is very viable, and there's a lot of people who make great solutions for making L1s that are other than just the major top 10 chains. I think we're going to see even a lot more L1s, but it does, you have to admit that it does sacrifice security, and there is kind of like a economies of scale to security as well, and especially with data availability sampling. As you add an additional byte to the network, it's actually sublinear scaling, so it actually takes like log n steps of verification more per n bytes, and so there's actually a really great property of having an L1 that's just like dominant and that most people contribute to. But that network effect does not necessarily carry over to other parts of what the blockchain is. So in my talk, I talked about like the fork choice rule, and you can like, a rollup is basically defining this, and this is operating on another fork choice rule, which is like the L1. I gave this talk earlier today. And essentially being able to customize a lot of that stuff actually makes it possible to make a lot of improvements to the way that these systems work. And a lot of things in Ethereum were kind of just figuring it out as they went. And it's not necessarily like, I think someone had said earlier, like, just because, what are the odds that one of the first blockchains was optimally implemented? I think that there's a lot of improvement, but going through an upgrade path of actually convincing the community to take every single change necessary to get there is really difficult. And also, you really don't want to you don't want to experiment at all in one of those situations, because if you try a crazy idea and it destroys the network, you're going to nuke everyone's bags and we're all going to be unemployed. So we really don't want to do that. I think like what's cool about modular blockchains is you can have a bunch of rollups on top of an L1. This L1 has a giant network effect, but the actual implementations, you can have these all be permissionless. And what's kind of cool about this is it actually is a better way of building a blockchain than it has a really interesting predictivity scaling property where you can parallelize the iteration process, because all the different people that are trying to make different rollups are not needing to communicate with one another. And as a result, you can have a much, much higher speed of iteration. It's kind of like if you have like a distributed system and your application is not designed for that, you can't just add nodes. That's like trying to build something within the confines of a single project where you have to agree with everybody. You're going to have a lot of communication communication overhead between each person trying to put forth an idea. But if you have permissionless innovation, you can do everything asynchronously, and this can scale. You can scale the amount of innovation with the amount of people trying to innovate, because everyone can take their own bets. And I think that that is why I believe that the modular ecosystem is going to be where the dominant amount of innovation happens, and as a result, I think there's going to be a large amount of activity in the future on that, and that's why we took a strong bet entering this ecosystem very early.
I guess I'm a little biased here. I work for Celestia Labs, but I think the thing to take away for me is that like people building on top of Celestia and actually building on top of other DA layers. I forget the actual question, but I think the thing that the reason that I really like, yeah, what's the question? I know where I was going to go.
No, the question was just, why start out building in one ecosystem versus another, or
Cool.
maybe staying in one?
Yeah, so I'm definitely biased, but I guess the thing that I do have flexibility for, of my choice is what execution environment I'm using. So I think I just think in the grand long term, having standardization to some degree between those execution environments. As great as it would be to keep them in the Celestia ecosystem, I think that having the ability to connect with other DA layers that are building the same sort of consensus, shared consensus network, is something that can be really powerful.
All right, want to jump in a little more here into your specific protocols. I guess I'm going to start out with both Bunny and LZRS. You guys are both building block explorers or search engines. Would love to hear from you guys, how your approaches, differ, or also how they could be similar or additive to each other as well.
Yeah, I can go first on this. Yeah, I think they have a fantastic block explorer. Ours is, it has a very different angle. First of all, it's primarily for developers, and we are trying to build, we have an indexer that works with Rollups and lots of different chains, including DA layers, and we think of our block explorer as kind of like the web console for this. So this is you can log into AWS and set up your services and run computations in their cloud. And we think of our block explorer as just the web interface for our cloud. And it's also kind of a reference implementation. Since it is an open source block explorer, it's a reference implementation. So someone who wants to build a product with our cloud can look at how we use it, and they can just copy that exactly. And we would love for them to use our APIs, because that's how we make money. I guess the last but not least, I would just say that when we design it, our approach is that we are very developer focused, and because we're working mostly with long tail projects, things that there's not any users at all. So but no, it's true. The users are the companies that are developing it, and that's who we're talking to a lot. And so they're debugging things right now. This is the stage that they're at. And of course, are there users on any blockchain protocol? I mean, that's a question. But I'm sure there's hundreds. But yeah. No, but we're trying to make all the tools that developers need for building applications and debugging their protocols as they're building it live.
I can confirm there's users in other blockchains.
True.
Yeah, no. As long as the blocks are not empty, we're happy. Or even as long as there's people that need block explorers that are very. We used to use the phrase human readable quite a bit. I feel like over time now I've grown a little bit more detached from it. I think it's just more so from the standpoint is also a not so great word, trying to find a new one for it, but legible. From the standpoint that it's something that people can just understand. It's maybe friendly is the appropriate word for it. Something that you can feel it's approachable, something you can relate to, something that does not assume any single level of complexity from the user prior to knowing, oh, I don't know what is a swap, but everyone can understand what is a send and receiving, what is sending and what is someone is receiving in a swap or exchange transfer. Beyond that, a lot of our infrastructure is set up in such a way that we're able to actually leverage infrastructure like Modular Clouds to collaborate on, let's say, hey, you have a really wonderful indexer, can we get some of that data, right? Also, in the exact same way that, okay, going back to the economics of it all, we do believe that, let's say, if you're building critical infrastructure for a lot of these ecosystems, even whether or not they're long tail or like very much at the center of the bell curve, you should be still getting paid. You should still be a very sustainable project on your own right. I think we more so prioritize the fact that developer tooling can only take us so far in such a way that we can allow people to create. We can allow providers to create goods that people can start interacting with very easily. However, just developer infrastructure stops at the point in which, as soon as an end user starts trying to engage with your ecosystem, that is where you don't want to show someone, hey, here's the console, right? You very much want to create a product that someone else that knows very well how to use the console can then use a product like ours and say, hey, look, you just minted this, you just engage with this good, you just partook on this service, you just send money around the world, you were just able to bank yourself. Or even let's say something as communication, I actually didn't have a phone number for an entire year. And I think, yeah, very free, and I highly recommend it. But being able to leverage our infrastructure, let's say peer-to-peer messaging networks, I had no problem living around the world that way.
That's awesome. Might try that actually one day. Just not having a phone number.
It's great.
I had a couple more questions for you guys, but I think I'm going to move on just so we don't run out of time here. So sorry. Oh, I can keep. Oh, I have 5 more minutes. Yeah, one talk is dropping out. Oh, okay, perfect. All right. So great. So basically, the way I understand it, Bunny, you're more focused on, the consumer side of things, and LZRS more so on like the developer kind of back-end kind of things. I would love to hear, I guess starting with you, more about the cloud platform that you're building and how you can help.
Yeah. So I think one issue that we're going to be facing very soon is it's becoming very easy to launch a chain. And that means there's going to be a lot of chains, and these chains are continuously producing blocks, and the cost of putting data on these chains is now plummeting. So people are going to be putting a lot more data on these chains. And so one interesting thing is so first of all, there's basically this leads to 2 challenges. One is, and I think I might have mentioned this earlier, but fragmentation of the different types of implementations of everything. So if you have a traditional indexer and cloud-based application or tool that works with, for example, EVM chains, you're already not going to have compatibility with every non-EVM chain. And as we get more chains, that's going to be a large selection of interesting projects that you're not going to have compatibility with. And even within the EVM space, there's fragmentation. So not all EVMs are the same. There's some EVMs that don't have a given RPC endpoint that you might want, or they just don't they have some pre-compile, or they just have it just doesn't work exactly the same way. And it's actually becoming increasingly hard to just simply make an EVM compatible tool. So one thing that we're doing is we're just trying to think from first principles. How can we rebuild these systems so that we are not making assumptions about how a protocol should work, and we can just let people define that. But as I had mentioned earlier, we want to make that developer experience as easy as possible. So that's one of the things that we're doing. And the other thing is it's kind of gets into the economics of actually running a cloud-based company. And when you have a lot of chains, you're going to have this long tail of chains that are somewhat interesting, but maybe they're just not extremely well adopted yet, or they have potential, but there's just not that much usage yet. And you might want, accessing any one of these given chains, it probably doesn't give much value to people. Maybe not that many people want an API for that, but a lot of people will sometimes want to access data from some of these chains. And so I can't remember the statistic off the top of my head, but last year I was quoting this thing where there's some very large percent of Google searches that are long tail. So people are searching for data, searching for information on Google, and a lot of these searches have never been searched before. It's a non-trivial amount. It's actually surprisingly high. What that indicates is that people, when you have the distribution, like you have like a head of data, most people are accessing data in the head, and this long tail, there's a lot of demand to access data in that long tail. The problem is that it's really expensive to store that, and if you just say, okay, well, I'll just buy all these terabyte hard drives and just like put them in my basement, it's also then hard to actually like run computations on that and access that and query that in a way that is performant and acceptable, in a way that is useful for people building applications. So we're trying to make the infrastructure on the cloud side of things that can allow people to run computations and query this data set and make that available for everyone. So this stuff doesn't just get lost to history.
You're up. Why consumer focused?
Pardon?
I guess the question was just, I believe that you're kind of more on the consumer side, helping, users like interact very easily with the Block Explorer, more so like a search engine. So I was just curious as to why you picked that direction over something like Modular Cloud, which is more of the back-end side of things.
Sure. So I say we very much are intentional with the wording of referring to our product as a search engine as opposed to a Block Explorer. But I'll actually just pick off of there's a lot of queries that do not get actually searched on Google. The statistic is insane. As you were saying, I was just thinking, okay, just think of like a standard query, like 5-letter, like what is, and then just insert whatever word. Do a permutation on those characters, it's going to be an insane number. And yes, they're never going to get searched. And I do often find myself finding stuff that, oh, there's no search result for page for this. And I think it's kind of fun. Then how do you build a product that actually allows you to access these things? You don't necessarily build a product that allows you to access only hash data. You may want to do that if you want to specifically, again, take the approach of letting people be extremely developer focused. That is great. That is actually the perfect product for that. That is how you want to reference stuff. Maybe Blockite. Some people do that as well. Why not support it all? But the point in which we're very intentional on us being a search engine as opposed to Block Explorer is we believe people don't necessarily want to search for specific data sets or specific factual information. That all of the top 100 searches on Google every single year are all brands. They're all brands, they're all goods, they're all good they're services. And the only exceptions are stuff like weather, food around me, and stuff of the sort in different languages as well. Because everyone searches is not something appropriate to the crypto ecosystems. Therefore, I think it's such a good approach to actually take it. Okay, if everyone in the world searches, there's and he's saying billions of searches every single month. I forget the precise amount, but it's definitely on the 2 digits end of things, like 36 billion searches, I think. Every month, don't quote me on that. You can Google it yourself, or Dora it yourself someday. And we take that approach because we want people to actually not search for this factual information on every single block, every single transaction, every single internal transactions, logs, whatever, decoded logs. What we want is people to actually search for these goods and services. And we, at Dora, when you search for an NFT smart contract, right now, this is only bound to, let's say, Aura ERC 721 Dora proxy contracts. But we want people to be able to mint within Dora, which you are able to do right now. If you search as Dora smart NFT smart contract, again, Dora proxy 721, you're able to mint it within Dora. If you search up DEX within Dora, we generate a friendly UI for you to be able to engage with the swapping widget within that. Right now, it's, of course, bound to one of the most used ones. We use the Uniswap widget. In the future, we hope to have this very generalizable infrastructure that allows you to leverage every single good application, regardless of whether or not it's the first or the last time that someone's looking for it as well. We think that we think that is how people relate currently to goods and services. So therefore, why actually not offer that in the space? We have a lot of providers for many things. Why not actually give it to people in a way that they're already used to engaging with them?
Sounds great. You guys are really additive to each other and kind of approaching it from a different angle. I think it makes a lot of sense. So thanks for going into that. Jordan, jumping over to you on shared sequencers. There's a number of different shared sequencer networks popping up, including Astria. Would love to know, what's different about Astria from both, the developer infrastructure experience for the most part, or how easy is it to will it be to plug in and use your solution?
Yeah, I think, I mean, first of all, we're really excited to see, more people building the shared sequencers. We think, it's only from our perspective, it's only positive to have more people thinking on this and more people working to, push us to build something great. I think the reality of this space is that, the shared sequencer narrative took off in March, April. And I think, Espresso yesterday launched like a demo thing that they posted, which is great. Pretty cool, excited for them. We're gonna do a demo of what we have a little bit later here today at a workshop. So I think the reality is that like, it's really early, and the debating over like who has better product UX and whatnot, it's going to be really early. I mean, to an extent where it's like I looked this morning, I was like, oh, Espresso had this post. Let me go look and see how this works, because I'm going to be talking about how we're all thinking about our user experiences, and it's one of those. It's just so early to really give you like this is our differentiator in terms of how our product actually works. What I can talk to is, like our experience and whatnot, which is that like my background is in developer tooling. I worked at GCP, I worked at Meta doing like their API designs, and worked at a CI/CD company for a while. So it's like it's really our background is building developer tooling. And so everything we do comes from kind of that mindset of like, what is a user? What is their journey? How do we make it so that it works? What are all the things they're going to want to do? How do we work on those integrations? And then, from here we get, products out. And then, like I said earlier, it's going back, it's hearing what people have to say and continuing to improve on it before we get to, a final launch. And that's kind of how we think about it. And yeah.
Thanks for that. I'm also kind of curious from the node operator perspective, when people are coming in to run a sequencer. Maybe it's too early to touch on that as well, but I'm just curious to hear like who might be such an operator. Is it someone like a traditional validator or professional node operator that already exists for other kind of things?
Yeah, I guess then there's a couple. I have kind of a follow-up question, but I can answer both of these. Sure. Which is when we talk about a node operator, are we talking about like validating sequencing nodes, or are we talking about like a node that someone runs at home so that they have access to the data?
Oh, I meant so the former. Okay.
Yeah, I think the way I think about this is similar to other specialization pieces and similar to Tendermint. We'll go after traditional validators for the most part to start with. I think this is a big part of the appeal of a shared sequencer network is if you want to go and launch your blockchain, like we're going to do the legwork of making sure that there's good validators that are using it. That's part of like launching this product. And that way, when you go and you launch your rollup, like you don't have to do that, because that's a huge, it's just a people coordination problem. And so whether or not that's, an institutional node operator or that's an individual with like their special high performance setup, I think at the end of the day, it just comes down to doing it and like, well, so it doesn't, I don't have any like specific biases one way or the other. We are building, our sequencing chain is built on top of Comet BFT. So lean on top of the institutional knowledge that, and I say really more like ecosystem knowledge of that people already have in terms of running those.
Thanks for that. Yeah, Josh, your turn. So you're a solutions engineer at Celestia. Would love to know a little bit about what you work on day to day and how you're helping like, the entire Celestia ecosystem build things on top of it.
Yeah, so I guess like a lot of my day-to-day is mostly maintenance of our documentation. So if you've run a light node, there's a good chance I've like at least edited something that you followed to do that. If you're running a rollup on Rollkit, I also work with their documentation as well. I guess on the integration side of things, I work like on different execution layer integrations. So I worked with the OP stack integration with our engineering team, kind of like polish the docs up for that and give it to the end developer to go ahead and play around with. But I guess like one of the most fun things that I've had or enjoyed the most recently is trying to abstract away the console or the terminal for people when running a light node. So I have like a beta version of this Mac OS app that I made that you can just download on your Mac like you would any other application and start a node up. So yeah, I kind of just experiment with things, but I think that's the beauty of like where we're at in this space. We're still figuring all these things out. There's many EVMs, as LZRS was talking about, that could be used as execution environments, but some of them have different precompiles and just like different properties about them that aren't all the same. So figuring out like which one of those are best in the long run, I think, is going to be like, yeah, like a really important thing for this space. I kind of got a little bit out in the end there, but yeah.
No, you're good.
A little bit all over the place, but mostly experimenting and helping people post data.
Maybe this might be a bit too early of a question, so apologies if so.
You're good.
But going back to that, our first kind of question about how easy things will be. Given everything you just said, how easy do you think it will be to launch a rollup, using Celestia, both from the perspective of someone just doing it themselves or a developer doing it themselves, or leveraging a RaaS solution?
Yeah. So I guess like one of the next ideas I have for this Mac app is to like first put in a transfer function so it can act like a wallet. I want to also put in like a posting data to the network function, but like the bigger addition to that would be something where you can go in and like literally click like start a rollup or initiate a rollup, and maybe leverage something like Dimension, for example, to do that. So I think like in the next year or so, like there are going to be things like that that exist, maybe even sooner. Conduit is an example that has not built on top of Celestia yet, but they do have the ability, if you go to their web interface and make an account for free, you can start your own rollup on Gurley. And I think that's fascinating. They handle all the infrastructure for you. You can like inspect the logs of the actual like software that's running, and I'm very optimistic about like this basically like drag and drop sort of like roll up infrastructure, like the same way that if you want to go make a web store right now, you can use Shopify and basically have no knowledge of like development or anything, and you have something that works and is a fully fledged product. I guess I'll stop after this, but I think that's one of the beauties of where we're at, is we're going to be able to figure out all the different pieces of the stack really well, and like the really optimistic vision I have is that the same way that like blockchains work in the future is the same way that software works now. I know it's called the OSI model. I don't know much about it, but there's 7 different layers in the way like most applications we use operate. And like I think I want to get to a point where no one has to know what's going on under the hood of that rollup. They just know that they have a rollup. Here's their like special key to access it or whatever. But I don't know what happens when I send an email. Like every single layer of my email, I couldn't tell you what happens. So like I hope that we get to a point where developer tooling and like even just the end user like products are at that place where people don't have to think about it, because it's overwhelming, to be honest. And I think that's probably one of the biggest challenges of this space.
So I think we're out of time. Yeah, we're out of time. Thank you guys so much for being here. Would love to do it again sometimes, have some more questions for you, but it was really an engaging conversation, so really appreciate your time. Yeah, and thanks again, everyone.
Thank you.
All right, everybody. So we have a short break now because one talk fell through. So please be back or stick around at around 12:10, I think, to see Aditi. I think she entered the room at some point. There she is. So yeah, stick around or make sure you're back at around 12:10. Thank you guys again.
I'll just point to you.
It is.
Yeah?
There
We go. Okay. Oh, wow. This is such a beautiful picture and just image. Amazing. Okay. Today, I'll be talking about Capsule, but the context of why this is such an important topic for modularity and the summit in general is because as we increase the surface area of chains, we actually end up with more problems. And so this is where transaction signing infrastructure becomes really relevant. Next slide. Oh. Wait, there's a slide before that, no? Keep going back. Back. There we go. Okay, cool. Next slide. Perfect. Okay, so congratulations, we did it. Turn to your neighbor and give them a pat on the back because hell yeah, we're on our path to solve the scalability trilemma, which was necessary to solve for so-called mainstream adoption. So yay, we're on the path there. But because of this, we've actually introduced a bunch of new problems that hinder potential mainstream adoption. So that's kind of what I'm here to talk about today. Next slide. Thank you. So here's what MetaMask looks like today. Managing a bunch of tokens, managing a bunch of networks. It's a very complex flow to sign transactions. Next slide. Assets are basically everywhere, and essentially as chains, the number of chains grow, this problem gets much worse. Next slide. And so, yeah, I've been thinking about blockchains in general since 2017, started my journey at Consensus, had a stint at the Graph, was recently at Celestia, and then ended up joining Nitya, the founder of Capsule, to think about this problem because I was kind of observing that there needed to be a better way to manage transactions across all these chains. So more into that on the next slide. So here's what we know about the path to mainstream adoption. Of course, there's more steps on this. It should say 1, 2, 3, but yeah, it's fine. Yeah, there's probably more steps on here, but for all of us, the steps to mainstream adoption are 1, we know we have to separate out execution from the L1 to just scale better. 2, we have to create more compelling applications to bring people into crypto. And then somewhere in the middle, we need to profit, hopefully. Next slide. And so if we think about this in the framework of 3 product categories, applications, wallets, and chains, we actually end up seeing something super interesting. Next slide. Yep, perfect. There you go. Perfect. We've successfully added more chains to the spectrum and protocols because we've obviously been thinking about scalability a lot for the past 3 years, to the point that we've created more and more block space and created more forms of execution like alt VMs, ZK VMs, et cetera. So this side of the space is kind of teeming with activity. Next slide. Next. There you go. Also, we know on the other side of the space, applications, we've seen a fair amount of activity there. So we're somewhat there in terms of mainstream adoption with apps like OpenSea, Zora, Rabbit Hole, Lens. But frankly, it's been a challenge to see a lot of mainstream people use these applications outside of things like airdrop farming. And so what gives? Next slide. Oh, yeah, go back. Yeah. The Capsule thesis is that solving for mainstream adoption is not just about creating more compelling applications. I think this is a very prevalent narrative on Twitter today where people are like, devs should be building better applications and use cases suck. But we actually think that's a misguided take. And the problem is, of course, innovating more at the application layer, but it's also managing the transacting experience across this wide surface area of block space we've created over the past 3 years. And so the key to that is the wallet layer. Next slide. Everyone should just like take a moment to cringe because I know like wallets are just like overdone and over talked about. So like let's just take a moment to like accept that. And yeah, it's the reason why it's been so exhausting to talk about wallets is because we've thoroughly like just exhausted our mental space for wallets in general. And I'll kind of explain why that is in the next slide. There we go. So the reason why is that over the past few years, we've innovated a ton at the UI layer, but not on the fundamental transacting layer. So this is MetaMask, Rainbow, phantom kind of represents like 2018, you still need to switch a bunch of networks, you still need to sign transactions or messages transact. You also have to like inspect the transaction to make sure you're not signing anything jank. And so it's still very much the same as far as like third-party wallet applications go. Next slide. There's also been a lot of innovation at the embedded wallet side of the space. So this is like Coinbase Wallet, Circle, Magic Link, Web3 Auth. There's a bunch of players. I think Engine as well is in the space. But this like wallet as a service product category is also pretty exhausting. And the reason why is you get this like clean experience of not having to deal with signing messages and signing transactions in the middle of your application's experience. But as soon as you want to take your wallet and go elsewhere, so Celestia talks a lot about this, exiting with interoperability. It's very, very difficult. So these are the steps you have to go through to actually take an asset from an embedded wallet and actually import that into MetaMask and then list that asset on OpenSea, for example. There's a lot of steps, and so that's also very confusing and exhausting and bad. Next slide. The third way we've exhausted ourselves is with third-party app building wallets. So if you think about this, it's like Uniswap building a wallet or Robinhood building a wallet. This is awesome and actually works a lot in favor for the application. So the app now has full control over their end user experience. They no longer have to go through like a MetaMask. They can just go through Uniswap wallet. But it now requires Hayden and the team to fight the good fight with giants like Apple on App Store policies and making sure the app doesn't get delayed and kind of growing their user base from zero, which is a really tough thing to do. Next slide. And so you can see why we're kind of exhausted of wallets and this market in general. And at a high level, this is where this layout is kind of where all these products sit. It's crowded, it's confusing, it's not perfect. And there's an obvious gap of needing ways to transact that are embedded and don't require like leveraging a third-party app like a MetaMask in the middle, but also managing the signing and switching networks and making sure that you can take your keys and kind of go elsewhere and take your assets elsewhere as well. And so the crazy thing is that this is what this market looks like for just a single chain. So just within this like single chain paradigm, you have all these options. And so as block space surface area increases, Mo chains. No problems. There we go. Yeah, you guys didn't say that. Mo chains, no problems. There we go. Yeah, participate. Take two. And so next slide. Oh, yeah, there we go. So so in a world where thanks to modularity and better scaling, wallets as standalone products are constant RPC endpoints. Always switching network in the middle of your flow and just shifting the user friction, which was once on the infrastructure side of things, down to applications, which is not good. And so next slide. And so this gets, keep clicking, 1, 2, 3, 4, 5. There we go, now we're done. So this gets 1,000 times worse. So this is just a couple of examples of L2s or networks that have shipped recently. So there's like the Public Goods Network, Zora Network, Base, Claros also shipped recently. And so as we keep increasing the number of chains we're transacting with, you kind of need a better way to manage the transacting experience and the intention to transact in a clean way without making user experience really bad. Next slide. And so our core insight is, forget the wallet. I think wallet as standalone products are really, really tough, and instead focus on the ability to natively transact. So in a world with Mo chains, no problems, having a third-party app like a wallet just adds to the confusion. And so if you have a native way to transact within the application or the product, you remove the ability, the need to kind of switch between signing things and also needing to kind of have a browser extension to transact. Next slide. Yeah. So this is kind of how Capsule thinks about it, and we'll go through a demo as well. We basically add a notion of, the image is a little messed up, but that's okay. We add in a notion of permissions into this experience. So by permissions, we remove the discrete proposing, signing, and inspecting of transactions that need to happen in today's kind of transacting paradigm. And so how we do this is we take MPC-based key management, and we wrap it with a permissions engine. So no more pop-up switching networks, but you also get the interoperability benefits of wallets by being able to take your keys everywhere. So functionally, next slide. Yeah, functionally what this looks like is a developer tool. You can click again, it changes color. Yeah, functionally, yeah, right? Functionally what this looks like is a developer tool with a single sign-on experience. So this means theoretically a user could onboard onto an EVM-specific application and then one-click onboard into a Cosmos wallet. Which removes the need for the Cosmos wallet to acquire new users and also get users to bridge through the friction of going into a new ecosystem. And so we think this design kind of drives network effects by not only simplifying the customer acquisition process, but also the user's transacting experiences. Next slide. And so this is a demo. I'm not sure if it's going to work. Click again. OK, great. So what we're doing here is, again, the single sign-on experience of creating a wallet. We could do email, phone number, WhatsApp, whatever you want. We verify that with a 6-digit code. Oh, did that work? I guess we'll do it again. OK, that's fine. Next slide. Anyway, the point of the demo is you can log in with any form of auth, leverage hardware enclaves to transact, and also simplify the user's transacting experience with this concept of permissions, which the demo should show you. Next slide. No? Oh. OK, maybe that was not on me. That's fine. No? Just go to the last slide. Previous. No, previous. Yep, OK. So the takeaway, ideally post the demo, which I can send to everyone here if you're interested, is wallets aren't the problem. Our mental model of how data is written to the chain is the problem. In a world where we have tons of chains, users should not know, ideally in my opinion, and won't know what chain they're transacting on. And in order to live in that world, you probably need a new paradigm of writing data to the chain and transacting. And ideally, the last bullet, this doesn't just create more and more silos and walled gardens. This is created in an interoperable way where you have a broader abstraction layer that can manage this transacting surface area. Next slide. Yeah, so that's a bit about me if you want to get in touch. And yeah, feel free to reach out if you want to see the demo properly. Thank you so much.
You want to take some questions, maybe?
You want to stay up for questions?
Wait, are we on?
No, you have time. You have time. Yeah.
I have 8 minutes. Oh, wow. Yeah. Okay. You want to come up for? You're not coming through? No? OK. Yeah, any questions? Hello. Yes?
Does it support Wallet Connect?
Yes. We're in the process of integrating with Wallet Connect. Yeah, wallet aggregators are key to how this interoperability works. But generally, you should be able to take your keys and go everywhere. And so that's kind of how we think about it. Yeah. And we're in private beta right now. I don't know if that was clear. Yes.
If the user says like they're using an email and then want to like eject to like a private key, is something like that possible?
Yeah, this has come up a lot. We're actually working on this right now. Having the ability to eject and also go elsewhere is extremely important. And whether that's MPC to EOA or other things is kind of on our roadmap as well. Yeah.
Can I swap like different like auth methods?
Yes. So I think phone number, Apple, WhatsApp, whatever you want. It's pretty trivial for us to add. Wow. Yeah. Yes.
So if there's more chains,
Yes.
are there more problems?
Well, ideally, if you're able to manage all of this like intention to transact in a clean abstraction layer that doesn't involve the like Vitalik's post of like my ETH is all over the place and I have no way of like unifying the networks that the ETH is on, that's the intention, and that's what Capsule does. Yeah. Cool. Hey. All right, I think we're done. Thank you.
Thank you, Aditi. All right, next up, we're going to have a panel on investing in modular infrastructure. Joe, free agent, is going to be moderating. We've got Matthijs, Kelvin, and Yuri from Signature. Guys, please give them a hand.
Hello, hello. I think this is on. Great to be here, everyone. Appreciate everyone attending. And a big shout out to Celestia and Maven 11 for putting this on. Had the privilege of attending last year as well, and by far one of my favorite events that I've had the privilege of joining. So I'm excited to lead this panel today about really some great perspectives about investing in the modular ecosystem. So want to throw it down the line, but first, my name's Joe. I invest in the space, and yeah, happy to let these guys introduce themselves.
Yeah, I'm Matthijs. I'm one of the partners at Maven 11. I think we were the first investor or backer of Celestia, and I hope, therefore, we help the modular movement move forward a little bit.
That works. Yeah, I'm Yuri. I think together with Maven, actually, we're the first investor. Like, we're second, I guess, right after you guys, when we called later. We're a little bit different, I guess, as a VC, so we'll maybe have a different perspective here. Because we look at the blockchain space, not specifically as blockchain, but we have a broader perspective on a better internet, let's say. So I hope we get a different perspective here between the more crypto VCs.
That's great. Okay.
Hey guys, yeah, Kelvin here, investment associate at Spartan. I guess we're the third investor in Celestia after you guys. So yeah, we've been investing since 2017 and looking into more modular space starting in 2019. And yeah, we've been fairly involved pretty recently as well.
That's great, guys. I think how I liked setting this conversation last year when I had the privilege of moderating is kind of getting some context into your guys' history in the space. I know you shared a little bit about it, but maybe quickly, like, what was maybe the first project you kind of recall giving you some of the inklings of kind of where the modular narrative is today, and like maybe what's one of the more recent ones as well?
Yeah, I think the first one, easy shout there, is Celestia, but I think maybe the sort of Plasma or even Lightning Network on Bitcoin, you could argue that it moves execution off-chain. Currently, the most recent one, I won't name any portfolio company, but I think Eclipse is doing pretty cool. I think it's cool to see that they bring the Solana VM to like another ecosystem, which sort of shows the power of moving that execution off-chain.
Totally agree. Yuri?
Yeah, I mean, we went with Celestia as the first time we saw something really, really different from after like Bitcoin and Ethereum, and it became clearer that there's something happening where you have to actually modularize or split certain functions. And we're kind of moving slow in that direction. So we're looking now at what's happening out there. So with all the decentralized sequencer, with intent-based architectures, with Rollups, obviously, and then Rollups with the services, and just looking at that from a tech perspective, like, okay, when is the next time something comes up that's so big that splits again in a way, right? Where you need to really modularize in such a way that it scales up again.
Totally. And what's maybe like a recent project you've heard of that kind of maybe fits into some of those narratives, or one that you're following?
I'm following a couple of projects, but I talked yesterday with the Austria guys as well. So I'm kind of interested really in the decentralized sequences, not because they're right now interesting to us, but I think they're going to be a big thing once rollouts become a little bit more thriving, right? Once you have this happening around more, there will actually be a thing where you say, okay, what is the next bottleneck that might break? And that might be one of those things.
Cool. I'm excited to chat some more about that in a little bit. And Calvin, what about yourself?
Yeah, and Celestia is definitely one of the first projects that actually piqued my interest in the modular space as well. So yeah, back in 2021, started looking into it. It's interesting how such a minimalistic design chain could align so well with the ethos of censorship-resistant blockchain. So yeah, Celestia is definitely one of the first that's like the pioneer in the space as well. For a more recent project, I've been like Yuri just mentioned, with the proliferation of rollups in the space, I've been thinking more into the permissionlessness of moving liquidity across these rollups, right? So an example project that we got involved in is called Catalyst. So essentially, it's a liquidity layer across all these rollups that allows users to transfer value natively across these.
Yeah, it'll definitely be an interesting challenge. I think that we'll probably get into a little bit during this conversation as well when it comes to maybe some of the trade-offs of modularity as well. Yeah, I think I would also just love to kind of understand, like, we kind of hinted at it a little bit there as far as some of the recent projects that you guys are following, but when we think back to maybe 12 or 14 months ago in Amsterdam, What are some of the things that are like top of mind as far as like what has changed specifically in that period of time?
Yeah, I think back then it was sort of like, okay, DA and rollups, that's all there is to the modular ecosystem. And since then, a few big trends, optimism, Arbitrum obviously taking off in a big way. Also getting traction on the application level, which I think is very key. And we all talk about infrastructure here all day, but it does actually matter that we have users using these things. I think that's sort of validation of the thesis that rollups will scale more. And then obviously on the more technical or experimental side, you have things like modular MEV, so cross-chain MEV, intent-based architectures. Aditi just talked about that. And I think developments like sovereign rollups, which Sovereign Labs is obviously working on, are also like in that bucket of new experimental ideas that we love to see.
Got it. And what about maybe Calvin? We'll go to you and then to Yuri.
Sorry, could you repeat the question?
Yeah, maybe trends that you've seen over the last 12 to 14 months specifically that have like very much piqued your interest in the modular space.
Absolutely. So I think RaaS, so Rollups Service, so similar to what Matthias just mentioned as well. We've been seeing a lot of these getting competitive in space, different ways of solving the same problem as well. I think DA is also something that's interesting. So aside from Celestia, we're seeing obviously other DA solutions in the market, whether it's Avail or EigenDA.
Great. And Yuri, maybe anything to add to that before we move on?
Yeah, I agree with the guys. Also, I mean, RaaS is kind of the easy way to think about. Once you think, oh, there might be many rollups, right? You need somebody to deploy them. So there's a service. That's kind of an easy idea, let's say. Not easy to actually realize, but it's an easy idea to think about.
Maybe to add to that a little bit, I'd love for you to maybe dig in on, like, if you have any opinions on maybe some of the economics that exist at that layer. I know I've heard maybe a variety of perspectives on how sufficiently those businesses or protocols can kind of bootstrap the economic considerations around where they sit in the stack. So free to anyone to answer, but I'm just curious to.
I think we all have opinions on this one. You want to go first, or shall I?
Sure, go ahead.
I think one sort of thing we hear a lot now is abundant block space. So all these DEA solutions that we hear about are like, oh, there will be so much block space that it won't really be valuable anymore. Whereas I think there is a big difference in the quality of block space, whether that's liquidity on that, verifiability of that block space, which obviously light clients play a big role in. So that's something where the value accrue will definitely happen, in my opinion, on the most valuable block space that a user can easily verify. There's a lot of liquidity on it, or MEV extractable on it, which could be interchangeable, and that you can easily deploy different rollups on. And that's, I think, also interesting that on Ethereum you still often deploy EVM rollups, whereas on Celestia you'll probably see a proliferation of different virtual machines.
A little bit of a bias for other execution
environments. Of course.
Yuri, anything to add to that?
Yeah, I think the biggest gravity at the moment maybe is the bear market based liquidity. It's fun to see if you even look at L2Beat and you think a TLV, for example, of the rollups. It's strange why, for example, Arbitrum and Optimus doesn't have more of it, and more of it, especially after the breakdown last year, moved again to mainnet. Maybe this is the quality, right, of the block space, and you have more security or more battle testedness of the mainnet, and you just trust it more. I'm not sure. But it seems to be like, why isn't going more up, right? Why isn't going more to the rollups to do something? Because Aave and Unis have all of this there, right? So the basic stuff basically we're using.
I think we discussed this one earlier or some time ago as well, right? If I leave my assets somewhere for 10 years, I'm not going to do it on the rollup right now. I will just use Ethereum mainnet or Bitcoin.
Exactly. So how do you solve that? And then I thought about to a certain degree, maybe you need some sort of tool or a company or protocol that's only exists on the roller, like GMX, for example, on Arbitrum and Avalanche, right? And around that, it slowly will build around an ecosystem, and then only it becomes as trustable as a mainnet.
Yeah, maybe to kind of like add to that and maybe pose another question to you guys. I think it actually might be like one of the trade-offs that probably is under discussed in this space specifically, which is to what degree with some of these like new implementations, with these new configurations of blockchains, can institutions or potentially like more advanced, like larger liquidity holders actually underwrite the risk associated with these architectures? So maybe we can pose that question to you guys, like how do you as investors kind of like underwrite that process, kind of the activation energy, or like potentially some people would use the word lendiness that has to develop in order to accrue or attract that liquidity?
Yeah, I think for us as venture investors, we can underwrite that, because we sort of do need to take a lot of risk to get the returns we aim for. But as like an institutional, debt fund allocating in DeFi or something, yeah, I understand that they see more risk in like experimental projects that are now going live in the modular space, etc. And they would maybe rather stick with a more mature DeFi stack on Ethereum. So I think there you just need to prove yourself over time that you are there to stay and that they can allocate. So it's about sort of the risk, appetite of the investor.
Anything from you guys as far as like, I don't know, maybe how you as investors kind of at least attempt to underwrite some of the risks that like, these more modular configurable systems or architectures can introduce?
Yeah, for sure. So when it comes to assessing different projects, I can actually use perhaps like a DA layer. So there's several ways we can assess this, right? So obviously, DA is a function of the cost as well as the transaction count. So you can do certain projections, right? Given how much, I guess, revenue the DA layer could actually make, and then you add on a premium to it, and you can actually, have thinking like how they could actually monetize on top of it.
Yeah,
right?
so you think of it from more of maybe an economic security perspective, or kind of where are you going with that as far as?
Sorry,
you're thinking of it more in relation to like the economic security perspective of like that sort of a thing would help an investor, or like maybe like a liquid fund better underwrite the risk of like a modular architecture.
Yeah, I think that certainly will help.
Matthias, I think one thing we had chatted a lot about is kind of like some of the different like founder types that we see specifically in the modular space. Would love to maybe throw it to you guys as far as like, are there things that stand out about like the types of individuals that you've had the privilege to support and invest in that are building in this space, maybe unique characteristics, maybe bad things, who knows?
Yeah, I'm happy to take this one since we've backed quite a few founders in this domain. I think right now what you see is it's usually quite tech-heavy people, and they like to be sort of nerd-sniped. So they like to think about ideas that are complex and that easily change as they move along. So they also need to be flexible in their architecture. I think that's sort of the current founder type you see in the space. I do expect that to sort of change over the next 3 to 4 years to also more consumer-facing, more commercial, business-minded people who just want to build an end product for users.
What do you think that shift will be like a byproduct ever? Like, what do you think will cause that? Like,
I think just maturity of the tech stack, right? So that they don't,
I think to some degree.
So that they don't need to worry about like the trade-off of MEV prevention or an intent or not, right? I think somebody who just wants to build a good user app doesn't want to care about what sort of transaction type there is.
Maybe I pivot this question to you guys as well when it comes to, I think everyone kind of agrees on this kind of opinion in the zeitgeist that like everyone is focusing on infra. There's probably not enough people focusing on applications. What are some of the things maybe that you guys are impressed by when it comes to like making some of these stacks more accessible? Like we have mentioned some of the rollups as a service providers, but I think, whether it's like net new execution environments, opening up the doors for developers from other ecosystems to come into Web3, like is there maybe a specific highlight of those categories that you think like make this technology more approachable for like application and like potentially like consumer developers as well?
I think actually what's really cool about the modular, let's say, mindset is not that you build modular, but the way that you're not locked into an ecosystem, especially through a token, right? So I try to run around Berlin and talk to people at why isn't people collaborating more together? There are a bunch of different ecosystems there. And somebody mentioned to me, well, when you develop something in your ecosystem, the incentive is really still like develop it in your ecosystem, because you develop it outside, well, they profit from it, right? So unintentionally, the token provides a barrier for collaboration to a certain degree because it's been so big already. Now, modular doesn't have that. Because you can collaborate rather easily. There's everything is more aligned, so the room for experimentation, the whole environment is way better. So what you have is really that there's a lot of people building really cool stuff out there, and they're just trying to figure out how to combine it, recombine it, and so on. But a lot of great ideas coming out of that, and one of these great ideas is that you, for example, can abstract away the token, right? I think Nick mentioned that 2 days ago on the ZK day, that you can actually build directly something on Celestia and don't have a token. This is a good thing because developers don't have to be financial anymore. They can just like start building, which is really cool for the application users in the end, right? So those kind of thinking is way more free and running more free and doing more experiments in the modular space. It's also about the founders who are really mindseted like that.
I don't know, we might have some people start sweating in the room when we start hearing no tokens, but another thing I'd like to pose to you guys, I'm like quite curious, specifically maybe on like Calvin and Matthias's perspective on like what are you bearish about in the modular ecosystem? Are there like specific things that you think are like currently discussed or like a lot of people are excited about that like maybe specifically as an investor you aren't that interested in, or maybe even like intellectually or like from a product market fit perspective you think like doesn't have a chance or you're not as excited about?
Yeah, so I guess I can just quickly take this. Yeah, so that's a very good question. I think moving forward, there's going to be a challenge when it comes to justifying valuation. So I feel like during the bear market, a lot of people are looking into infrastructure that squeeze up all the valuation. And in order to justify these valuations, depending on what you build, fees might eventually compress in the future. So you'll have to find other ways to accrue value to what you're building, right? So perhaps owning, more of the vertical stack, that's how you accrue more value.
Also bearish on high valuations. But Matthias, I'm curious to hear your thoughts.
Yeah, I don't know if I agree with the fees point. I think sort of fees will compress per user, but the sum of fees that we collect on like the infrastructure as a whole, I hope will increase as we onboard more users. Sort of the bear case for modular crypto, I think, is either the complexity that you add by sort of incorporating all these different systems together. So if one of them breaks, that might not be good. And overall, maybe, but that's a larger bear case on crypto, that people just don't really care about end-use verification. So a large part of building a modular blockchain with data availability sampling is that everybody can run a light node very easily. I mean, we see the people from Celestia especially do it everywhere. But ultimately, the assumption there is that people do run around a light node and verify this thing themselves. Whereas maybe, well, they just don't do that.
Do you think people want to run light clients?
Yeah, I think otherwise you shouldn't be in crypto. But it's sort of why you built on the blockchain, right? You want to be able to verify it. Otherwise, you can just use an Excel sheet. But
it reminds me of like the accessibility point that we mentioned earlier. Maybe earlier we were talking about the accessibility for developers with like external skill sets from crypto. But when you think about from a retail perspective, maybe what some of the purists who have like grown up in this industry like really like kind of like prioritize is really ensuring that these networks can be robust. And a huge part of that is ensuring that you have like a culture that exists around these blockchains of verifying state and having individuals capable of doing that. But maybe one thing I would pose to the group is I'm kind of convinced that we have to, and in the same way we have to build, like modular execution environments, et cetera, to make it more accessible to developers. I think if we want people to care about, verifiability, we have to make it almost as like, easy as like wearing a wristwatch to tell the time in order to actually see like wide adoption. So maybe counter that if you guys steel man that perspective. Even as like a validator, like I still think people don't want to run
I actually
light
agree
clients.
with the perspective, right? And I do think people care about it. So that's sort of in your question, like, will they? I fundamentally do think so, because the most valuable sort of crypto networks also have that culture of running their own full nodes, right? Bitcoiners go mad if you make it slightly harder to run a Bitcoin full node. It's sort of the whole block size debate was about that. And Ethereum also puts in a lot of work into making it easy and accessible for everybody, like all over the world, with not a lot of money for hardware to run a full node. Obviously, you have trade-offs, but I do think that's what matters. So that's also why I'm pretty bullish on like being able to verify it yourself quite easily.
Maybe a question in the room, like how many of you guys have like ever run like a full node on a network, or maybe you're even like have tried or attempted to run a light client?
They're gonna counter my point.
Kudos to all of you. Everyone else, homework. At least give it a try. I really encourage everyone to give it a try.
I think maybe there's a difference in how you phrase, like, especially if you go outside the blockchain space, the general blockchain space, where everybody's kind of excited about the tech. What does it mean to care about running a light client, for example, right? I think people do care about a lot of things, but they have like let's say, I care about it for 2 seconds, right? If you give it 2 seconds to me and I'm able to do it in 2 seconds, I do care. If it takes me 10 seconds, I will not care, right? So there's a kind of a resource allocation problem here, where you say, okay, how can we make you care about that within that time frame, right? And that's what you have basically on a website, right? You go on a website, there's a green button saying, okay, it's check, done, right? Cool. So I care for a second, that's it, but fine.
As long as you can establish that root of trust in your green SSL checkbox in your browser. I think we've seen a lot of kind of thought and probably innovation in the past 12 or 14 months on some of these more sovereign constructs that we've started to see getting constructed. Do you guys have maybe some thoughts on the economic kind of implications of those sorts of constructs when you really remove kind of the application and execution layer from maybe some of the underlying economics that a network might be inheriting from an alternative L1 despite maintaining its sovereignty?
Oh no, I'm happy to go. I think that especially on sovereign app chains or app-specific rollups, whatever you want to call it, I think the value capture is way more easy, right? Because it's inherent to the application. So probably value will accrue to the application of the crypto stack and to the sort of bottom layer, which in my case would be a DA layer or whatnot. And I think if you have an app-specific chain, then it's quite easy to capture value by just extracting a fee for offering the application. So I think, yeah, the fee switch in Uniswap is famous, but if they had an app-specific chain, it would be quite easy to make it valuable because every time somebody uses Uniswap, the block space gets used and validators capture some of that value.
Any thoughts from you guys on kind of sovereign constructs and like how they could potentially like modify or alter some of the economics for application developers?
Yeah, so I agree with what Thijs just said as well. I feel like app-specific chains will probably have a better chance of accruing more value. In some way, I actually feel like modularity it does make certain layer 2s like struggle to accrue sufficient value. This is why we're starting to see layer 3s getting built out, right? That's how you try to find other ways to accrue value. Oh, sorry. Yeah, onto your layer. So yeah, moving forward, I think we'll continue to see more layer 3s building on top, and yeah, continue to scale that way.
Yeah.
I don't see a difference happening, and there's a normal, let's say, traditional world where commoditization means that you will less and less accrue value, and everything on top of that will accrue more value. It's just that within the innovation cycle, I like to say that every infrastructure was application once. Right, you start out of that, like an email, even like an email protocol was an application once. You just started sending emails, and then more and more people build on that. It compressed basically down. What Matthias said before that, with that the fees per user might go down, but the fees in total might go up, right? So it depends, like what do you mean by really accrue value? But in general, as a sum, it might be that most of it at some point will be an application, but once the system is really thriving, like we have now in the Web2 world.
Do you think Uniswap's an application or infrastructure?
Which version?
No, yeah, so we argue about this at the office, like, are you investing in applications or infrastructure? And you were also alluding to this, right? And I do think that in crypto, it's often both. Because Uniswap, for sort of Panoptic as an example, they're building options using UniV3 liquidity. So for them, Uniswap is the infrastructure. And then you sort of have an infra layer again that captures value.
Probably like why the conversation, like, I guess like that's probably part of the reason that that's like become such a, maybe like a common theme or like something that a lot of people are chatting about, is because there's probably like alternate definitions of those things as well. And they probably like convolute over each other a little bit.
I see they're going to aggregate the road, right? And Uniswap X, I think, is an aggregate, or coming towards to be an aggregator. So they're moving toward the application now, and they kind of letting go of the protocol ones.
Maybe something I would like to maybe ask you guys from like a more kind of like personal and investor perspective. I know earlier we chatted about like maybe some special things that we like see in modular founders, those sorts of things. Are there like explicit things that you guys like really enjoy seeing out of like maybe the founders or even like the technical teams that you have the privilege of supporting that you would wish to see from others? Are there like highlights there that like you would like to share, like lessons learned from some of these portfolio companies in the modular space that you guys are, that you think is worth sharing?
Sure. I guess, yeah, when you're building like modular infrastructure, the founder should be, I guess, really agile as well. So in modular in that sense. But yeah, yeah, some of the backers that we've, some of the founders that we backed, yeah, we actually would like to back, founders that has previously built in, whether it's like a monolithic environment or a modular environment. So founders that actually know how to appreciate the modularity nature of blockchain, right? So they're agile and that they actually understand what's the benefit of having modular infrastructure.
Yeah. What about you, Yuri and Matthias? Anything spicy as far as like things you want to see from founders? Or?
What I like about working with our founders in the modular space is I'm often the dumbest guy in the room, right? So they're all smarter than me, and I'm learning from them as well.
That's the sign of a good investor, if they're willing to say that.
At the same time, I mean, it's not that different, right? They do need to be smart and sort of flexible or agile, as you said, but they also struggle with the same things every other company struggles with. Hiring, team building, just building a company is hard, whatever you do. I think that's sort of it. Yeah, I think that summarizes it.
Yeah, there might be a balance as well, probably. In this space, I've found, at least during my time as an investor, that the majority of kind of the core founding team was quite technical. And oftentimes they do need kind of more, I guess, kind of like kosher traditional support from investors when it comes to the types of like things you can actually do to help them win?
Yeah, I mean, these guys don't need me to tell them how to write code. I have no fucking clue,
sure hope
right?
not.
But maybe helping with a first hire, etc. That's more where they need to sort of be alleviated. So they have their core muscle, their core strength, and we try to work sort of around that.
Yeah, interesting. I want to kind of like go into some maybe potentially spicy topics now that I think are, again, like quite timely when it comes to many of the ideas that are getting discussed over the course of the next 2 days here. What are some of your opinions on kind of like rehypothecation of like proof of stake assets? Specifically, do you think there's like unknown dangers that investors or founders or application builders are not considering? Are there like externalities that you think long and hard about or potentially keep you up at night like I do?
Yeah, so I mean, we have a company in our portfolio, for example, it's a pure Bitcoin company, and they don't like it at all, right? But there's a Bitcoin maximalism involved here, so I understand that, right? You're talking about kind of storage, right, values. But generally, what I find more complicated with the infrastructure now is that you add to the financial complexity, technical complexity, and to the technical complexity, you add scalability complexity. So you might think that, well, if something breaks down, I can all like execute smart contracts and it all goes down this way, but all of a sudden, bam, it doesn't work out because everybody runs to the same gateway. And so you have this all complexity even getting bigger. And it's really hard to evaluate that. How big is that actually? It's a lot of bunch of unknown unknowns. And that makes, I would go slightly, right? Really, really careful about that and see how far you can go with this. Because at some point we just break and then you realize what it is. So maybe just do that experimentally with small sums just to trigger and figure it out a little bit. But doing it on a big scale, as we saw also last year, that might be a problematic thing.
Yes, definitely, as we all witnessed last year. Matthias, do you have any spicy takes on this?
Yeah, I mean, I like the experimentation with it. In general, I like experimentation and trying out stuff and maybe breaking. On this specifically, I think the economics behind it are still quite hard, right? So it's hard to quantify the risk of like rehypothecation of assets, as quantifying risk in crypto is fucking hard anyway. And then there's also not that much fees collected right now that you can sort of give enough yield to
funnel to, yeah.
Yeah, funnel to incentivize people to take that risk. And that's, I think, sort of the big question here. Like, okay, maybe there's a small group of people who will do this, but to incentivize a lot of people, you need a lot of fees, and that's just not there right now.
I think I would broadly agree with that. I maybe want to pose like a question to the audience. Like, I like opening these up to see if anyone has anything to add to the conversation, or maybe things that you disagree with. Like, is there anything that anyone here would like to raise their hand and potentially ask the panel? I'm happy to walk up and give you the mic. I see a Spartan shirt over there. Any spicy takes for your colleague? You can't put Calvin on the spot like that.
Yes, well, I guess one spicy take that we kind of touch on was modular blockchain might at some point bring us back to maximalism, because going back to a point, right, like my previous point, if you're trying to accrue value to a specific layer, you'll start to find other ways to accrue more value, right? So, for example, just thinking out loud here. So a deal layer, if you're trying to like, fees do compress in the future, and you find perhaps you're trying to own another layer instead, maybe execution layers. Then you're starting to see, we're going back to the cycle where it's like we're starting to own more of the stack. So, that's perhaps like one spicy take.
Yeah, so then Celestia would at some point be like, hey, that settlement layer on top of us is also quite valuable. Why don't we sort of enshrine it into our stack? Yeah, that's a good bear case.
Yeah. Yuri, any other bear cases in regards to that spicy take?
I think my biggest worry with the whole ecosystem generally is that, are we actually building something completely different and new? Or are we just rebuilding the stuff that's already out there in a little bit slightly different way, and we're just not seeing it because it's so new, it haven't converged yet. But in the end, you just end up with the same system, with the same centralized parts. Like a validator is so big, it just controls a bunch of stuff, right? And maybe something so big, it controls a bunch of stuff. You have like a bunch of operators that are just grand, and you haven't seen it coming, but the economic gravity of that just made it happen, right?
That's fair. Another pivot maybe in the conversation. Are there like certain types of applications that you guys believe are like specifically empowered by by modular infrastructure? I know we've kind of chatted about like, oh, like these concepts of kind of turning specific applications into kind of their own like sovereign execution like layers, et cetera, across the stack. But when you think about kind of like the second order effects, maybe, this time next year or in 2 years, what type of applications do you think will have most benefited from this sort of architecture?
Yeah, I think, sort of a downside of building a modular blockchain is, I think, interoperability. And as a result of that, applications that don't need too much interoperability are going to be, I think, very interesting to begin with. A good example of this could indeed be gaming. So a gaming-specific chain for just one game. When I play like FIFA and I want to sell my coins or something on there, I don't need to interact with somebody playing World of Warcraft, right? I have no need for that. Whereas in DeFi, that's very important that you can plug these different Lego blocks into each other. So I think the first wave maybe, and we saw Argus present earlier, will probably be gaming specific chains. So that's, I think, something modularity enables. And then indeed the different execution environments, right? Stuff like the Solana VM, the Fuel VM, Move VM, etc. Maybe order book type of decentralized exchanges will be enabled by that. Although it remains to be seen how MEV will play out there, but these type of products as well.
Do you maybe want to chat on that as far as like some of your like cross-domain MEV perspective when it comes to like how that conceptually alters or is modified by like modular architectures?
Yeah, I mean, we're talking about it a lot. One thing we are currently still maybe debating, and I don't have my mind made up yet, is where do you want the MEV to sort of land, right? So one vision is you want the DA layer to capture the MEV because then it will accrue more value and you'll have more economic security. On the other side, you maybe want the MEV to sort of be isolated in a separate execution environment, because then if like one game gets extremely attractive and a lot of people play it, it doesn't trickle down to the other rollups. So it's a trade-off, right? Do you want it to go down or not? And it's, I think, where the leader selection happens is where it will go to. And I don't know what the optimal decision is. I think this is still very much an open question.
The first thing it makes me think of is if, and maybe I could be ignorant to this, but whether people have thought about dynamic systems that would be able to like maybe like modify or like point where that MEV could go, but between two layers like that. I don't know if that's been explored or if that's the dumbest idea that's been said here today, but.
I also don't know, honestly, but I would be down to sort of look into that more. I think that's one of the more interesting areas that indeed, we talked about these modular founders, if you want to call them like that, are sort of nerds not by and looking into, and I'm sort of happy to tag along with them on doing so.
Yeah, as we kind of like get a little bit closer towards the end of this conversation, maybe opening it up to all of you. You have an audience here that are quite modular pilled. Are there like specific types of things that you want to see built, kind of requests for startups, or any concepts that you think are like rather unexplored or that you wish you had more looks at as far as different ideas?
So when I was reading up, I just started really recently reading about the intent-based systems, and I found it's a really cool way of thinking about how it actually should act. And we have a company that's kind of in a similar space, but it's an agent-based space. And so intents and agents are a similar thing, but in the end, if you look at how an app is built, for example, right, it's not possible to have an app built on just smart contracts. You need some sort of in between, like agents, to trigger certain functions such that the person can just like have a phone in the pocket and just notification arrives, right, something like that. So you need all those things, and you need to cross them the chain barrier to this, the off-chain and on-chain. So I'm excited about this stuff and experimenting more of this kind of things to really figure out, okay, where does blockchain fit into the bigger world-solving problem space than just really running around the small pieces of the blockchain ecosystem itself. Because I think we crossed the barrier already a couple of years ago where blockchain was just a really kind of a big space where you could put all your hope in. And it was not concretely there, it was just a bunch of hope, and you can just really think about, oh, that's the potential. But now it's getting more concrete, and it also shows you more things that breaks, that works, that can solve and cannot solve, right? And it becomes really hard to have the hope. And so you have to really think about now, okay, what does it actually can achieve? Where does it go, and how can we go there? And I think this is kind of it's intent-based thing together with the agent-based. I'm not sure how different they are actually from each other. That's a kind of a different conversation. Is kind of a really nice way to explore it.
Calvin, Matthias, any requests for startups or areas that you wish were maybe ideas that you saw more of as venture investors?
Oh yeah, I'm happy to take it. I think this is going to be a bit boring and somewhat contrarian now. DeFi, it's not very sexy anymore, right? Especially amongst venture investors. I do think the whole real world assets thing is actually quite cool. That we have like close to $1 billion of bonds being on the Ethereum chain right now is, I think, very interesting to see. So in that regard, stuff like Noble that aims to bring USDC onto these Celestia chains, I think it's very interesting. So these type of products that actually connect to the sort of real world or Web 2 world or whatever you want to call it, are quite interesting. I would love to see that more moving forward as we grow more into that adoption part of the tech stack.
USDC, the quintessential real world asset?
I mean, I've been arguing here about end user verification, and now I'm the USDC bull, but yeah.
It's all fair.
And also privacy tech, but that's more generic. Stuff like Penumbra, Anoma, Nimtech. I think that's sort of where my sort of more crypto native heart lies, and I would love to see more of that as well.
Maybe dig into that a little bit, because I actually feel quite naive as far as like maybe some of the privacy considerations that are empowered maybe uniquely by modular infrastructure. Is there any like thing that you would add to that, or like things you've seen recently that excited you, specifically with like privacy type applications or privacy based architectures?
I haven't seen a lot of privacy tech like on a modular ecosystem, like a Rollup that's only privacy, or app-specific Tornado Cache would be quite cool. I'm not sure if the sort of... And then on privacy end, you have sort of two layers of it, right? I think a lot of financial institutions want privacy on their orders and don't care if like regulators can see it. And then you have more the crypto anarchistic privacy, which are maybe DarkFi, Nimtech, or work on, where sort of everything has to be private. They're very purist about that. In a modular ecosystem, I don't know, you can make a lot of design trade-offs. You can maybe encrypt a mempool, which for financial institutions would be enough privacy, right? So yeah, looking forward to seeing these founders try out stuff there.
It's another one I don't want to bore people with, because I feel like it can be quite cliche, but like, I'm curious if you guys have any perspectives specifically on, you know, like maybe like non-Web3 native use cases for some of these modular architectures. I think I could probably speak for everyone in the room in the sense that like, you know, like enterprise blockchain, et cetera, has failed in the majority of its capacity. But I'm curious if we feel that there's any inkling of feel that the modular infrastructure could maybe help empower that in some way.
I had this conversation yesterday about like how do you build a social network, a new social network, and I find this is a mistake. Most people think about social networks in terms of Facebook and Instagram and YouTube's as kind of there's a graph. Because I think in the new way, if you have blockchain, you have this new technology, you can rethink that. And I think in the center of that is the feed, and the feed can be, for example, modular, right? You can actually do and choose your own feed how you want to like it, and the feed through curation connects to people, right? Not anymore through kind of a social graph that already existed and you just walled it in. It really is about like there's a centerpiece where people are curating stuff, and that flows all into the feed, and that connects to people, right? And this has the emerging quality of a network then. All of a sudden you have a social network without wanting it, just like it was before. But it's a new way of thinking. And I think that's what blockchain enables, is a new way of thinking the old stuff. All the things that we have already, we can have it back, but we have it in a new way and build it in a different way, and only then it works.
I'd actually like to build on that like last point that you made. Is there anything like very specifically that you guys feel like maybe getting modular pilled, whatever you want to call it, or just like becoming more aware of how people are thinking in the modular kind of infrastructure space? Are there explicit things that has changed around how you think? That could be, I don't know, from like a ethical, philosophical perspective. It also be from a technical perspective as well.
I don't have a whole lot. I could take it back to the enterprise question if you. I don't think we'll see a lot of enterprises starting to build on these systems earlier, right? You asked, like, how do you underwrite the risk of it being quite experimental? I think especially enterprises are scared of that. I do think that sort of a rollup itself is very interesting for them, because they can sort of keep a level of control that maybe they feel like they miss on like an permissionless L1.
Or maybe certain regulatory
yeah, exactly. So I do see a lot of like experimentation happening there, but I do think it's way further out than next year or something, as you asked, right? I don't think they'll be like, oh, we have to deploy a rollup. No, I think they're more likely to be to look at more established networks.
Cool. Well, now we have probably maybe 2 or so minutes left just to finalize this conversation. But what do you guys hope we are like? You know, if we return here in a year and have the privilege of meeting at the next Modular Summit, what is it that you hope you're seeing become successful? What are some of the, like maybe the next milestones that you hope you see this space achieve in order to kind of get us to the next stage?
I mean, Celestia launching is a good first one, right? Launching their mainnet successfully. Second, I think also more ZK rollups going live like in full. I know ZK Sync is sort of live, but that ecosystem maturing to a similar sort of level as maybe the Arbitrum ecosystem is. Because I know we're here at like Modular Summit and we're talking about Celestia, but a lot of rollups also have like the largest ecosystems by far on Ethereum. EIP 4844 going live successfully would be pretty cool, I think, as that makes block space more accessible for these rollups. And maybe the first sovereign rollup on Celestia, more app-specific rollups going live.
Hopefully some accelerationism around restaking as well, maybe.
Yeah.
Fast experiments, but small ones, hopefully. What about you guys?
Yeah, so aside from those, I think we want to see more of the dApp layer development as well. So I actually want to touch on on-chain gaming as well. So I feel like on-chain gaming could actually take advantage of what modular blockchain could actually offer. So bringing the entire game logic as well as game economy on-chain could actually bring about like siloed different type of economies on the side, right? So for example, strategy game, you're trying to like attack someone, right? Let's say it's a and then someone can like front run, that action. It will be like
priority.
It will create like different new dynamics, right? So I feel like that's some place that we can perhaps.
I've definitely heard Scott from Argus talk a lot about what excites him building like modular infrastructure specifically for like game designers is like attempting to create something that can create like very emergent, like net new like player behaviors, because I think that's one of the things that actually makes games exciting, or like when good games become exciting is when it's like something you haven't done before. I remember like reselling in-game assets for the first time. That's like actually what got me into crypto in 2012. I think seeing more experiments around that will be pretty exciting as well. Awesome, guys. I think we're just at time, so really appreciate the attention from everyone and everyone supporting the whole gang here at Celestia and Maven. Appreciate you guys having us, and yeah, enjoy the rest of your time in Paris, everyone. Thanks.
Thanks a lot.
I'll just take one. No, one more talk. I'll take it. Thank you. These are all three for you? Oh, can I take? Yeah, there's one more speaker, right? Does he have a microphone already? There's one more speaker, guys. Okay, for the. What is?
Oh, sorry.
Sir.
Move over out of the way, no problem.
All right, everybody, please make your way either out of the room or into the room. Just see if we can quiet this down a little bit for you. Next up, it's going to be Arjun, head of ecosystem for Mantle. So I guess I'll call you to the stage. Take some time for these people to wash out.
Which is
clicker.
I guess
Yes.
Is the slide loaded already?
Yeah.
The next one in 1 minute, right?
No, this is the last.
This is the last one. And we don't have the modular Lego after?
Yes.
Hello. So I wanted to actually, so we've talked about, so we're all excited about modular architecture, but I actually wanted to cover something, something which I think doesn't get discussed a lot when it comes to modular chains, and which is how the economics are going to look like. Right, when you have all of these different layers working with each other, what are the economic models which we have at play, and what the incentive design is going to look like? Ultimately, what we've seen, so modular technology in general, when it comes to blockchains, is not something new. We've seen this in Web 2 as well. So what we've seen is that Web 2 software architecture was always monolithic. It was replaced with APIs and microservices, and ultimately, what we're seeing the same in Web 3 is that the monolithic chain architecture is also going to be replaced with modular architecture, right? So at Mantle, for example, we built a modular chain. We've gone live with eigen layer data availability. We've taken the OP stack and turned that into a modular stack. And what we've also seen is that API-driven architecture led to like billions of dollars of value creation, and we expect the same to see, at least I expect, the same thing to happen with the modular architecture as well. So let's try to look at some of the different layers of the blockchain and try and see what the incentive design is going to look like. So ultimately, on the execution layer, right, we've seen like a lot of interesting things happen. So if you've been following what some of the other layer ones have been doing, for example, Aptos came up with Block STM, which is parallelized processing. There's also Arbitrum Stylus and Polygon Miden. And what we've seen with different execution layers is that people have started thinking a little bit beyond EVM. So there was a time, or rather, I would just say over the last 18 months, we've seen that EVM has been the sort of execution layer of choice. But of course, now we've come to this point where we can also see that EVM is reaching a stage where either we optimize EVM or we look at a different kind of execution model where we can use possibly other languages, etc., to sort of write smart contracts, possibly do things more efficiently. And ultimately, there are a couple of ways of doing this. At the execution layer, you could possibly charge gas fees, accrue some yield to stakers. The moment you start to decentralize, you need to figure out some sort of economic model, and ultimately the value will lie in very optimized execution, and it has to be deterministic in nature as well. So if you can solve something like this in a decentralized manner, where you've got multiple execution environments all fighting for this piece of this pie, we could see some new interesting economic models come out. So I fully expect that with more and more VMs there, chains will not sort of work with only one VM. There could be multiple ones, depending on the kind of outcome you're looking for, where it comes to gaming or DeFi. And ultimately, as long as it's fast, secure, and deterministic, and you can parallelize things, we're going to see some interesting economic models come out of the execution layer. Similarly on settlement, right? So if you guys have been following what happened on Twitter, Anatoly posted something interesting where you could take Ethereum transactions and put those on Solana. I don't know if you want to do that, but it kind of gives you this interesting choice, right? So can we settle on other networks in the interim before we settle on Ethereum? Like these days, you must have seen so many different rollups are coming out on a daily basis, and which is great for the ecosystem, because that just means that the barrier to creating a chain and running a chain has reduced so much that everyone can have their own blockchain, which is great. But this also produces other challenges where we're going to see the block space on Ethereum, which was earlier crowded by transactions, is going to be crowded out by rollups. More and more state roots are going to eat up, and state roots, while you can optimize them, and we'll sort of get into that later, but ultimately, block space is again going to become a premium. And we need to figure out some interesting ways in which we can settle, we can solve for incentives, and we can achieve the kind of performance we need without sacrificing security assumptions. So ultimately, you also have this L3 app chain narrative going on these days. You can build your own app chain. I think so many people want to do that. Should they settle on Ethereum? Should you only settle on L2? How does, for example, the hyperchain model work on ZK Sync? Some of these things have been discussed from a technology standpoint, but ultimately, what you really need to solve for is how do you create value of the token of the chain building on top. So all of these chains, which are L3s, all of them are going to have their own tokens. How is the underlying layer going to build value accrual for those tokens? Ultimately is going to be the main kicker. And of course, value lies sort of in derived security and faster finality, but along with ecosystem benefits. So for example, if you're building your own L3 chain, should you build it on ZK Sync? Should you do OP Collective? How do you make that decision? And what we've seen time and time again is that the ability to get speed, execution, finality is something we've continuously become better at solving. But how do you help the ecosystem? And what does the ecosystem benefit look like? Ultimately, when you have all of these different sort of chains fighting with each other, you Scroll, you have Polygon, ZK Sync, OP, Arbitrum Nova, how are they going to help you design your ecosystem? And how they're going to help you create value for your own token, ultimately, in my opinion, is going to be the most important factor when you make this kind of a decision. And that's kind of why ecosystem benefits ultimately are going to be a very big factor. So for example, when we try to, at Mantle, talk to chains who want to build L3s, the main conversation always is around ecosystem benefits. For example, liquidity, listing of tokens. And what else? Can we create markets for the tokens building on top? And if you go to the next layer, right, so data availability, of course, is now this hot new layer, right? We've got Celestia, we have Eigenlayer. So we went live with Eigenlayer, but we've been talking to Celestia for a while. There's also Polygon Avail. So many different data availability solutions with different, let's say, security assumptions are also there. And we also have ETH restaking now as this new primitive, where you can take, for example, the economic value of a token, and you can use it for utility versus collateral-based yields. But ultimately, you again have to create utility for the chain token. So for example, in our case, what we liked about EigenLayer is the fact that we could restake ETH and get security, but we could also take our own token and stake that on the data availability nodes, thereby creating yield and value for our token. And this is super important. So whenever you talk, like for example, about Celestia or Avail, luckily all the founders are here, so I can quiz them about these things. But how are you going to help my token? And where do the ecosystem benefits lie? So with more data availability solutions, ultimately the ability to solve token-related and value-related problems is going to become more important than any piece of technology out there. And we're just at the start of data availability. So I expect to see like more economic value sort of, or rather more like different approaches to economic value come out in the time to come. But this is like the main question I literally have when I talk to like data availability players out there. And if you go to the next layer, right, the consensus layer. Now, again, like consensus layer is a total war zone right now with ZK VMs, optimistic, rollups, Arbitrum doing their own thing. The shared sequencer approach is also interesting, but again, the question is always the same. How do you create yield, right? So you have all of these ZK provers, you have like shared sequencers, shared bridges, fantastic. How does it help my token? Like, how does it create value for me? So I sometimes feel that we talk a lot about technology, we talk about EIP 4844, we talk about Workle trees to reduce proof size and optimize all of these things. But ultimately, and yeah, you can find gas fee extraction models and offer yield on decentralized designs, but how does it create value? And ultimately, these are the conversations we need to start having. So, I think we need to start looking a little bit beyond the technology and try and see how we can solve for value in these decentralized designs. I'm just going to keep it really short, and this is basically the last slide, but ultimately, technology will decide if we can build modular chains, but ultimately, the incentive design is what will decide how we do these things, how these execution layers come together, how these data availability layers come together, how the consensus layer comes together. So no value, no token equal to no bueno. And we need to really solve that. So, anyway, thank you so much for listening. I just wanted to keep it really short and want to get more people start talking more about incentive designs. And I think the key of how we're going to implement all of these things lies in the token itself. So anyway, thank you guys. That's really it.
You want to maybe take some questions?
Oh yeah. Do you guys have any questions? Anything you want me to cover about incentive design?
How are y'all thinking about basically the ossification of incentives, right? EigenLayer, y'all kind of beat EigenDA before they even were out, right?
Yeah.
If that's part of your token model, and you get surprised by how the economics are working at 6 months and a year, does that put Mantle in a really hard position?
Not necessarily, because the core security assumption or the underlying infrastructure of how EigenLayer is built is already set in stone, right? Because it's in the white paper. So it's kind of already decided upon. Now, the way to think about these problems is that the way you solve modularity with technology, you cannot really change that. So I'm actually against changing technology to fit the incentive model. What we need to do is take the infrastructure, like whatever the security assumptions are, whatever the restaking layer is, and what we need to do in that is bake economics into it. So the data availability nodes, which is securing data availability for many different chains, which is ultimately secured by the underlying EigenLayer restaking infrastructure, unless you can offer some token utility there, I feel chains may think twice before adopting this kind of a sort of a data availability model. Right? And similarly for Celestia, Celestia has got such an interesting model itself, right? Which is a little more optimistic in design. Polygon Avail is using Caldera polynomial commitments. But ultimately, how they create value for the network's token and where those benefits lie are going to be like super important. So I don't think these companies or anybody else building this needs to change the infrastructure. They need to just figure out how to fit an incentive design into their underlying infrastructure. So EigenLayer is doing that using nodes. I think Celestia, I'm sure, will have some approach. I think Avail is going to be live possibly by Q1 of next year, so I look forward to seeing how they sort of solve these problems for networks. Does that cover the question?
Yeah, it's kind of more of a question about Bit, but like how Mantle themselves are thinking about incentives, right? Because you're using that both on the gas fee context And I guess if DA stakers are also staking.
This is the so I would say that in terms of token, what I would say is that how we plan to structure it as an ecosystem token. So it'll be used for gas fees, it'll be used for infrastructure staking, it'll be used as the ecosystem token, it'll be used for governance, and then it will also be used in all the other protocols we're building, like the liquid staking derivatives protocol, which we also plan to roll out possibly by Q4 of this year. So the token will have utility across all of these sort of, you could say, infrastructure pieces. So that's kind of how we've designed the token, and whatever is produced in the future and whatever products we're going to make, we're going to ensure that we bake in some sort of incentive design.
Cool.
Yeah. All right. All right. In case you have any other questions, you can always just reach out to me on Twitter. It's first name, last name. And Telegram is also first name, last name. So you can just feel free to ping me. Yeah, just it's only first name, last name, because there's another Arjun Kalsi out there who's going to ask you for like 1 ETH because his dog died. So just be like really careful. Right? So it's first name, last name. All right. All right. Thank you, guys.
All right, so I think that concludes the first half of the day. There's going to be lunch in the main room, and we start in an hour again. So see you back then.
Okay, hello. Welcome back to the afternoon of day one of Modular Summit. Hope you've all been having a great time so far. My name is Jill Gunter. I'm with Espresso Systems, and I will be your MC for the Fourier stage this afternoon. And first up, it is my honor to introduce my friend and co-founder, Ben Fish, from Espresso Systems. We'll be having a whole track here for the next hour and a half on the topic of shared sequencing. And first up, Ben will be talking about why dumb blockchains require smart solutions. So without further ado, I think we'll have some more people trickling in here, but I will hand over the stage to Ben. Thank you so much.
Okay, thank you, Jill. Right, so does the clicker work? Nope. Back one slide. Perfect, right. Dumb blockchains need clever titles. This talk will primarily be about shared sequencing in the modular stack and is somewhat related to the title, or maybe not. But as it will become clear, shared sequencers are designed as dumb or lazy ledger systems that don't execute transactions and just sequence. And that poses some challenges that requires some solutions. First, just quickly about our organization, Espresso Systems. We are a team of engineers, researchers, and designers. We're building infrastructure that is going to assist Rollups to achieve better scale, better interoperability, and better security. We are a very distributed team. I am Ben Fish, and I am the CEO, and my colleague Jill was just introducing the event. She is our Chief Strategy Officer, and there's a number of other executives as well. So let me start talking about this problem of sequencing in the rollup ecosystem and the modular stack more generally. But first, a starting point is to talk about what exactly are rollups doing. Okay, so rollups are horizontally scaling the application layer of blockchains. Primarily today, rollups are being built on Ethereum, but of course, or on top of Celestia too. So if you view Celestia as an L1 as well. So, but in general, the idea is that the layer one, all it does is just verify fraud or ZK proofs. It may also provide availability of data and some other services, but it doesn't execute transactions. And so as you add new applications, the reason why this horizontally scales is as you add new applications, you don't burden the layer one with having to execute for those applications. You can introduce a new set of servers that executes for that application and just proves the state result to the L1. Rollups are applications that host other applications. So things like Optimism or ZK Sync are general virtual machines which can host other applications, but now we also have app chains that just execute their own application-specific states directly, and all of these are horizontally scaling the execution layer of blockchains. Another key point, besides sharding of computation across applications, is that rollups leverage heterogeneity in the network. They're leveraging the fact that realistically in networks, not all nodes are the same. If we want to scale layer ones to be extremely decentralized, so that there's 12,000 nodes participating and one of them is a Raspberry Pi, or as I heard yesterday, apparently a Turing Pi is a thing too. But then the weakest node obviously will not be able to compute transactions as fast as the strongest nodes. So rollups allow the more powerful nodes to do even more computation. When we're talking about ZK rollups, it's 10,000 times or more expensive to produce a proof than to even just execute itself. So we increase even more the computation of some powerful nodes, and this helps weaker nodes catch up. So the thing is, today, rollups control a lot. They control a lot more than just doing execution and horizontally scaling Ethereum. In fact, they they centralize the entire process of deciding which transactions to include and in what order. And this brings us back to a world in where there are central actors that have the power to discriminate, that have the power to impose monopolistic pricing or maximally extract MEV from users. And these are all the things that blockchains were promising to get us away from. If you think about it, the rollup ecosystem today is essentially Web 2 applications that are being audited by an L1, right? But the actual processing and everything is really just being done by the Web 2 application. It's just being followed and verified by an L1. So what is the solution? One solution is to separate ordering from execution. Right? So that application layer rollup servers will execute transactions and not handle any of the ordering process, not handle any of the process of even making data available. The L1 would not build or execute. Its roles would only include finality on transaction ordering, availability of transaction data, and the verification of state proofs. And users would submit transactions directly to this decentralized L1. So this has also been called a based rollup architecture, where you have the consensus network that users submit transactions to, rollup servers read a transaction stream from this consensus network and then post the state root and a proof, like then gets verified. Challenges arise from this, however. If the L1 is not doing any of the execution, then how does it set prices for including transactions that doesn't execute? How does it verify that the fees that it's receiving are paid correctly? Does it need to have some kind of minimal state to do that? How is revenue that it's generating shared back with rollups or applications? How do we prevent spam? Could the L1 overload the proving network without compensation for work? All of these are challenges, not all of which I will address in this short talk today. But these are all things that need to be considered when working with such based rollup architecture, or more generally what I would call decentralized sequencer architectures. So we can also look at hybrid centralized base architectures where, and this has also been called escape hatches or L1 inboxes. I would say that is a form of based rollup where, or related to, maybe not exactly the same, where there is a designated rollup server that can order transactions, but users can also submit directly to the L1. So the L1 orders some of the transactions, the designated rollup server orders others, and we have some way of deciding, well, maybe the transactions from the rollup server go at the head, maybe they go at the tail. There's different approaches to doing that. And this hybrid architecture can be applied to any decentralized sequencing design as well. We can mix and match. So there's also perhaps a reason to separate the order finalization layer, at least logically, from the layer 1. And why might we do that? Why would we use anything except for Ethereum's Gasser protocol today for ordering and making available transactions? Well, specialization, right? Ethereum makes some decisions on how it works to optimize for certain sets of properties. For example, Ethereum is extremely available. Ethereum is extremely decentralized, right? If you wanted to design a protocol that is still decentralized but prioritizes fast finality and can give faster pre-confirmations, then that could be a reason to design another layer. If perhaps it's something that's designed for high throughput data availability, that's another reason to design what I would call some layer 1.5 that sits between the layer 1 and the layer 2. So protocol modularity, opportunity to make different design trade-offs, higher throughput, lower latency, faster pre-confirmations. When it comes to talking about faster pre-confirmations, a common misconception is that Ethereum's finality is 12 seconds. This is not actually true. This is the average block time of Ethereum. Transactions must be several blocks deep to be confirmed. And it takes, in fact, 15 minutes for transactions to finally be finalized by Casper FFG, which is the finality gadget of Ethereum. Often users may consider a transaction final after 5 minutes. Some may consider it final after 12 seconds, but that's very, very risky. You can read more about this by looking at Ethereum's discussion. Vitalik has a post on single slot finality, where he explains that Ethereum's finality is actually 15 minutes, not 12 seconds. So let's say you wanted to design a decentralized protocol that could provide faster finality than Ethereum. Why doesn't Ethereum have fast finality? Well, it runs something called a dynamically available protocol, which means that even if 10% of the network is online, not 100%, it still can process transactions. It still can make progress. Bitcoin has this property too. This is in fact one of the innovations of consensus protocols in the last 10 years. That started with the Nakamoto Consensus Protocol. But we also have protocols that are on a different side of what's called the cap theorem, meaning they cannot be dynamically available, but they can achieve what's called optimistic responsiveness, which colloquially may be called fast finality. And optimistic responsiveness is the ability to respond as fast as the network will allow. When network conditions are good, the consensus protocol can give you instant finality. It also has an asynchronous fallback path so that if the network conditions aren't good, it will eventually make progress. But it will stall if enough nodes go offline, right? Ethereum doesn't have that property. Ethereum cannot achieve fast finality because it will remain live even if a small participation set is online, whereas protocols like Hotshot developed by Espresso Systems will go stall if too many nodes go offline, but if they're all online and the network conditions are good, they can give you very, very fast finality, almost like a centralized sequencer. There are protocols that achieve neither property, like Tendermint. So responsiveness is the idea when there's a high rate, when the sun is shining, you get this high rate instant confirmation, but it's still robust when it's raining. Right? So we call this Web 2 performance with Web 3 security. We can also blur the lines between, the physical lines at least, between the layers when it comes to things like eigenlayer. Things like restaking enable you to incentivize or at least subsidize the participation of the L1 nodes in this layer 1.5. So that the same physical set of nodes are running it and you're making the same, ultimately the same trust assumption, but just the protocol properties are different. So, moving on to sort of a second challenge, fragmented liquidity and interoperability. It's beautiful that this application layer is being sharded by rollups, but this fragments the interoperability. So now two applications can no longer call each other. They can no longer make function calls to each other. Your Aave liquidity pool is no longer shared across all applications if they sit on different rollups. Bridging across rollups is complex. Atomicity is limited. So how can we recover this? And specifically, to what degree does sharing an ordering layer only, and not an execution layer, which would make everything the same rollup, right? Does sharing an ordering layer only help? Okay? So this is the next question I want to explore. So there are three advantages. I will only focus on one. One advantage is simplifying cross-rollup bridging and atomicity, because you are sharing at least the same ordering protocol. So you don't have to verify each other's consensus. The second is mitigating what I would call systemic risks of bridging overall and the opportunities for profit that they provide to adversaries. You can mitigate that and reduce it by sharing a consensus protocol. I won't address these first two, we have blogs on it, but I will focus today on explaining why this supports what I would say cross-rollup building with economic bonding. This is not the same as sharing an execution layer, but it gives you some very interesting guarantees. So first, quickly on proposer-builder separation. This is the way things work in protocols like Ethereum today. It also works like this in Hotshot. There's a proposer that's elected by the consensus protocol in every slot to propose transactions. But this proposer, while it needs to sign and broadcast information, doesn't need to come up with everything that needs to go into that block. That could be outsourced. In fact, it could run an auction among competing builders who are able to build an optimized block. There are different things that this might be optimizing for. Generally, if we let the proposer run this auction, then naturally the builders who win the block auction are going to be maximizing the revenue of the proposer. And that's what motivates us to do some other designs, which are designing like an ideal functionality that implements an order flow auction, which is optimal for users and stable for users. Could we design something where users are getting the best execution prices available to them, or guaranteed that their transactions don't fail? And this is something that the teams like Flashbots and Suave have been working on, and other teams too, and is sort of the future, I think, of sort of the order flow design of blockchains. But in order for this to work, the consensus protocol needs to be extremely decentralized, so that the proposer doesn't just say, okay, you know what, screw this ideal functionality, it's not good for me, it's not maximizing my revenue, I will just run my own auction the way I want to. No, if it's extremely decentralized, the proposer gets elected once in a blue moon. It can either take transactions from the ideal functionality or have no transactions at all. It can't make a credible threat to users to abort the ideal functionality. And that's why decentralization is important. This is, in fact, why EIP 1559 works. It only works because Ethereum is extremely decentralized. But with proposer-builder separation over an extremely decentralized shared sequencing layer, decentralization is key. Then you can also introduce these builder functionalities on top. And these builders or ideal functionalities can also start to provide some interoperability guarantees. Example, a builder could say to a user, okay, the user wants to trade on Optimism and ZK Sync. It sees some arbitrage opportunity. It wants the builder to include both of these transactions in the block and ensure that they both succeed. Because the builder is basically able to win this auction of a super block wholesale that sends blocks to both ZK Sync and Arbitrum, it controls, it basically has a lock on the state of both ZK Sync and Arbitrum, and thus can make this guarantee to the user. It can promise that it will include both trades in the same block, and it can also write this promise in a cryptographically authenticated way so that if it violates this promise, then the user can go to some smart contract and slash it. Okay, so if I don't do this, then you can use this as evidence to slash me. And it can put up a big collateral in order to give the user confidence that this promise will be satisfied. This is a simple example, but we could go through an example of even cross roll-up flash loans. It will take more time, so I don't have time for it in the short talk today. But just to summarize, so Espresso sequencer is one of these layer 1.5 sequencers. It sits between the L1 Ethereum and Rollups, although we're trying to blur the physical lines by using eigenlayer. It provides this consensus on ordering, but that also supports proposer-builder separation, and we envision most blocks being built in that builder layer, which can actually provide the interoperability guarantees to users, which wouldn't be possible if you had different consensus protocols, because builders would not, builders would have to simultaneously win many auctions, and that carries a lot of risk. A common concern is how is revenue from cross-rollup bundles allocated back to rollups. Another common concern is whether this leads to builder centralization. To address the first concern, the concern that builders will need to execute for all interoperable rollups, and that may create a higher barrier to entry, leading to fewer competing builders. So first, I think it's important to recognize that builders and validators are not the same thing, and we don't require the same level of decentralization at each layer of the stack. We need to work from first principles and look at first of all, what does decentralization mean? Does it mean a lot of economic stake? Does it mean a lot of distinct physical nodes? Does it mean geographical? And what is required from each layer given the service that it's providing? Executing for all rollups is not actually that hard. Maybe it's hard for 12,000 nodes, including a Raspberry Pi. Maybe it's just hard for a Raspberry Pi. But executing is not a huge barrier to entry, and we don't necessarily need 12,000 competing builders. We just need enough competing builders to create competition in the market that drives down monopoly pricing. Not necessarily 12,000 of them. So it's unlike the decentralization requirements of proposers. And in fact, if you have a highly decentralized base layer or a consensus protocol, then that's what enables proposer-builder separation. That's what makes these proposers more passive and able to be compatible with ideal functionalities that are designed in an ideal way for users that are thus stable for users. Furthermore, the barrier to entry is much higher without shared consensus, because it requires more capital to win simultaneous auctions. The builder absorbs more risk, and it can't promise user atomicity without this risk. This phenomenon of builders executing for all rollups is an inevitable consequence of the user desire for interoperability. It will happen no matter what. And so I would argue that designing a shared sequencing layer is going to lower the barrier rather than create more asymmetry among builders and increase the barrier, which is the alternative of many independent rollups with their own sequencers. So this is a small meme about that. Right? Well, where there's a will, there's a way. Builders that execute for all rollups anyways will find a way to do it. Shared sequencing enables more builders. I don't want to go into the revenue sharing problem because I'm out of time, but I just want to say it's connected to order flow auctions. And there's a cool idea of splitting up slots so that at even slots, you don't have cross rollup bundles, and it's very easy to divide the revenue. And in odd slots, it may be trickier, but you get a good approximation from the even slots of what to do in the odd slots. Announcements. We have a Doppio testnet. We also have double shots of espresso available at our booth. But the second testnet of espresso sequencer called Doppio is now released, and it features an end-to-end integration with Polygon ZK EVM, a fork of Polygon ZK EVM. Next, we're working on OP-Stack integrations. We're working with Caldera, Spire, Catalyst, Injective Alt Layer. We recently won an Optimism sequencer decentralization RFP, so we'll be working on that. And here's a little picture of our little growing ecosystem. If you want to join this, please let us know. We're happy to talk to everyone. So thank you so much.
Great. Thank you so much, Ben. We're going to be hearing more about shared sequencers next. We have Josh Bowen, CEO of Astria, coming up, who's going to be talking about Astria speed running the end game. Josh, over to you.
All right, hey everyone. Thanks for having me. So yeah, as they said, I'm Josh. I'm the CEO, founder of Astria. Okay, which button? The green one? Okay, all right. So I actually renamed my talk Astria's Vision for the Endgame. I used the talk Speedrunning the Endgame previously, so I got the slides in late. But what I'm gonna walk through here really is what Astria's architecture looks like and kind of the top to bottom of like why we're building the architecture we're building. Because as shared sequencers have gained prominence in the last 5 months since this has even been like a kind of a concept, there's been a lot of questions about like why it should be designed one way or another, and so we're gonna give that. And so for Astria, we have like two kind of key principles. We think that rollups should be decentralized by default. This is generally a pushback on the idea of this progressive decentralization, which has been promised by a lot of different rollup networks, but quite frankly, we haven't seen it. We're 18 months into mainnet on a lot of rollups, and they're still just as centralized as they were day one when they launched. So we believe that if we want to see a world with many, many rollups, they're going to be decentralized by default. Otherwise, we'll have this recurring window of we launched it, it's centralized, we'll get to the decentralization later, and there will perpetually be newcomers that are just centralized. So that's principle one. Principle two is that we believe deploying a rollup should be as easy as deploying a smart contract. Also, am I going to get a clock time there, or should I just guess? Okay. So we believe deploying a rollup should be as easy as deploying a smart contract. And now I'm just going to go into kind of architecture stuff. I have 53 slides to get to, so I'm going to talk quickly. This is how we view the general kind of transaction thing. You could call this like the transaction order flow, but we put it in a kind of 4 stages, and noting that we are, or at least myself, is not in the camp of a rollup being defined by its bridge. So that's just, you can argue with that. We have a panel after where we can fight. But we believe we start with unordered transactions that could be intense. We go to an ordered block. From that ordered block, we end up with an executed block that has a state DB and presumably a resulting state root. And then after that, you can have a succinct proof or a ZK proof. And that is kind of what we're going to argue the ordering. We'll label these as order flow, sequencing, execution, and proving, and view those as 4 phases. Again, people can disagree with terminology, but I have to pick some semantic definitions to go with, right? Okay, so state of sequencers today. This is what I'll argue is kind of the most simple case for a centralized sequencer today. You have an end user. They're going to talk to a rollup sequencer, get a soft commitment there. As it's one box, that's a centralized sequencer. That sequencer pushes batches to the DA layer. You get a firm commitment for that. What are the problems with that? Like, why would we decentralize? A sequencer's typo there. Because this rollup sequencer that is centralized has a persistent monopoly on ordering, right? And that's a problem for any number of economic reasons, on transaction flow, on censorship, right? But we don't want to have one party that has a persistent monopoly. And when we say persistent, we mean across all time, right? Across blocks. So if we go to a decentralized sequencer where we'll just simplify it and say we have a leader rotation, so there's multiple entities, this is still for one rollup, but multiple entities get a chance to be the sequencer for the block and everything else is the same. We move to having a per block monopoly on ordering. This doesn't resolve everything, right? We've seen a lot of like interesting designs like multiplicity for like multi-validator, like block proposing, but it is, we'll argue, better than having a persistent monopoly across all time. There's various research on MEV things where you can maximize MEV by extracting no MEV in one block and putting all that MEV in a second block. We remove cases like that when we say there's now a per block monopoly on ordering. You can't guarantee you're getting multiple blocks, or at least it's probabilistic. We'll argue that's better, right? So why shared sequencers? Why would we want to go from decentralized for one rollup and many rollups having many decentralized sets to shared? And this is what we're going to posit as like a model for this. You'll still have a user. They'll communicate with the RPC for a given rollup. So this is your MetaMask to like a guest node or whatever. And it will push transactions to a shared sequencer. We implicitly assume the shared sequencer is decentralized here. And so what are we doing here, right? Now we're shared, right? Here we have multiple rollups. Users still can interact directly. There's more complicated designs, but for this talk, I'll limit here, where you can have multiple rollup RPCs sharing a sequencer. So this is our kind of simplistic model. It's very similar to like the Espresso guys' kind of more complex like diagram, and they have a great demo visual on Twitter that you can look at. Come on. Right? So what is the user actually getting from a sequencer commitment? When we say it's like a soft commitment, what are they actually getting out of it? So I really like this quote. I've used this a lot of times. It's from Nick Carter's article, It's the Settlement Assurance is Stupid, from way back in 2019. It's obviously Nick Carter, right? It's a little bit Bitcoin adjacent, but I think it is some of the better written work on what we're talking about when we get a commitment of finality. And so settlement assurances refers to a system's ability to grant recipients confidence that an inbound transaction will not be reversed, right? This is usually used in the case for the specific article of Bitcoin. This is the 6 confirmation depth thing, right? It's probabilistic finality. When do you know a transaction will be reverted? We'll say settlement assurances or settlement is this act of not being reverted. So we'll say a sequencer guarantees a user that their transaction will not be reverted, right? And then if we think, okay, is this a settlement layer, right? We have this quote from James Presswood. We actually pin this in our marketing channel in Slack. This is one of the things that was influential in moving from we're building a settlement layer to we're building a shared sequencer. The term settlement layer is very busy, muddy, right, and confusing. So we're not going to use that. But why shared sequencers, right? Come back to this question. Why would we want a shared sequencer? We argue, again, from the Nick Carter, It's the Settlement Assurances post, right? Ledger costliness is the most profound and direct variable available to us to evaluate a blockchain settlement guarantees, but simply it's the equivalent to the amount paid to validators/transaction selectors per unit of time. So in like a Bitcoin case, which is probably the most simplistic one to understand, this is like the amount of computational effort put into a given fork of the chain, right? And literally the money burnt to give you that layer of like settlement finality, right? In a proof of stake chain, in like something like Ethereum, right, where you still have like a heaviest chain and it's slashable, right? It is the depth or like the weight of a stake that has been posted on one given fork of the chain, right? That's your like, that's what you're gonna call ledger costliness, right? So we argue that sharing a single sequencer set between multiple rollups will increase the ledger costliness, right? And what we mean by this is if we have, 10 rollups and we'll assume they have kind of heterogeneous transaction flow, right? They're maybe not all EVMs, they're maybe serving different use cases, and they are all relying on a single point of settlement, and they are doing like a proof of stake mechanism, or even if it's something like, a proof of governance, or just like kind of an implicit governance kind of chain link style implicit staking, right? If you have multiple use cases and more order flow using a single point of settlement, it has stronger guarantees if it is shared between all entities rather than each of those rollups attempting to acquire its own kind of set of ledger costliness, right? So this is what we'll look at, right? We look at this architecture. We'll assume that the soft commitment has a high likelihood that transactions are settled. Specifically, if it's shared, we can assume it is a higher likelihood that the transactions are settled in a shared set than if it was decentralized across any given rollup. So then we'll say, why lazy shared sequencing? And so again, I think our architecture and Espresso's architecture is implicitly, we say it's a lazy shared sequencer. And what we mean by this is it's not executing the state transitions, right, to the original picture. It's doing the ordering, not the execution for all the rollups. So why are we doing that, right? Well, really, there's a question of why wouldn't we do the stateful shared sequence? It would be really nice if we could say, hey, we all do it in one go, and we all get this commitment over a state root, and we get the ledger costliness, and it's nice and clean. Why are we not doing that? That seems like the obvious, nice solution, right? We'll argue that the resource requirements for a stateful shared sequencer, one doing execution for all the rollups, scales in proportion to the number of rollups. It's not explicitly the number of rollups, right? But if you assume that I, as a validator set, a sequencer set, need to execute 3 different heterogeneous state machines, I need to keep the state, and I need to process and do the execution, use the computational power and the storage requirements to keep all these states in these ledgers. That increases. If I add another rollup, then I have to pay more cost, right? So going back to one of our principles, deploying a rollup should be as easy as deploying a smart contract, right? If it's a stateful shared sequencer, it prevents permissionless use of the shared sequencer. And what this means is, if you are introducing, every time you add a rollup to a shared sequencer, you increase the cost, the resource cost, to the actors in that sequencer set, then that cannot be permissionless because you've now introduced a DOS vector, right? I can go say, I'm going to go make 10 rollups, and I'm going to push them into the shared sequencer, and I've just increased the workload of all these entities, right? So if we look at things like Polkadot's parachain auctions, right, that is a mechanism to create an economic cost to join the sequencer set, the validator set. If we look at interchain security with the Cosmos Hub, now replicated security, right, there is a governance process. You need to convince the validator set that they should allow your state machine to join the set. And we believe that it should be as easy as deploying a smart contract. You don't need to ask for permission to deploy a smart contract. You simply go to the chain and you pay the gas fee and you deploy your contract, right? So that's one of our arguments for why we should use a lazy shared sequencer. But then going back, if we're not doing the execution right, what is a lazy shared sequencer actually guaranteeing to our end users, right? And we're going to argue that a lazy shared sequencer guarantees that a transaction's position in the canonical block ordering won't be reverted. So specifically, this is a weaker guarantee than saying the resultant state root of your rollup is X, right? And it's actually giving you this state root hash. If you're familiar with like a Tendermint kind of Cosmos space, there's a distinction between Tendermint giving you a block hash and the Cosmos giving you a state root, right? We are talking about a block hash, right? You're giving a commitment of the ordering of a given block, but not a state root of a post-state machine execution, right? And so we argue again, right? Deterministic state machines is kind of what we're doing with blockchains generally, right? A chain state is determined by recursively applying its state transition function to an input state in an ordered block, right? So very simplified function here, right? If we're at state 0 and we want to move to state 1, we provide block 1 and we just run the state transition function. Now we have state 1, right? I'm not like a math guy. I don't know what the math symbols would be to recurse this, right? But run that every time from Genesis, you now get the resultant state root. And the important thing here, right, is that from a Genesis state, if you have access to all of the ordered blocks for a rollup, but not the state commits of those rollups, you can still, as a full node executing that, deterministically reach the same end state as everyone else for a given fork of the rollup, right? So we still have the capacity to do this execution. But really what I was like, when are these blocks actually being executed? Like who's doing this execution if not the sequencer set, the validator set, right? So this is when we go to like Ethereum land, right? So this is a picture from mevboost.pix. It's a great dashboard place to look for like information on mevboost. When I checked on, looks like the 16th, right? We're at 95% of Ethereum validators are running blocks through mevboost, right? Or like 95% of the blocks on Ethereum overall are mevboost. So we're pretty close to 100% of people are using PBS for this, right? And then let's look at the relay dashboard, right? So within relays, there's really 2 types, right? I guess there's 3 types if you consider the censorship ones like a type, right? But we see the largest relayer, 28.3%, is the ultrasound relay. And the ultrasound relay is considered an optimistic relay. And what we mean by that is that validators are actually not checking the block that is given to them by a builder to ensure that it is a valid state transition function. They're not re-executing. The reason they're not doing that is they save some milliseconds of latency by not doing that execution. And the way that PBS works as an auction mechanism, builders want to be able to submit their blocks as late as possible in the block timing. By shaving, let's say, 100 milliseconds off of that, they notably change the amount of order flow, the amount of blocks that are sent to them as a relayer, and they're all competing for order flow, right? So by just saying, will YOLO, right? we're going to assume that builders are not sending us fake blocks, and we will not execute that, right? So what we argue is 28% of all blocks, 28% times 95% is like 26.8% or something, of all blocks going through Ethereum today, the validator is not actually executing the state transition function. So what does that mean? Where are these blocks actually being executed? So we'll argue this is like a rough design for how we would see a shared sequencer having like a PBS MEV supply chain order flow, right? Users go to roll up RPCs. Those RPCs could be, MEV supply flow. We could have like Suave, whatever, right? But they'll go to something that's order flow. And we're going to assume that order flow is a thing that takes transactions. Maybe there's bundles in the middle, searcher, builders. They're not that distinctive parties actually in actuality at scale, but it outputs blocks to the shared sequencer proposer, right? And the important aspect of this diagram is that to generate these bundles, to generate these blocks, execution is needed to find profitable blocks, right? If we think about what we saw with MEV, before MEV guess, this is pre-merge, right? What would you do? You'd do a priority gas auction. You'd spam the chain to try to get your transaction, and it would revert if you didn't like it, right? We introduce an auction mechanism, and actually it's not economically desirable, it's not like game theoretically optimal, to go submit non-functioning blocks, right? If I'm like a PBS person, I can like go grief the chain, but if I'm here to make money, like I'm a sophisticated professional actor, I'm Jane Street, I'm Jump, whatever, right? I want to make money, so I want to submit good blocks. So I have to do execution, I have to run the knapsack problem across, all the state machines and theoretically find what is the optimal block, right? It's like a PNP problem or whatever, right? They're going to do execution to find these profitable blocks, and they're going to know whether a block works, right? And so the shared sequencer, this is the key thing, defines the canonical block ordering, but really what it's going to do is it's going to choose the most profitable block that is offered to it, and structurally a shared sequencer is essentially the same thing as an optimistic relay, right? It's going to be given a bid and a block, and the economic incentives say that the people who are going to be sending it blocks are going to send it profitable blocks, and profitable blocks are going to be executable blocks that are valid, not blocks that are just kind of griefing the chain and saying, oh, look, you have a block, and it's just going to like revert or whatever, right? So that's our argument of like where the execution is actually happening in this stack. We can have like a lot of debates maybe in the panel on like the trust assumptions you're making, whether you've moved to economic assumptions instead of like programmatic assumptions or cryptographic assumptions. But remember, this is where 27-ish% of all Ethereum blocks are already being pushed this way, and that's relatively stable, but we could see increase, right? This is status quo today. So we'll touch on bridging really quickly here, right? We're not doing the execution. So when we go to bridging, right, is a rollup defined by its bridge? Not answering that question here. But if we say 3 components of bridging, right, I'm going to argue that bridging is between a sending party and a receiving party. And the key of bridging is that a sending party has to convince a receiving party that the data is available, that there's a canonical ordering, and what the post-execution state is. This is broadly what like a contract on the receiving side of a bridge is looking for, right? If the data is available and we have shared DA, we're going to say that's a trust minimized bridge. We're not going to go too much in depth to that, but that's generally what we're looking at in like the rollup sphere. But really, when we look at this kind of order flow diagram, we're going to say the soft commitments, again, the shared sequencer is defining the canonical ordering of the chain. So we're getting a canonical ordering between all the rollups on the shared sequencer. The firm commitment coming from the DA layer, that's giving you your data availability. So then the question is, who's attesting to this post-commitment state root, right? Who is actually executing the chain and saying, I will give some kind of guarantee, cryptographic, economic, whatever, of this actual post-state root. So what's the state of the world today, right? The status quo, EVM chains by and large, so whether you want to say like a Gnosis chain, you want to look at like the rollups between each other, right? They're often not going through the optimistic bridge. 7-day withdrawal window, that's really a long time, right? So you have mechanisms that can use Connext, they can use something like Hop, but in reality, a lot of them are using things like Layer 0, they're using things like Axelar, they're using things like I'm forgetting the third one, Wormhole, right? Fundamentally, I'll consider those third-party committee bridges. You have some off-chain set of actors that are making a multi-sig attestation and staking their reputation, maybe they have an on-chain stake, on the validity of that state root. Comet BFT chains, they're using a native validator set. It's still a committee bridge and it's still an attestation, making it on its majority assumption, but they use their native validator set, right? We'll say this looks like this, right? You have sequencing, you have an ordered block, you can do execution, you get an executed block. That executed block that is implicitly ordered, right, goes into a committee. That committee generates an aggregated signature, whether that's BOS, multi-sig, whatever, right? And that aggregated signature is sent to the receive side, and that's the kind of attestation we're making. What is the next gen, right? We see Succinct Labs working on proof of consensus of Ethereum Sync Committee. Polymer is working on ZK Mint, right? And so what fundamentally these are is we're going to do the whole first step, right? We're going to do an ordered block, we're going to do an executed block, we're going to pass it through some committee. That committee is going to have an aggregated signature, pass that aggregated signature into a prover, and we're going to get what we're going to call like a proof of consensus, to use the Succinct term, right? Why do we want this proof of consensus? It's kind of like an interoperability solution, right? Cryptographic curves are hard to verify. They're expensive to do in contract, right? ETH doesn't know how to verify an ED 25519 signature natively or cheaply for Tendermint. So to go between Tendermint Comet BFT chain to like Ethereum, if you wrap it in a snark, you essentially have a very expensive yet off-chain signature aggregation modification, right? So this is what we're seeing a lot of things move towards, right? But what do we think the end game is, right? We'll argue that prover networks are going to ease the creation of succinct state proofs. Now, I'm not a ZK person, I'm going to go into details of ZK stuff of the storage proof or the state proof, right? But fundamentally, we have things like risk zeros, like Bonsai Network. We have like the NIL Foundation guys, right? We have these people working on networks that say you take a state machine, you do the execution, and you pass it into this generic box of proving, and it's going to give you a Stark, a Snark, whatever, right? It's this succinct proof of execution. That allows a light client to verify it. However, it's worth noting intercluster bridging still needs this proof of canonicity, or this proof of consensus over the ordering, right? Because fundamentally, you can easily generate a proof of a state machine, or theoretically you can easily generate it, but you could generate a proof that is a valid state transition, but is not the canonical chain state transition. So you still need both components, right? What you get with shared sequencing, and it's like 1 minute, so I'm rushing. You get one proof of canonicity from multiple rollups because the shared sequencer defines the ordering for the chains, right? So you can generate one proof for all the chains using the shared sequencer that tells you this is a canonical chain, and then within the shared sequencer, you just need the state proof. So we'll say this looks like this, right? You order a block, that's happening on the shared sequencer. Standard kind of like next gen stuff, right? This is the succinct style stuff. This is the Comet BF, or the ZK Mint from the Polymer Labs guys, right? You generate this proof of consensus, and then once per rollup, you do the state execution, you pass into a prover network, you get a ZK state proof. Both of these things go to your receive side chain. Now you have all the components you want. Again, we can go back and say, if you're in a shared DA layer, you get something trust minimized, right? You know, if this is everyone sharing Celestia, if this is everyone sharing Ethereum, right? You get slightly better guarantees as well. But this is how we view it at like the layer above that. So again, looping back to where we started, we believe that rollups should be decentralized by default. We're giving a workshop at 4:30, like shortly after the panel in the Couchy stage. We're going to show off like what we have for like a demo right now. We have a development cluster very similar to actually like what Espresso has. We'll show you guys how you can run this locally and how you can deploy your own rollups using a shared sequencer. So thank you, everyone.
Awesome. Thank you, Josh. I now see why the original title was speed running. That was truly a speed run. Coming up next, we're going to actually have a panel on shared sequencing. I'd like to welcome Evan from Celestia up here, who is going to be moderating and hosting. The other members of the panel, please come on up as well.
Evan, are you supposed to be on the left? We want to do in order. Sure. You're the CEO of Rollups.
Hello, alrighty. So, the whole theory that I have for this panel is that all the talks that we just saw, they're sort of like movies. This is more like the features on the DVD. This is something to go, you know, get to know these guys. This is something to sort of, I hope that if we don't answer any of these questions and we just sort of go with the flow, I'm totally okay with that. This is just to go with the flow, just something interesting. So, we already sort of have an intro, so I'll just run through these intros really quick. Right here we have Ben Fish. He's the CEO, co-founder of Espresso. He's also an assistant professor at Yale. He has some incredible research that is widely used today. So proof of replication, I just learned this for Filecoin. Literally the most used, I'm supposed to talk on a microphone. Literally the most used ZK proving system today. No big deal. Also VDFs. And even some economics research on mining. Really great work. We also have Connor. So Connor is just a general purpose gigabrain. I have learned so much from him. He's the CEO of RollKit, apparently.
He's an engineer and a researcher at Rollkit. I've learned a ton from Connor about how you actually decentralize rollups and without using consensus. So you use something like fork choice rules. It's really, really interesting work. And you've also done work with MPC, and you're also, you were a guitar teacher. Yes, so he can riff. Okay, and then we have Josh Bowen. So Josh, you are known, I think, for your width and depth of knowledge, which is rare. You've done work, again, also some research at Celestia on execution environments, fraud proofs, optimistic rollups, and before that you were at EdgeNode, right? Yes, and then before that, we don't want to talk about that, no. Okay, that's at Google, he worked at Google. Okay. Okay, so the first question is, what is love? No, I'm just kidding. This is not like the Lex Friedman podcast.
Maybe we could talk about that.
Yeah, okay. The first topic I really want to get into is not really comparing which is best with like consensus and decentralization, but one of the really interesting things with this panel is that we have 3 shared sequencers, or with Rollkit, a way to build shared sequencers as a rollup, but they're all in very, very different contexts. So it's like all of these folks and all these projects are incredibly smart, but they made different decisions based on that context. So if we can dive into the why and the how of why we used the consensus algorithms that we used, then I think that gives us a better understanding over the problems that we're trying to solve, which of course shows us what shared sequencers actually do. Because sometimes if you go on Twitter, one of the leading questions is just like, WTF is a shared sequencer. So we can just go in order. Ben?
Sure, yeah. So the way that I view it is if rollups are built on top of the layer 1, then the default shared sequencer should be the layer 1. If it's not the layer 1, what are you doing, right? Well, you're trying to do something that the layer 1 doesn't provide. So if you're trying to build rollups on top of Ethereum, and I'll talk about building rollups on top of Celestia in a second, but if you're trying to build rollups on top of Ethereum, Ethereum's a dynamically available protocol, meaning it's very available, it works even if 10% of the network is online. It has very slow 15-minute finality. So we decided that, well, what does it make sense to build for a shared sequencer that is not the layer 1 but sits on top? Well, something that provides a different property, and that's fast finality. So that's what Hotshot, our consensus protocol, does. It optimizes for getting 12,000 validators to be able to reach consensus within a few seconds. It sacrifices the availability guarantees that Ethereum has in the sense that if less than 75% of the network goes offline, then it may not make progress. But that is the reason we did that. If you were building a shared sequencer on top of a different L1 like Celestia, which uses Tendermint, then it may make sense to use something else, right? Tendermint, we didn't decide to use Tendermint because Tendermint is not optimistically responsive. That's like a separate discussion. It's like it can have fast finality, but it doesn't necessarily scale to as many nodes if you want to retain those fast finality guarantees. So Hotshot's designed to scale to Ethereum's validator set because we want to be as close to the L1 as possible, just providing a different property, in this case fast finality instead of high availability.
Never thought about using Rollkit as a shared sequencer. That may be a possibility, but we're more interested in using shared sequencers with Rollkit. Rollkit is meant to support all different kinds of sequencer schemes because we've identified many, and the trade-off space between them all is unbelievably complicated. So we like shared sequencers a lot because one of our goals has been to allow people to launch chains without needing to provision a validator set. And when you've promoted that idea and got everyone excited about it, and then they find out they have to have sequencers, then it doesn't seem as cool anymore. So you can do a rollup without sequencers easily if you do the base rollups, the no sequencer rollups, but those inherit the block time of the L1, which on Celestia is 15 seconds. 15-second finality, 15-second blocks. A lot of people want to go faster than that. When people think about rollups, they think about Arbitrum and Optimism, which give very quick soft confirmations and provide a very fast UX to the users. And if you lose that when you go to develop a rollup, you're going to be sad. So shared sequencers let us do this no validator set, easy to launch, and also have the fast user experience. So shared sequencers are probably one of our highest priorities to integrate into Rollkit as soon as possible.
Yeah, so kind of just reiterating what the other panelists have said, right? Like, I take a much more kind of like practical background. Like, I'm not an academic by any means, and so the evolution of Astria as a project came out of my work at Celestia. And broadly, what we were working on was like, how do I deploy a rollup on top of Celestia, and what are the components necessary to kind of do that, right? So we go look at like, why are there sequencers in like Ethereum rollups? We've all seen like the based rollup design mechanism, right? But the fundamental reality was that users would prefer faster response times than slower response times. I often reference, right? There's some research from like 1991 on like how do users feel about like user experiences in like web applications, right? And like roughly it says users want to click a button and expect it to respond within like 1 to 4 seconds. Shorter is better. There's probably more modern research on like mobile UIs, right? Everyone's used like an older phone, or like iPhones are known for having like much faster latency and it feels kind of smoother, right? But users like responsive user experiences. To Evan's point, right? With these centralized rollups, we got these very, very fast responses. And again, I'm kind of cynical or like, I view it as practical, right? If we want to say, hey, we have these centralized sequencers, we want to decentralize the sequencers, if you sacrifice the latency benefit, that is the reason they moved to centralized sequencers in the first place, users are going to say, oh, this is just like a degradation of my protocol. No one in like a rollup wants to be like the first mover to say, cool, I'm going to use the shittier experience that my users like less than the centralized ones. So it's kind of our job if we think decentralization is important, then we need to provide a user experience that is adequate, that users will actually use the damn decentralized thing, because I am not optimistic that users are going to be just like altruistic actors who say, no, I use the thing that is the most decentralized. Like, no, they don't. They use the thing that is convenient for them, that makes their life easy. We need to provide a decentralized solution. And I think shared sequencers are a way to do that while minimizing, again, it should be easy to deploy a rollup, right? We can't have everyone do this problem. Like, if we want 1,000 rollups, we can't have every single project need to do this process every single time.
Yeah, if you, going back to the point of like taking away the fast responsiveness, have you guys ever taken away ice cream from a child? It's like, it's not fun. Okay, so next topic. Another way to think about a shared sequencer is it's a committee, and it can perform some sort of service for rollups as a committee. And specifically, like, there's just like a lot of different services that you can provide doing that. For example, like with Espresso, you can provide DA. And with Astria, as far as I understand, you can do something like IBC and like settlement, like with the EVM portion. So I'm curious to dive into what are the other committee-based services that we haven't already touched on, or what are some committee-based services that you think would be useful for rollups? So again, we can just go in order.
Yeah, well, I mean, it's interesting that you think of it as a committee. I mean, the committee if the committee is like 12,000 nodes, or if there's the same set of nodes as the underlying L1, then it's not necessarily a committee. It's the same physical set of nodes, but it's logically playing a different role of offering a modular component of the overall services that a rollup needs. Primarily ordering, and then availability can come for free as part of that. But then you bring up a good point, like what other services can you get from an ordering layer? So we've been talking about in our talks how shared ordering layers like Espresso, like Astria, also give you interoperability guarantees. Beyond that, if you could think about adding validity checking as well. So what if rollups could also just settle directly to the shared sequencing layer? Then you might ask, well, what is the layer 1 doing, right? Well, the layer 1 is still there. Perhaps the layer 1's being used for availability. But the layer 1.5, for some reason, is better at providing, for example, it may be easier to add a custom opcode to verify ZK proofs at the layer 1.5 that is faster. It really depends on what you want to move between the layers, because the layer 1 can provide all these services as well.
I can't think of anything we want besides a fast, dumb, decentralized ordering machine.
Okay, I'll give a more optimistic take. I guess, like fundamentally, I view shared sequencers, and this is going to my kind of like cloud SaaS, enterprise SaaS background, right? And this is the land of middleware, right? Like when I joined crypto, I think one of the weird things to me was like the architecture was like, oh, there's like Ethereum, and then you just like slap a UI on top of Ethereum, and I'm like, that's not what enterprise architectures look like. There's like 13 layers between like an enterprise service bus and like some Oracle DB from like 2 decades ago, right? And like the mobile app you use to check your insurance, right? Layers exist, and middleware is used to kind of intermediate between these and to like reduce complexity of interactions with like a broader kind of ecosystem of things. So if we think about shared sequencing, again, it's a committee. What can you get from this committee? I think of it as like, we've used the term decentralization as a service, but also it's like, what can a rollup get for free by using a shared sequencer? Again, it gets these soft commitments to like my talk, right? There's bridging benefits. If you say you still need some kind of bridging guarantee of like the canonicity of this chain, this is less useful if you're doing like a settlement to like Ethereum thing, right? Where you say, well, okay, is the rollup defined by the bridge? Well, the bridge on Ethereum has control over the ordering of the rollup in some mechanism, then that's fine from a bridging. But if a rollup wants to bridge to like some extra domain space, it's going to need to make an attestation of the canonicity of its given fork to that receiving chain. We could also think about things kind of like farther out, like, okay, is an oracle, is it a roll-up of like the shared sequencer or whatever, but you could say part of the data stream of this shared sequencer is some set of oracle transactions from off-chain. How is that happening? Is the committee of the shared sequencer having, an increased amount of state and actually making some claim over the validity of, this off-chain data? There's various things like that, but I think really the way to think of it is like, it's a stream of data. Generally, we assume the rollup is only kind of filtering out the stream of data directly relevant to it. There is potentially data you could push into that stream that gives a shared timestamp of it across all the rollups that they may choose to filter out as well. So again, you could have some JSON format for Oracle data, and all the rollups of the shared sequencer can choose whether or not they want to parse out that Oracle data and use that in their state machine. There's a pretty broad design space there, but it's unclear what will be like useful. And I think the research on like what are the kind of trade-offs and security guarantees and whatnot of these things, but like I don't think we're solving the Oracle problem here. But there's potential like UX benefits as like a rollup developer.
Yeah, that's really good. One of the things that I was to lead into the next topic is MEV and PBS specifically. So some of the things that I was trying to hint at is with these committee-based services is that whenever you use a shared sequencer, and if that shared sequencer is using some sort of MEV infrastructure, that MEV infrastructure is like sort of already set in place for you. So to get into the MEV part, monopolies are bad in general. That's usually a safe thing to say amongst crypto people and most folks in general. But we don't always get rid of all of the monopolies. And I think, especially from Ben's talk, you had some really, really good answers to this. So I really want to dig into monopolies and basically profitable censorship. So we still rely, so crypto, like we like to think about getting rid of monopolies, yet we have, each proposer has a monopoly over which block is used for that given slot. So I kind of want to dig into who captures MEV in the system and how can we change that to be more programmatic? And no matter which direction we want to go in, how can we change that? So yeah, we can just, again, go in order.
Yeah, I mean, this conversation is relevant even just talking about layer ones, like without rollups, but the same problem happens with shared sequencing layers for rollups too. So it's interesting that you said, wait a minute, the proposer in a consensus protocol has a monopoly on a slot. It gets to decide what goes into the slot. So this is, I think, one of the really interesting things about consensus protocols. There's a number of papers on this. Like there's a paper called Monopoly Without a Monopolist. A blockchain is a monopolist. A proposer has a monopoly over one single slot, right? Does this slot-based monopoly behavior achieve monopoly pricing? Meaning, do users pay for pay the price that maximizes the revenue of the blockchain, or do they pay basically the market clearing price where supply equals demand? And so, ignoring MEV of ordering and sandwich attacks and all that, right? If we just look at what's the price to include a transaction, EIP 1559 has solved this problem. Users pay, even though the proposer in the consensus protocol has a monopoly, users pay the market clearing price. And the reason is that if the proposer is not willing to process the transaction of a user paying the market clearing price, the next proposer will. So having a monopoly for a short period of time does not give you a monopoly over prices and this is the key property of blockchains. That's why they have to be decentralized, right? Because I'm elected once in a blue moon to process a block, if I don't take the transactions as they are, paying the market clearing price, there's someone waiting in line who will just do it. So I cannot make a credible threat to users to reject their transactions paying below market clearing price. Now, when it comes to MEV, this isn't the case because the transactions are available to me. I can sandwich attack them. I could even get the help of a bunch of builders and searchers to figure out how do I extract as much value as possible by reordering the transactions in front of me. The willingness of a proposer in a later slot to do it without extracting value doesn't matter. I can do it now because the transactions are there now. And that's why we need to move towards order flow auction design, where we introduce an ideal functionality that has a privacy element to it, which shields the transactions from the proposer, builds a system which is ideal and stable for users so that all users submit their transactions there. And then we turn the proposer back into a passive entity that can either take the block output of this ideal functionality or have nothing at all. And again, that proposer does not have the ability to make a credible threat to users to not take their transactions if they send it to the ideal functionality. They just try to take anything that's available to them at the time. And it's very hard to design those ideal functionalities. It involves a lot of cryptography, perhaps trusted execution environments, but that is the direction the industry is going in. That's what Flashbots and Suave are working on, and those only work with highly decentralized ordering protocols. That's why we're advocating for shared sequencing.
So to respond to that really quickly, it's like, in theory, you have multiple different builders. So maybe multiple different swabs or something like that. And the proposers, since they do still have this monopoly for this one block, it's very short, and it's very limited, they still can pick the block that gives them the most profit. So this is sort of where I was...
But the block that gives them the most profit may be the one that has all the users. And the one that has all the users is the one that is shielding users from MEV. So you can either design something that's stable for the proposers, or you can design something that's stable for the users. If all the users are participating only in the order flow auction that gives them the best execution price, the short-lived proposer has no choice but to take from that pool. Otherwise, it doesn't have any transactions to process. It can't make a credible threat to users to say, no, don't submit there, I won't take it, because it has a short turn and then it's gone, right?
I guess I was proposed like the spicy like counterpoint, right, of like dumb flow is dumb, I guess. And like what I mean is that like generally when we think about like retail flow and like users getting sandwiched, it's because they're like unsophisticated actors and like they're not necessarily doing like the labor to find what is like the optimal execution for them, right? And then there's also like we can think about user preferences in like financial senses, but like also in like a product sense, right? So like I spent like years at Google, right? Like what does Google do? Well, Google provides you a lot of free services. But like, are those services free? No, Google's monetizing that on the back end with ads. And why are they doing that? Because users don't like friction, and transactions are friction. You know, crypto talks a lot about transaction friction because if it's like $2.50 to submit a transaction, you won't do it. Well, like when apps came out, like the App Store on like Apple, right? It was like 99 cents to like buy an app or whatever. That's like no money, right? Like functionally use an app for like 10 minutes, you should be willing to pay $1 for it, right? But people didn't. So they made them all free, and then they monetize on the back end. Users trend towards things that are low friction, and then they monetize on the back end. We see this in financial systems, right, with like Robinhood and payment for order flow, right? Users don't think and they don't read the MBA papers that say like, hey, maybe it's suboptimal for you to actually be like submitting transactions that are free, and then you get like marginally worse execution, though the actual quality of execution on payment for order flow seems to be like an unanswered open question from like analytics and like availability of data. But like, fundamentally, like users use the thing that is low friction, not necessarily like the thing that gives them like optimal execution. So I think like again, like I'm very positive on like Suave and like Flashbots, but I think it's gonna be a very hard fought battle to say we are able to convince users that they should only submit transactions to this if that may result in some marginally higher transaction cost for the user, and then someone else comes along and say, I will ruthlessly front run and sandwich you, but you will not pay any upfront transaction fees. The users might say, yeah, I'm fine with that. So I do think there is like something from like a product perspective that may be like trickier to get from like user demand rather than the kind of like, again, like the ideologically like correct of like, we just need all the user flow to go through one of these kind of like TEE environments, and therefore we can't do all the sandwiching attacks when you're like, what if the users just like don't care?
think we're moving the target. I mean, whatever is good for users is good. Like, let's define what's good for users. That's the ideal functionality. Maybe it's not paying for failed transactions. Maybe it's not paying monopoly prices. Maybe it's both. But if we design something that's stable for users, then that will be stable for a blockchain too, only if it's decentralized, and that's the key point. Yeah.
Yeah, and I agree on that. It's just like defining what is actually a user preference across like many parameters is like hard.
Agreed.
If you use a lot of people talk about rollups inheriting liveness and censorship resistance from their base layers. We found that if you build a sovereign rollup on a DA layer, which is built such that it inherits censorship resistance and liveness from its base layer, fundamentally you leak a form of MEV to the validators of the base layer called profitable censorship. And if you don't want to leak that MEV, because maybe you don't want to create anything like gas wars on the base layer, then you can't inherit liveness and censorship resistance from the base layer. So if you're using a shared sequencer and your shared sequencer has its own consensus and its own proof of stake and its own token, the cost to create a liveness failure on the shared sequencer is the cost of 1/3 of the stake if it's Tendermint style. And that could be very high. That could be high enough that rollup developers don't feel as though they need to build a forced transaction inclusion mechanism from L1. It might be censorship resistant enough on its own. And so the shared sequencers can help remove that MEV from DA layers.
This is really, really good. Before we finish it up on MEV, do you all envision any way for a rollup to be able to capture its own value just like that? Like what would be like more of like a mechanism design for a rollup programmatically capturing MEV as opposed to only relying on something like Suave or whatever's built into the shared sequencer?
I mean, I think that if a rollup is using a shared sequencer, then the shared sequencer becomes part of the rollups protocol, and so it does need to be programmed into the shared sequencer. You can always view things as rollups participating in some kind of order flow auction. So if you do design order flow auctions, then maybe there's a way of doing it without programming it into the shared sequencing protocol. But I think that that's the opportunity that we have right now. So one of the ways we didn't really touch on, and none of us really touched on this in our talks, but with base rollup, if you use the L1, then there isn't really a way of programming into the base layer like, oh, rollup should get back this portion of MEV. We, designing these decentralized protocols on top of the layer 1, have that opportunity now. And I think it's important for adoption. It's important for at least the major rollups out there to be convinced to use Espresso or Astria or Rollkit, right? An important thing to do is to say, here's a credible revenue sharing protocol in place that can allow you to get back the value that you're creating for the system rather than the system taking all the value. And so that is, I think, a very important research problem that I'm trying to get people excited and interested in. We have some thoughts on that. I shared a little bit in my talk. You can have like alternating blocks where in some of them you run independent auctions, some of them you run joint auctions, independent being one for each rollup, joint being auctioning off wholesale blocks for all the rollups at once, and that allows you to estimate and approximate the marginal contributions of each more directly, and then use that to inform some reallocation strategy. But this is a wide open problem that welcome everyone to think about and offer better solutions on.
We think a lot about how you can do MEV redistribution and things like that, and we suspect that the way it might work is if whatever layer is doing your transaction ordering has really, really good censorship resistance, maybe with something like a threshold encryption scheme or possibly with a multiplicity style scheme that Duality proposed, you can use verifiable sequencing rules and maybe something like protocol own builder to capture that MEV and do interesting things with it. There's also, of course, all the various ePBS, MEV smoothing, and MEV burn schemes that are coming out of the Ethereum world. And maybe those would have some way of ensuring that it gets captured and redistributed in some equitable way as well.
I guess I'll just throw like a contrary point in here maybe of like, so from our view of like the idea that like deploying a rollup should be as easy as deploying like a smart contract or whatever the term we use, there's always a question to me of like, who is the rollup? And what I mean by that is like, not the mechanism design of like calculating like the counterfactual of like a single auction versus like a combinatorial auction of like, what is the value that this rollup deserves? But it's a question of like, who is the entity that like represents this rollup and how is the shared sequencer aware of that being like a distinct entity? So it's kind of this question of like, and Ben, we've talked about this like various research things like, where do you pay back like the rollup itself? Like what is the state machine that is like actually calculating and like, receiving these funds and choosing like to distribute them? Like to our thing, we think from like a UX or like developer experience, it's important that like there's not like a registration phase for like a rollup to like sign up to the shared sequencer. That's kind of intentional and why we're like a lazy shared sequencer. So to this degree, it's unclear who would be like the valid entity that is being rebated the actual funds, even if we had a magical way to calculate like the optimal value that should be returned. It's like, well, who are we actually giving this to? And then the other point I think of is like, where do we want this value to be like returned to? Should we be thinking about like the rollup as some like nebulous entity or like application developer? Should we be thinking about like the users, right? What if we see some space where, I didn't have, a tough time in my talk to cover, but like, what if users are doing something where they have some kind of front end or singular order flow thing, whether it's like Suave or some other kind of aggregation mechanism that is actually using multiple distinct state machines and then settling to a single shared sequencer? Well, that user may not have some kind of like preference for one of these chains versus the other. And so should we be thinking more about rebating the MEV to the users? And again, to Ben's point, right, going to order flow auctions of like, well, actually we're trying to get the MEV fairly back to the user. And, just right now in the current like MEV design, even on like ETH, right, like 90% of that MEV is captured by the proposer. So that's like the entity where you have to get that margin from to get back to the user. But it's unclear if we want like an intermediary hop to like give it to the sequencer or like, the nebulous entity that is the rollup. Really, we just want to be giving it back to the user and giving them like best execution price.
Nice. Okay. So much good alpha right now. Let's focus on based rollups. Based rollups are a critical part of shared sequencing. You can't really have shared sequencing without some sort of lazy execution. So I'm not really sure on the exact definition of based rollup, but effectively you agree on the transactions beforehand and then you execute them. So this is what I think what Josh was talking about earlier on his talk, where you have sort of like an optimistic relay, where you're submitting a block, you're submitting some sort of transactions, and then you have some sort of arbitrary execution environment on top. So another thing to do with MEV is I'm curious on like with this execution environment itself, on reordering the transactions or doing something to do with a based rollup capturing, again, this goes back to like programmatically capturing its own MEV, is can you have a based rollup that doesn't necessarily respect the ordering of the shared sequencer? And can that like be beneficial in any way? Do you see that as like a viable thing? Or, I mean, a very fair answer is no.
No. But, no and. Or is it only yes and? Can we do a no and? Okay, no. Anyways, it gets into the definitions of a rollup can define its own state transition function. So, and that could be on a block level, for example. You could have an ordering of transactions in a block, but then an application which reads all those transactions, like takes the average and then uses that to determine like the state of an AMM. So you can define your state transition function to be not just executing transactions in the order that they appear, but it could be some deterministic function of how they appear in blocks. You have to, of course, break it up into some parts. You can't wait forever until you decide what your transition is, but you could do transitions on a block level as opposed to an individual transaction level. And that does give you some ability to define these reorderings, but the key thing is you can't do it in a dynamic way. You can't do it in an opinionated way. Anyone looking at what the shared sequencer outputs and knowing the state transition function knows what's going to happen. There's no like dynamic thing that the rollup can now do. So that's the nuanced perspective.
Yeah, doubling down on that, right? Like the state transition function, like we argue, like it has to be deterministic, right? How you order it, you can just say, I read it backwards. Like why? I don't know, because you choose to, right? Like I think a batch auction is probably like the cleanest thing. If you have like an AMM, like a Penumbra style batch auction, right? Like everyone gets the same price. It doesn't matter if you're at the front of the block or like the back of the block, right? But like it has to be deterministic. You're not like doing like a random shuffle, because again, then the shared sequencer, like again, like what is the commitment giving you? If you're like, someone's gonna randomly shuffle it by some exogenous extra protocol rule, you're like, all right, you won't come to consensus on it. Then like, what are we doing here, right? So it does have to be deterministic. Again, like how you order it, how you refund it, like fine. But also from like the shared sequencer perspective, like it's just like including the transactions. It doesn't really care what you're doing after the fact. That's on you.
The name of the concept is verifiable sequencing rules, I believe, and it reduces the problem of fairness to the problem of censorship resistance. If you can get something included, then it will be ordered fairly according to the verifiable sequencing rules. There was a research day talk about it from Matthias. It's quite good.
I'll just argue, I just have a general opposition to like the concept of like fairness being like a thing. There might be some like useful economic definition for it, but like I think arguing of like fairness is where we get like spam and whatever, right? Like all of the first come first serve things of like, oh, is it fair? And like, well, is it fair that the guy has like faster hardware and like a better like a shorter Ethernet cable is like faster than you?
Well, maybe not fair, but something that you can capture and redistribute possibly.
Yeah, exactly. So what I was trying to go with that is that you definitely need a deterministic function, but could you design a deterministic function that can direct value capture to somewhere where you want some sort of programmatic MEV capture? So something like a batch auction, like what you were saying.
Yes, but I think that can only be the value capture within the state machine of that specific rollup. That cannot be the value capture of, say, an inclusion fee within the shared sequencer. Like you on your rollup cannot deterministically reorder something in such that you extract value from like the inclusion fee on the shared sequencer.
I mean, it's also important to note though that if you have a deterministic function and you are the protocol or the builder that does have dynamic control over the ordering of transactions that then go into that state transition function, you are the entity that can figure out which order is going to maximize my own profit or which order is going to maximize some profit. So you don't really have control just by defining the state transition function over where the profit goes. And that's why you still need to get back to this order flow auction design that we were talking about.
Exactly, because the proposer has monopoly over.
Not the proposer, well, again, it comes back to consensus protocol. The proposer has a monopoly for one slot, right? Which is important because that means that it will take whatever output it's given if that's the only output from some order flow auction that it can choose from. That's the consensus. That's why consensus protocols, that's why blockchains are good, right? Blockchains turn proposers into monopolists from one slot, and that's why centralized systems are bad, because you have a monopoly over all slots. And it's amazing that when going from monopoly over all slots to one slot allows you to achieve non-monopolistic behavior in a system. That's like the coolest economic thing about blockchains. But you still need to solve this like builder side. You need to solve this order flow auction that designs a system which is stable for users if you really want to mitigate or minimize MEV or control where it goes.
Your verifiable sequencing rules they don't know if somebody sold on a centralized exchange after they did a swap, for example.
For example, great.
Which is how all the MEV is extracted.
Nice, nice. Okay, so bear with me, we're gonna bike shed on naming just a little bit.
Fine.
Okay, so I think actually the main criticism of shared sequencers is just the name. So like, do you think that shared sequencing is a good name? Like, is it justified? Or would you rather go with something like, I've heard shared proposer, I've heard shared aggregator. Is it not, shared seems reasonable, but maybe not even that? I don't know, what do you guys think?
Are we going in order here? Yeah, okay. I think that when it comes to names, there's no perfect name for anything. So, I mean, blockchains aren't a great name. I'll say it. They made a lot of sense for proof of work consensus, but you know, other consensus protocols may not be blockchains. But it's the thing that catches on, and it's the thing that resonates with people, and it makes sense. And I think that shared sequencing, we've all now been using it, and of course, once you start using something, people are going to point out reasons why it may not be the perfect term. But in the end of the day, it's a pretty decent term, and sequencing refers really to finalization of the sequence in which rollups will execute their transactions. We could add that to the title. That's a mouthful. And I just don't know if there's another name that's like nice and short and succinct that captures it. But if somebody comes up with one, you're the winner.
I think it's a good name. A lot of people like aggregator. I think that's a good name as well.
I guess I'll say, like, yeah, we made like a very intentional decision to like use shared sequencer as like it was like a marketing term, right? But like fundamentally, like people that use the same shared sequencer have a shared view of the sequence of transactions. So like certainly better than like settlement layer, where everyone's like, what the hell is a settlement layer? What are you settling? What is settlement, right? We're like, no. You use the shared sequencer, you and everyone else using it has a shared view of the sequence of transactions that feels pretty explicit, right? Yeah, we implicitly assume that it's like, in our terminology, right, like a lazy, decentralized shared sequencer. But again, you just have to pick words and put it in your marketing copy.
Are there any other misconceptions on shared sequencers that you guys would like to address now?
Shared sequencing is not one rollup. Shared sequence is not shared execution. It's not shared building per se. It makes some set of shared building easier. I don't know. Shared sequencers are real.
Yeah, that's a great segue into, does anyone know really quick how much time we have left? 0. Oh. Wow. Okay, well. Right on time. Okay, that's great. I don't know if you have time for the same. No, there's no need. We don't have time. We were just gonna handle if rollups were real or not. So we'll just leave that for next time. All right, thank you everybody. I was super excited for shared sequences before.
Thanks, Evan.
Now I'm extra excited for shared sequencers.
Great, thank you, Evan. Thank you all. Stick around, because coming up in a moment, we are going to hear from Neil. All right, just gonna give it a moment of transition. Yeah. I think so. All right, thank you all. If you want to chat, I'm going to encourage you to make your way towards the door. If you would like to stick around, however, I would encourage you to do that, please. We're going to be hearing from Neil from Eclipse in a moment. All right, wrap it up, wrap it up. Take your seats, everyone, please. All right, I'm giving everyone a countdown to grab their seats in 3, 2, 1. Okay, thank you so much. All right, thank you all. Coming up next, we're going to be hearing from Neil Somani, the CEO of Eclipse, and he is going to be telling us why rollups as a service are going to zero. Very controversial. So
hopefully not all of them.
Over to you, Neil. Thank you.
Hi. Okay, this is on. Okay, so for context, Eclipse builds rollups as a service. So this topic might be confusing for some folks. And in this presentation, so I'm Neil. I'm the founder. And what I'm going to explain is different economic or technical considerations for app-specific rollups. Gonna talk about the rollup as a service landscape, and yeah, well, let's get right into it. Okay, so there's been a lot of discussions about RaaS or rollups as a service, and what I want to do is I want to first define what is a rollup as a service, And a rollup as a service is something that deploys rollup frameworks. And that requires understanding what is a rollup framework. A rollup framework is something that implements execution and settlement-related capabilities for a rollup. So this is something like OP Stack or Arbitrum Orbit. You deploy one of these frameworks yourself, or you can use a RaaS, and then you can start having your own chain for your own application. So this is a market segmentation in a Masari think piece, which I actually signed off on the times or at the time. So this is partly my own fault for not thinking it through fully. But what I think is more useful for this kind of segmentation is to think about what parts of this stack are cooperative with each other, which parts are competitive, and I think that's the right way to frame it. So the way that they framed it here is they have SDKs, which I'd probably call frameworks instead, since they're not all SDKs. You have shared sequencers, and you have no-code deployment. And I'm going to talk about how I'd reframe this a little bit. So what is a sequencer? A sequencer, I mean, we just had a panel on sequencers right now, but it's something that just does ordering. Ultimately, with that ordering, you have to compute the actual state transition, so that's execution. So rollups as a service as they exist right now, this is maybe a little bit too narrow. I called it isolated sequencers as a service. Usually it's also deploying the execution-related capabilities, but that's essentially what rollups as a service as they exist right now are. They might do some additional support, consulting, and some stuff, which I added as a footnote. I'll talk about that a little bit more. But what I want to describe is basically what is a business model. So right now it looks like some amount of fixed fee. That might be a fixed fiat charge. There's some variable component, so it's a percentage of the sequencer fee, which you have to actually define that a little bit more clearly, because that could be a percentage of the congestion fee or the execution fee for a rollup. That could be just a premium that you add to every single transaction. But this is kind of what I want to address, and I think that this is something that every rollup as a service should have a view on. But the first thing is that the rollup framework, to some degree, actually competes with the rollup as a service. And that's something that I'm going to cover in the next couple slides, so I'm not going to talk about it too much right now. The other things that rollups as a service have to think about is that given that they're deploying isolated sequencers as a service, there aren't actually like a lot of network effects. There aren't really economies of scale for every single isolated sequencer. For each additional rollup that you deploy, the service doesn't really get better, or it doesn't get cheaper. Unlike, I mean, a shared sequencer, for example, for every additional rollup, now you have additional composition between those rollups. Or for certain types of services like DA, the more folks that are using a single DA layer, then there's more fees coming into the system because blocks get full. Maybe it's a fee market, it goes up. That incentivizes more validators to run for like Celestia or something. So that's very synergistic. Whereas for a rollup as a service, that kind of network effect doesn't naturally exist alone. There might not even be a token. So that's something to keep in mind. So I think this is the right way that I want to frame that discussion of how a rollup framework could be competitive with a rollup as a service. And the way I want to put it is by thinking about the functions of a modular blockchain. So we're here at Modular Summit. Everyone should be aware of this stuff. But the functions, as Celestia puts in their docs, we have execution, and I threw a bunch of stuff in there. I put sequencing, the actual execution of the transactions, and computing the state transition function. I put proving for ZK rollups. The second part, which John Chard would say doesn't even exist, is settlement. So it's figuring out like what's the canonical chain or what's like the correct state of this rollup. And then there's DA, which hopefully everyone's aware of here. But like let's say you're an optimistic rollup, you're a verifier. You need to know what were those transactions that were run in order to even call for a fault proof. Or even on any L1, you need data availability, just so that all the full nodes can know what transactions were run. They can keep in sync with the network. So another way of thinking about these functions of a blockchain is these are the possible ways you can try to accrue value, or the places where you can try to capture value, whether you're a rollup framework or some other type of part of the blockchain stack. So yeah, now I want to go a little bit more deeply into each of these three areas and think about where could a rollup framework feasibly capture value. So settlement to me is not a viable place to capture value, because one, we're not even sure that it exists, but two, settlement doesn't make very much money. So for Optimus and mainnet, and this is actually all about optimistic rollups, partly because that's what we have deployed for Eclipse right now, so that's what I think about the most, but you could probably make similar arguments for ZK rollups. Settlement costs might be a little bit higher, but even if they're 100 times higher, that's still only like $500 a day. Not a great business to be in for every single chain. Whereas Optimus and mainnet, it's an optimistic rollup, so it's just basically posting state roots, and in the happy path, that's just $5 a day. So that's basically zero to me. I mean, should be to everyone else as well. So a competitive settlement layer to Ethereum is going to make even less money because they don't have the security budget of Ethereum to justify why they would charge more. There's less congestion, fewer people would use it. So that's not a great place to play, is my point. And then DA, this would basically be the case where a rollup framework deploys their own competitive DA layer. So this would be like if Arbitrum had a Celestia competitor or something, or if AnyTrust became the primary business model. And my argument here is that that's not a very great place for a rollup framework to play either, partly because Celestia already exists and we're all using it. And for DA in particular, there's very good reasons for all the rollups to try to use the same DA layer, because you're all like posting to the same place, the fees go up. Like I was saying before, it's synergistic for everyone to use the same DA layer, because more people are providing security for that DA layer then. So I'm saying the only place that's viable is actually execution. And as a result, those fees that come in from the sequencer are basically zero sum. Like you can charge more, but that just makes you have a less competitive sequencer or less competitive rollup framework or RaaS. So between the rollup framework and I call it ISAS here, isolated sequencer as a service. Maybe I shouldn't have done that because it's just like additional jargon. But I just put it there for simplicity. And this is a graph on the left side. I want to think through like the business model game theory of an ISAS compared to a rollup framework. And those numbers might not make sense because ChatGPT generated the graph. But what I want to convey is that I want to start with the isolated sequencer as a service and think about whether it plays nice or doesn't play nice with the rollup framework that it's deploying. And playing nice means that it shares revenue back to the rollup framework. And not playing nice means that it tries to capture all the value for itself. And in the case where it shares value, my argument is that they're subject to being undercut. Anyone can choose to not play nice, and that's going to drive, they're going to win from an economic positioning. And economics is probably the biggest reason why people deploy their own app chain. So I don't think that that's a sustainable configuration. And if the rollup as a service chooses to not play nice, then the rollup framework themselves needs to monetize somehow. So the rollup framework likely will deploy their own RaaS, similar to like what Optimism has done with Conduit, in my opinion. So that's kind of how I would think this through. And what I feel is that the stable configuration is for rollup frameworks to have their own rollup as a service, because then they have all the flexibility in business model. They're not forced to share like some fixed amount of sequencer fees. They're not getting undercut by someone else. They get all the profit for themselves. So that's kind of my thinking. And then this is just considering a little bit further the case where a rollup as a service competes with a rollup framework themselves. So this is like if someone's deploying a rollup framework that they don't own versus the rollup framework deploying their own RaaS. And then I'm just comparing these two cases where my argument is that the rollup framework has more flexibility. They likely already have a liquid token. They can subsidize fixed costs. So this is not like a fatal thing. It's more just something that every rollup as a service should have an opinion on this. And they should like establish their positioning, think about what's their business model, and how do they expect to sustainably capture value. And the reason why it's really important is because developers care. Because developers don't want to build on a stack that they think won't exist in like 1 or 2 years. And that's probably going to happen if there's no sustainable business model. So this is how I'd reframe the Masari framing from before. And I basically renamed rollups as a service to isolated sequencers. And what this really shows is that you can only have an isolated sequencer or a shared sequencer, but you can't really have both. And then similarly, I renamed rollups SDKs to rollup frameworks just because I like that better. It's a little bit more general. And then if you're in the rollup framework category, you should probably find yourself also in isolated sequencers or shared sequencers. Similar to how OPStack or Optimism has the superchain, that's likely going to manifest as a shared sequencer. All right, so this is like an economic thing, and this slide's a little bit dense, so I won't like go through all the specific numbers. But what I wanted to look at is, let's say you ran an OPStack chain. I use OPStack because it's just an open source framework. So I deployed it, and it costs about 1 ETH to deploy the smart contracts. I consider it like roughly 0 just because over a long enough, it's a one-time cost. So if you're running your rollup for years and years or something, it gets amortized. So the recurring costs are more interesting to me. And for like a lot of optimistic rollups, they're still posting to the DA layer, even if no transactions are run. That's because the sequencer is allowed to do some additional stuff. So that's half an ETH a day of just overhead cost, which gets amortized over the number of transactions, and that brings it down. And then there's some variable costs, and that's the biggest component for all for all rollups. And Sanjay at Electric actually wrote like a great piece on the cost breakdown for a given transaction on a rollup, but the DA cost is the biggest one. So this, I'm not going to make you do the math, but it ends up being about 15 cents on a good day. This is assuming like 25 Gwei gas price, and then assuming $2,000 per ETH. But yeah, that's basically like the cost that a rollup transaction can never get lower than that if it's deployed to Ethereum itself. So this is like considering some of the other things that could potentially impact this, like after EIP 4844, maybe the cost goes down by like 10 times or something. That's all speculation because we'll have to wait until it's mainnet. Similarly, we don't really know the Celestia mainnet cost because once that's up, we'll have to see. Similarly, with EigenDA. But my point is that just look at that variable cost, and you should think about what applications make sense or don't make sense given that. And I think an obvious one, for example, a game would never make sense, like a fully on-chain game, couldn't make sense on the Ethereum L1 as a rollup. Because 15 cents per transaction is likely prohibitive unless somehow the players are making money off of every transaction. But if it's fully on-chain, every transaction is likely not profitable for them. So that just seems unlikely to me. Whereas a DAC could make a lot more sense. So having a variety of DA options is really critical to enabling things like consumer apps. I mean, another way of thinking about this is what does make sense. That's probably like DeFi. People don't really care about paying 10 bips or something like that on a big DeFi trade. So this is probably reasonable given like the price propensity or the marginal propensity to spend for DeFi users on Ethereum. A lot of them would make sense to be on their own rollup, given that they're used to paying such high fees. It's a strictly better solution for those DeFi apps. And then I just want to think about most applications. Do they have that transaction volume to justify amortizing or to feasibly amortize the fixed cost associated with running a rollup? And the answer for most apps is probably no. NFT projects in particular probably doesn't make sense to be on their own chain. Small DeFi apps probably don't have enough volume. So this is, I'm not saying this to like discourage app-specific rollups. I think people can experiment, but we've seen a lot of app-specific rollups on testnet which would never be viable on mainnet. So I just want to point that out. And then this is like one last consideration that I want to talk about. And yeah, there's some technical reasons, like in order to do shared sequencing, it assumes that there's some builder. The builder needs to generically support many. I'm maybe assuming some knowledge here, but we just had the shared sequencer panel. But builders need to be able to execute for they have to run a full node for all of these different chains. So that implies some sort of interface for execution. For settlement, you need to have some restrictions on how execution can occur. So those are some reasons. But the main reason to constrain a customizable rollup is really just to better motivate the use case. Because if you look at Cosmos SDK, for example, this might offend some folks in the audience, but I never really felt like there was a plethora or diversity of use cases or implementations for Cosmos SDK. If you look at Terra, for example, without the stablecoin, it was just a regular Cosmos SDK chain. That's how a lot of the chains look at this point. So what I think makes a lot more sense is sector-specific architectures, such as a DeFi-specific architecture with extra short block times. That might impose an additional constraint, such as the sequencer must now be centralized in order to support that short block time. Or maybe for games, for example, like we were talking about earlier, it might need centralized DA or a DAC or something like that. So this is an example of a sector-specific architecture that we put together for Worlds, which is some polychain-backed game, fully on-chain. Evan at Worlds previously built Unreal Engine 5, so he comes from a traditional gaming background. And his view is actually like contrary to mine, but his view is that the purpose of the blockchain for the game is to act as a read-only interface, or well, for the users it's not read-only, but as the game developer, they just write to that blockchain, and they make it a public API for anyone to compose on top of, similar to the Steam Items API, or to, I mean, there's like a bunch of these that people can compose with, but the advantage of being on a blockchain is that it's standardized. So that's how he thinks about it. And as a result, he had these additional constraints, which is one, he doesn't want the users to know that they're using a blockchain. And that's particularly important because he can use Steam if he abstracts the user, or if he abstracts the blockchain from the user. And Steam is the biggest distribution channel for games. So that's one thing. He doesn't want to build financialization himself, such as like these play-to-earn games. He's not like a play-to-earn guy. And then he also wants to put a bunch of data on chain. And like we talked about before, that can constrain the DA options for him. So as a result, we built this chain for him. We deployed one of the standard Eclipse chains. We put an EVM on it. I don't know if everyone here is familiar with Neon. They actually recently went mainnet. But it's like a Sputnik VM. Sputnik VM is a Rust implementation of the EVM deployed as a smart contract to the SVM. So this is how they achieved this parallelized EVM, higher throughput than any other EVM chain. The settlement layer, so ZK, the point that's here is basically that a ZK rollup it will never be strictly better than an optimistic rollup. And the reason for that is that there's that additional cost for generating the ZK proof. Whereas for an optimistic rollup, you're just posting state roots. It's always cheaper to do that. So they kept it as an optimistic rollup. And then the DA layer will, hopefully Celestia is cheap enough for this to be viable. And then otherwise we'll switch them to a DAC. So that's what the world's chain looks like right now. And they've been using it pretty heavily. All right, and now I want to talk about what our rollup builder looks like. And this is our self-service deployment framework, or our website for this. This is a soft launch. We haven't posted this anywhere, so you're getting the first glimpse at it. This is what it looks like. It was actually a video before, but I removed that because I didn't want to risk the video not playing or something. But this is the front page. You can specify the network name, standard configuration options like the VM and things like that. Specify block times or things that are a little bit more technical. In the future, you might expect this to look like templates or just specifications based on the type of application that you're deploying, whether it's DeFi or something else. It just tells you what the rollup's going to look like. And this is what the chain looks like. We are giving a 1-week free trial, so you can heavily slam the chain. You can benchmark it. You can try it out yourself. And then after a week, you can actually pay. And it's going to be NFT gated. So if you scan this QR code, and I won't waste everyone's time and stay here too long, so you can scan this, you can get an NFT, you'll be on the wait list. I'll be sure to let everyone off who is here at the Modular Summit, so I'll get the list later. And you can try out this rollup deployment website. So I'll pause for a second. Can I tweet this? Yeah, of course. Yeah, go for it. Okay, and one last thing, we're doing an accelerator in San Francisco. So this was inspired by Modular, Modular Fellows, which is actually kind of how Eclipse came about. It was Nick who reached out after Terra depegged, and we were just talking about how we could make Solana into a rollup. So we wanted to do something kind of similar for Eclipse to motivate the use cases for app-specific rollups. We have some ideas on the types of apps that make sense and we'd want to see in our ecosystem. There's also a few RFPs for things that we need built into the Eclipse core product. So we'll have those out as well. We're putting aside, I think, 200 and 300 grand, something like that. We'll be funding different projects, and we're actually going to host them in our office in SF. So it's an San Francisco-based program. But for exceptional projects that are outside of SF, we can actually fly you in. And this is kind of funny, but we have rooms in our office, so we can house you, and you'll be living with our team. And you can talk with our engineers every day, and yeah, that's kind of the idea. So it's smaller than Modular Fellows. This is only 5. It might even be as small as 3, depending on how much we think we can reasonably support. All right, and that's it. So I think the rest of this is just like appendix stuff. So yeah.
Awesome. Thank you so much, Neil. I don't know. It doesn't sound like they're all going to 0. I think there's hope. Yeah, so up next, we'll hear from Matt Katz, who's the CEO of Caldera, who will be talking about the recent OP Stack / Celestia rollup combo that they've dropped. Hey.
That one? Cool. That's an interesting presentation as the founder of a Rollups as a service company to go afterwards. Also, if anyone saw that slide, I am not the co-inventor of ZK Sync. Just to keep that clear. Yeah, I want to talk about Caldera, our involvement with Celestia, how we're unleashing rollups with DA networks, and also just want to talk about some of the motivation behind application-specific rollups, why you might want to build them, why we are personally still bullish on RaaS, and why we think it might make sense for some applications. So I'm just going to take you through a journey of some of our thinking around this, and then talk through our involvement with Celestia and our recent developments there. So yeah, first of all, Matt, founder of Caldera, caldera.xyz. Come check us out. We are the easiest way to launch a dedicated rollup for your application, project, or ecosystem. We're also the first, as far as I know, rollups as a service company to go multi-stack. And so we really emphasize developer choice. We support Optimism OP stack chains. We also support Arbitrum Orbit chains with many more coming in the pipeline soon. We also focus on being an infrastructure layer for modular chains. So we know how hard it is for people to launch viable blockchains, and that doesn't stop at just the sequencer. So we aim to provide all sorts of different infrastructure. And we're also a white glove service. We are a RaaS, very nebulous definition, but we are one of a few companies that is defined that way. Oh, it looks like our emojis didn't render. That's all right. Imagine beautiful emojis there, chosen by ChatGPT as well. We do reliable sequencer hosting. That's a huge component of it, of course. Having reliable RPCs, making sure that the sequencer doesn't go down, making sure that archival data is available to users. That's a major unlock, and that's one of the more annoying things about, for folks who are trying to launch their own rollup. We also do all sorts of additional infra, as I mentioned, like block explorers, RPCs, interfaces for bridging. Like, we've actually found that is, in some sense, like a lot of the value add that we provide. There are some teams that are able to get started with the rollup sequencer, but they still lean on us on all of that additional infrastructure and value-added services that we provide as a cloud provider, and as well dedicated support. We found, we are probably the top of funnel for most teams that are thinking about application-specific chains or ecosystem-specific chains, and so we know best what people want, what people need, and the problems that people are thinking through as they're making these decisions. And so oftentimes when we're working with teams, we're working with them as a thought partner as they think through these major decisions. So yeah, I first wanted to motivate just why build with an app rollup. And I wanted to start from the very beginning. In the beginning, there is Ethereum, and Ethereum was good, but Ethereum is also slow. Whenever I talk about the speed of Ethereum, I always include this photo of the Caldera 8800. I personally am too young to have ever actually used one, but this is a personal computer from the mid-1970s. And the thing about this computer, it's probably the closest in terms of instructions per second. It's the closest comparable to Ethereum mainnet. So both this Caldera 8800 and Ethereum mainnet can process about 0.2 million instructions per second in total across their virtual machines. Now, unlike the Caldera 8800, which is a personal computer, basically single-threaded, only running a single application at any time, Ethereum is probably the worst cloud multi-tenant infrastructure ever, where you have hundreds of thousands of applications that are all competing for scarce computational resources on top of them. And so that leads to high fees. This graph was a little bit cherry-picked. You might notice it stops in 2021. Another thing is Ethereum is ossified, or Ethereum is in the process of ossifying. Ethereum as this global base layer computer for the world's new financial system, Ethereum cannot move fast and break things. Ethereum needs to be ultra conservative, and for anyone who has done anything in the EIP process, you know this to be the case. It's basically impossible to make changes to Ethereum, and especially breaking changes are impossible. And this is generally a very, very good thing for Ethereum. But if you're building certain types of applications, you might want to make changes, and that might motivate you to build your own chain. As well, this is true of most L2s that are being built on Ethereum right now. So if you've talked with anyone from these general purpose L2 chains, whether it's Optimism, Arbitrum, or any of the ZK teams, the holy grail is Ethereum equivalence, basically saying we want our rollups to behave from a VM perspective in the same way Ethereum does. And that makes sense for them as well, because they're motivated to produce chains that are effectively successors to Ethereum's general purpose mission. But that might not be what you want if you're building an application with specific requirements. And so even if general purpose L2s are solving the first two problems of speed and cost, they're still relatively ossified. They're going to wait for Ethereum to make changes to the VM before they make major breaking changes as well. And so that leads to why you might want to launch a dedicated chain. Again, emoji not rendering. But you have dedicated TPS. You have a dedicated lane to scale. And that TPS is all yours. Again, going back to that multi-tenancy point, you're not having resource contention between all of a bunch of applications all on one chain. You have either just the applications of your ecosystem or your own application on that chain. You also have ultra low fees. You can explore the trade-off space, where you settle, where you post DA, et cetera. to get the best fees for your application. I mean, in the last presentation, there's a lot of calculation around fees. That calculation is legitimate, but all of those variables are configurable. And so when you're building a dedicated chain, you get to choose what the inputs are to that function and then find the outputs that make sense for you. Lastly, there's latency. I think latency is a really, really underappreciated aspect when you're building Web3 applications. I spent some time in the gaming industry. When you're in the gaming industry, if your application has like over 100 milliseconds of latency, people like go into your DMs and your email like telling you to kill yourself. Blockchain, that's not the case. You have relatively high block times. Users are used to that. But if you're building on-chain social or you're building on-chain gaming, like you might actually really want ultra low latency, and being able to choose where you sit on that sequencer decentralization spectrum might be really helpful for that. Also, there's customization. At the first order, there's precompiles, right? A lot of these precompiles might be very useful. They've also languished for quite some time. Us specifically, we worked with a team who was waiting for years on the BLS curve operations precompile to get merged. You can find their CTO has comments on that EIP back from like 4 or 5 years ago. They were waiting on it. They needed it. It was what would have been most helpful for them to develop their application. It's not getting merged into Ethereum anytime soon. It's pretty stale. We're able to merge it into their rollup, get that set up, and then they were able to go live like a couple weeks after. And so there are a bunch of other really interesting ones too, like the Poseidon hash function, ZK-friendly hash function. But it's not just EIPs, and it's not just custom precompiles. You have basically full control over the state machine. So eventually, we're going to be able to support different VMs, like the Solana VM, the Move VM, whatever crazy VMs or custom state transition functions people might want to do. There's also value capture. Imagine a token emoji. Over there, you can use a custom token. You can generate sequencer fees. You can also run some like lightweight MEV. And so you can choose how to monetize. And especially right now where a lot of projects are thinking about how to make money, this is a super important aspect. A lot of teams are thinking more and more about this. How can they take fees from their rollup? How do they distribute that back to their community? How do they use that to fund development? And there are going to be a lot of really, really interesting models on this going forward. Lastly, wanted to defend settled rollups a little bit. We think that the rollup space and the modular space in general is going to be a homecoming moment for a lot of these application chains to come back into the fold with Ethereum via rollup stacks. That's not to say that we're anti-sovereign rollup. We think it makes sense for certain applications, makes less sense for others. But we're really into this idea of a hub and spoke, L2s and L3s, all eventually settled by and settling to and secured by Ethereum, and also having native composability with Ethereum assets and access to liquidity on Ethereum L1s, Ethereum L1 and other Ethereum L2s, and eventually L3s. So there's this wonderful quote from Vitalik, "Prescient as always," back from 2021, and this is. We're really, really aligned with this thesis. We get a multi-rollup future for Ethereum, which is effectively the Cosmos multi-chain vision, but it's on top of a shared base layer, providing data availability and shared security. That's what he said. What you might notice in that data availability point is that we haven't fully gotten there yet. Ethereum, when we're using Ethereum for DA, we're just posting data to Ethereum Caldera. That is not super efficient. It's quite costly, and it's leading to some big limitations when it comes to rollups. So yeah, that's the major blocker. When you're running a rollup on Ethereum, you have a bunch of costs, and then you have DA as a major bottleneck. You can split up costs into 3 buckets. The off-chain infrastructure costs, this is like your cloud servers, your hosting, networking, et cetera. That is relatively fixed and also something that can't really change that much. You have on-chain fixed costs. There's a little bit of cost in settlement. There's also fixed costs when it comes to DA. So a lot of these rollup stacks, they're posting a lot of data to Ethereum, just like empty blocks, kind of like metadata for the chain, even if there are no transactions being processed. And that was talked about in the last presentation as well. And it is a major blocker for people who are launching app chains, where they might be trying to bootstrap a little bit of activity, but that activity hasn't come yet. They don't have guarantees that there will be people around to pay for fees and cover costs. And so they are wondering, how do they cover those costs? And then there are the variable costs, so posting transaction data that gets sent to the sequencer. And then there's a major bottleneck, which is data availability. We can quickly go through them. These costs are really killer. They make it hard to get off the ground, as I mentioned. When you're settling on Ethereum, you might pay $100,000 per year in these fixed DA, like metadata costs. That is based off of current calculations. So if we have another bull run or gas prices get higher, greater demand for block space, that number can go up. They also prevent rollups from being strictly like cost competitive or better on cost than Alt-L1s. For like simple transactions, sometimes there might be cost competitiveness depending on demand on all of these chains. But as you can see, like generally for average transactions, a lot of these Alt-L1s are still slightly better than existing rollups, and that's going to harm adoption because users they don't really care, they don't really know the difference between a side chain and an L2. A lot of the times users and even application developers want to go wherever's cheapest, wherever there's adoption, et cetera. They're not super aligned with Ethereum in general. And lastly, and I think this is an underappreciated point about the current Ethereum rollup space and the status quo, is that we do have a DA bottleneck, which limits the total throughput across all rollups that are currently built on top of Ethereum. These are some calculations, kind of rough, back of the napkin math from Calvin Fichter, who works at Optimism. He has a blog post called TPS is Dumb. This was a little bit of a sidebar on that blog post, but basically, even assuming like relatively reasonable assumptions around call data compression, et cetera, like current Ethereum DA only supports 360 transactions per second. And that's if we're using all of the Ethereum's network, all of the gas throughput, just for posting call data for L2s. And this is like based off of the current network. So pre-4844, pre-dank sharding. But this is global across all rollups. So even though for the compute, we can horizontally scale Ethereum right now via rollups, eventually we're going to run into this bottleneck. And so if you look at a lot of these limitations, you'll find the thing that we keep going back to is DA. Right? A lot of these on-chain fixed costs are actually DA, which is surprising to some people because DA is often thought as the variable cost, but there's still a ton of metadata that needs to get posted to Ethereum. There are relatively high variable costs. You're paying DA when you're sending transactions. And of course, there is this bottleneck when it comes to DA, limiting the total throughput of all Ethereum rollups. And so we have our saviors, all of whom I believe are sponsored at this event, Celestia, Eigen, and Avail. Basically, projects that are focused on providing cheap data availability. And at Caldera, we were founded, we were really, even since founding, like we were really excited about these. We saw these projects as being the major unlocks for an Ethereum-centric rollup future. And so we were one of the first teams to integrate Alt-DA into traditional Ethereum rollup stacks. So with Celestia, we launched the first testnet of an OP stack plus Celestia rollup. And effectively, at a very high level, what it does is like we're posting data frames to Celestia now rather than Ethereum natively. Thus, Alt-DA. And we're only posting references to those frames that are posted on Celestia to Ethereum. So that means that we're turning that variable cost, which was sending all that data to Ethereum DA, into a fixed cost. We're just sending a reference. This is a diagram from Vitalik's blog. Just wanted to put this here to say, we're not really changing much of the rollup protocol at all. We're still posting state routes to the rollup contract. We're still posting batches. The only thing that changes is, I was told not to stray too far away from there, but we'll live, is this part. So these transactions, that data is being sent to Celestia. There's a little bit of changes made in this logic to post references, but effectively the rollup protocol is still the same. We're just referencing data on Celestia rather than Ethereum. And it's live. So if you guys want to be some of the first to launch something and play around with an OP stack plus Celestia testnet, you can go to our bubstestnet.com. And we're also really excited about this. We recently launched a testnet with Manta Network, and these guys are super early adopters. Yeah, they're great. There's Kenny in the back from Manta Network. They're, as far as I know, the earliest adopter of Celestia plus OP stack for rollups on Ethereum. So they're going to allow their users to experience way lower transaction costs than any existent rollup on Ethereum. Plus, they've also integrated a lot of ZK-friendly application-level ZK functions. And so if you're interested in developing on the first network to use Celestia for DA, go check them out, go talk to them. They've got a strong presence at this event, so find them afterwards. And yeah, thanks. Feel free to contact me at any time. If you're thinking about launching a rollup, if you just want to talk about the design space, always happy to chat. And yeah, stay tuned. You're not rid of me yet. We're doing a panel here on the rollups as a service space, which I'm told might get spicy. So stay tuned. Thanks.
Excellent. Yeah, the spice is just starting to heat up. That was great, Matt. And thank you also for Miracle of Miracles running on time with all of that great content. I'm excited to go in and start playing around with the OP stack on Celestia myself. It's my pleasure to introduce Tracy. Do we have Tracy here? Who's going to be moderating the Rollups as a Service panel that's coming up. So yeah, you're not rid of Matt yet. Neil's going to come back up, and I think that we've got a couple others joining us as well.
Sit in order?
It's okay, you can sit.
Maybe short one microphone. We don't need four.
Oh.
Like I speak loud enough regardless.
Just pass it back.
Yeah, I will.
Okay.
Yeah, makes sense.
Okay, well, everyone, good afternoon. Thank you so much for joining us for our Rollups as a Service panel. I'm Tracy Wang. I'm a Deputy Managing Editor at CoinDesk. Excited to moderate because we have 4 Rollups as a Service projects all on stage. And so, you know, hopefully nobody starts fighting. but why don't we just start with, you know, if we can go down the line and have everybody introduce themselves, kind of a little bit of your background, any other previous projects you've worked on that are notable, and you know, kind of how you got to where you are, and just like a 30-second intro.
Yeah, sure. Hello. If you weren't just here for my talk, I'm Matt. I'm the founder of Caldera. Got into crypto back in like 2012, 2013. Bounced kind of in and out of the space. Did a lot of stuff around startups, some performance engineering for things like games and operating systems, and found my way back into the space working on rollups as a service, trying to unlock scalability for novel applications on Ethereum.
Yeah, hi everyone. Yaoqi here from Rollups. So I started my research back in 2012, mainly on consensus protocol and also privacy, mainly publishing sort of research papers. But in 2016 and 17, together with some colleagues, we started to do research on scaling, mainly sharding at that time. So we co-founded Zilliqa, and basically push the midnight for the sharding protocol. And later on, like also working on some multi-chain approach. And then around 2 years ago, we started Fourier to build this decentralized rollup as service protocol for applications to quickly spin off a rollup and scale their applications.
Hey, I'm Neil. Great to see some familiar faces here. Founded Eclipse, and prior to that, I was working at Citadel as a quant researcher in the commodities group. I did like power, gas, electricity. And then I left. I was briefly building an EVM for the Cosmos SDK. So people here might know like Ethermint or Evmos and stuff like that. So what this was instead was you take the regular WebAssembly virtual machine and you try to run EVM bytecode through that. And the advantage of doing it that way is you get better atomic composability between EVM smart contracts and WASM smart contracts. So that was the thinking. My main reason for doing that at the time was actually Terra, because Terra had a lot of momentum. So when Terra depegged, I just scrapped that project and went back to the drawing board, was chatting with the Celestia folks for a while, was chatting with some folks at Zero X Park, and finally ended up building Eclipse because we wanted to address this gap we saw in the market for really highly parallelized, high performance rollups.
Hey everyone, my name is Kautuk. Kind of started building
on Ethereum in 2018, but then I caught the AI/ML hype of that time. But then, like, I realized it was not for me. And back in 2020, I came back to the space and started learning, reading, and researching more about scaling in general. I worked with the Ethereum Foundation in the PSE team a little bit, working on the Hubble Rollup project and the BLS wallet project, and also worked with LifePair for a little bit, moved the protocol from mainnet to Arbitrum. And I think last year I took inspiration from Hubble and like spun up Stacker, and it was basically a framework for building rollups. And yeah, that's pretty much about me.
All right, thank you. So we are at Modular Summit, and so if you guys can briefly talk about kind of how Rollups as a service kind of fits into the modular vision of the world, and also if you can give like a very, very high-level definition of like what a rollup as a service is for any of our new joiners that might not know. And I think there is this, simile that some people use that like Amazon Web Services is to Web 2 as like Rollups as a service is to Web 3. I don't know if that's directly like a good comparison. And so if you can kind of explain what Rollups as a service is and kind of how that fits into the modular vision of the world. Why don't we start with you, IQ?
Oh, great. So for Rollup as service, right? So I think we are talking about modular a lot today and probably tomorrow. So as we know, right, 2 years ago, like Mustafa mentioned about this Celestia and also modular, at that time we are trying to move from this monolithic blockchain model to this modular model. So in that case, we try to decouple the monolithic sort of a design from this execution layer, settlement layer, DA layer into multiple like modules. Like Celestia handling this DA and execution basically belongs to different rollups. Like we know the Optimism, Arbitrum, and all different ZK rollups. And then we also have the settlement layer. Typical we mean like the Ethereum. So in that case, right, when we talk about modular for rollup as service, it's mainly like for us, like we mainly focus on this execution layer, like really run the rollups for the applications. So that's sort of the definition for the modular when we talk about the rollup as service. But as you mentioned, right, for, if in layman terms, it's really like AWS or cloud services in the crypto world. So people can really just define the parameters, names, and just click a button, and then quickly either use us or some of our like projects, like platform to quickly launch a rollup for the application. It's either like sort of EVM compatible, or it can also be WASM compatible, or even SVM compatible, or even like JavaScript compatible, right? It's really like in general execution layer, but mainly for a lot of these decentralized applications. Sorry, my explanation a little bit long. It's not as short like as the number one. Yeah.
I guess, Neil, do you have anything to add or take issue with IQ's answer?
I like that analogy, AWS for crypto. That's very flattering. I'm going to use that. Yeah, I feel like what's interesting, well, I won't get too much. I feel like I'll just say it, but what's interesting about Alt-Layer is that it's reducing the fixed cost substantially by making it a short-term rollup. That's kind of the idea, the ephemeral rollup. But yeah, rollups as a service, it's like managed infrastructure. This way you don't have to actually do the deployment yourself. And more than that, you don't have to maintain its reliability. Some other team and you're outsourcing that to them. Though I think where it can go wrong is when the rollup as a service is spending too much time on consulting or things like that, because that's not scalable revenue in SaaS terms. And I mean, RaaS, the whole name kind of like tries to piggyback off the connotations of SaaS.
Yeah, of course. So also, I think it is nice to make a distinction between rollup as a service and rollup frameworks for now. So as Neil mentioned, it's basically managed infrastructure for RaaS projects. So for us, it's mostly around like the framework model. So it's interesting that still it can be thought about as AWS, because AWS has other services also that you can use to build the cloud project as well. So for us, we think of it more in terms of like building tools for creating those state machines and like creating those rollups instead of like having a chain which you can deploy applications on. But yeah, the AWS example still works.
Well, I guess the reason why that AWS example doesn't quite work is because we don't own the hardware ourselves. At least I don't think any rollup as a service at this point owns it. And that's why AWS works so well, because they get economies of scale. When more people use AWS, their data centers grow or whatever. It's like the whole Amazon flywheel. And maybe that is the direction that Rollups as a service could move in. They start to like vertically integrate even further.
Yeah, to build off of that, like I think if for a technical audience, the example I like to give are like platform as a services. So like a Heroku or like Render or Railway. There are a bunch of these that are built effectively on top of AWS or GCP, but then offer services on top. That's effectively what I think all of us are doing. I suspect none of us are running our own hardware. We're all on top of a public cloud. I think that the definition was good, so I don't have too much to add. The one thing I'll also say is like I see Rollups as a service as like the distribution layer for the rest of the modular stack, right? So if you have like the rollup frameworks themselves, right? Stacker being one of them. You have like DA, shared sequencer networks, et cetera. When people, but who are like the people and the projects that applications or people who want to build chains are going to come to, they're probably going to come to us. And so we get to act as kind of like the top of funnel for all of the amazing projects lower in the stack and help them reach adoption as well.
Yeah, but one thing to keep in mind is like Heroku never became a huge business though, because as a result, like when a company got big enough, they would just move off of Heroku. So I think that's something that distinguishes Rollups as a service, which is that you want to build in something that makes it a little stickier or like builds in a network effect into the whole deployment.
If we let's back it up a little bit and kind of talk about, do you think that kind of rollups as a service only makes sense if we exist in a world where there are like a lot of rollups? This is a two-part question. One, do you think we need rollups, or whether you think that there will be a future with a bunch of rollups, and why do we need them as a service?
Yeah, I'm happy to go. I think honestly, like there's less of a distinction between whether we need rollups versus like whether we need block space. Really like rollups are on some level an implementation detail. And the reason why we've seen a lot of, proliferation of rollups as a service versus like sidechains as a service, right, which could have been done back in like 2017, 2018, and kind of was done with like enterprise blockchain, but didn't really go anywhere, is that with like rollups, it's much easier to provide them as a service. The model makes more sense, and it's easier to be more aligned with a chain like Ethereum. And so that's kind of one of the reasons why we've seen proliferation of rollups as a service. And the motivation behind that is just more block space and varying types of block space on blockchain networks. So like all of us has probably spent some time talking about like fully on-chain games, on-chain social, high throughput applications, high latency applications, all sorts of blockchain applications that are, continuing to further like blockchain as this platform for like general compute. If you see those trends moving, like you need some way to scale, and rollups as a service I think are just the easiest way to get there. And then the question is like, why rollups as a service versus just like rollups in general or hosting it yourself? I think it is similar to like the cloud services model, where like you could run things on bare metal. There was a time when people did that. I remember an anecdote from like the early Facebook years. Like every time they added a new university, they like physically went into like a server farm and like racked a new server and like added that to their platform. So like you could do that in a rollups, rollup world without needing rollups as a service. It's just adding another layer of abstraction on top.
Also, to add on top of that, you mentioned like, do we need so many rollups and stuff? So I personally see rollups as more on the application side of things than chain side of things. So I think the whole theme for today has been, at least in this room, has been like rollups should be as easy to deploy as smart contracts, right? So over to like right now we are building smart contracts, applications as smart contracts, but in the future, if we have like better tooling and better infrastructure on that, we can just start building applications as rollups. So instead of the applications being deployed on a rollup, application becomes a rollup in itself. So I think one of the most prominent examples is DYDX. So DYDX is like just doing before that, before it moved to its own chain. It was basically a StackX app, and that's something which I see happening more once we build better infrastructure to deploy apps like that.
Yeah, all right, so that point on like the block space being the reasoning, I guess what's interesting to me is like there's a lot of commodity block space L1s out there, and like they're far from saturated. So I actually think that the biggest reason why people deploy their own chain is economics. And that also explains why we never saw sidechains as a service, because the fixed cost for a sidechain, for it to actually be secure, is much, much higher. For a proof of stake chain, you actually need some amount of stake, probably millions of dollars to secure that chain. And on top of it, you need like 100 validators, each of which is burning some amount of money every month. So you're burning millions and millions of dollars. Whereas for a rollup, the fixed cost is very low, because you only need a small number of sequencers. So what you're inherently doing is you're reducing the fixed cost, And the trade-off is that you've increased the marginal cost, because now you have to post every transaction to an L1. You have to pay for DA. But the upside is that when there is execution congestion and things like that, then you actually share in that upside. So you're going from being a rent seeker to being like more of a homeowner. So that's my thinking. And yeah, as far as why rollups as a service, I'd agree. Like, it's just too cumbersome. It's not something that I think application developers should be thinking about if they're, as far as like running their own stack. Reminds me of like when people used to have their own in-house data centers. At Citadel, we used to have that actually, and it was actually much cheaper than using AWS if you don't account for the engineering time that went into maintaining that whole system. So eventually we pushed everyone to AWS. That confused a lot of the portfolio managers because they're like, what? Like the in-house thing is so much cheaper. That's because Citadel wasn't really doing the accounting properly. They should have been properly attributing the engineers that worked for the reliability team and trying to like average out that cost as well.
Actually, I can provide some extra real-world examples because we all talk about this block space in theory, right? So we know that Rollup can provide much cheaper block space, and also at the same time, if we can provide fraud proof or validity proof, we can still derive the security guarantee from the L1s like Ethereum. But beyond that, we need some real-world example, right? One of the example I can give is that we are working with one of the biggest gaming partners right now. So the thing like they got a lot of IPs from Sega, Ubisoft, and some of them. So the thing like they couldn't really do this manual consulting one by one for their partners. So what they have right now, like collaborate with us and later use us to launch a rollout for the games, that they can make it scalable. Like for example, instead of assign like a 10 people or 20 people team, like consulting company, and to talk to different like sort of IPs, right now they can just use us to quickly just click a bunch of buttons and quickly launch that multi-sequencer with fraud proof like rollout for them. To serve their customers. So in that case, like they can quickly like just scale the business, not just like talk to them one by one, but really like once they got the deal, and then they can quickly spin off the rollout for them. That's something I believe like probably if like all of us, like especially in the room, right, we believe in the Web3 future, we must probably eat the pie of internet industry, right? So in that case, definitely we have to envision like in the future more and more the mobile applications will use blockchain in the future, right, as a backend. So in that case, we definitely need a much more scalable and high performant like infrastructure. So what we can provide at this panel for the developers to use, yeah.
Got it. Thank you. Could we go down the line and kind of talk about, I mean, now we're all convinced that Rollups as a service is the future. Like, why is your project the one that developers should work with?
Yeah, great question. I think this is going to lead to some interesting answers. For us, we're really focused on providing the most mature stacks that exist. So OP Stack, Optimism, and Arbitrum Orbit. And also we have really, really high focus on customizability. Anything from like changing the chain parameters easily, using Alt-DA, choosing which stack to use, all the way down to like custom stateful precompiles. We've been working on interfaces to allow developers to do that more, all the way to, potentially like additional VM level modifications. As well, we have a big focus on middleware. I think one of the things we've realized is just like what it takes to produce a viable chain doesn't stop at the sequencer. We're really focused on providing additional infrastructure, looping in folks we work with other infrastructure partners, creating a broader ecosystem of modular services and modular infrastructure. And our focus is just on DevX, ease of use, and getting people to the market with a viable rollup in the shortest amount of time.
So on our side, we are a little bit more crypto native, like because most of the team members joined the crypto space since 2016, building these public blockchains. So for us, right, we are mainly focused on this decentralization and security. So the stuff you can use all layer via our dashboard. You just click button within 2 minutes, you can launch a rollup. But what you can have is really a decentralized sequencer. You can choose the number of sequencers you have. And also multi-VM support. Right now it's EVM and WASM compatible. And beyond that, we also have our own proof system. So it's you can choose a settlement layer like Ethereum or the EVM chains. And later, like if there's anything wrong, you can have a challenger verifier to do the challenge for the proof. So that these sort of like the most of the advantage we have is really to highlight the decentralization and the security. So that's why we spent like almost 2 years on the implementation for this multi-VM and the proof system. Yeah.
Yeah, I guess my view is that like all the rollup frameworks to some degree are in their infancy, and that especially optimistic rollups, none of the fault proofs are permissionless or enabled. So to me, what distinguishes like different rollup frameworks or rollups as a service is what they chose to focus on, and consequently what they could not focus on, and because that implies a trade-off in terms of their positioning. So for us, we focused on one was high throughput and high performance, and the trade-off there is that the nodes are heavier. So they're beefier nodes, but they're very powerful. So you could run like just an unheard of number of transactions, and we have games that are posting literally hundreds of transactions per second on chain, and it would only be possible with a parallelized EVM. So that's one reason. And then the other thing is avoiding vendor lock-in, and that's something that also implies a trade-off to some degree, because it means that there's no strict allegiance to any ecosystem. You can actually pick which ecosystem you want your rollup to be aligned with. But as a result, Eclipse itself is not really aligned with a specific ecosystem. It's more like people, when they deploy an Eclipse chain, they choose the positioning for it, and they have to make that positioning known. So that's kind of how I think about it. Trying to think if there's anything else that really distinguishes, because I feel like all the integrations, things like that, like everyone has to provide a block explorer, you have to provide bridges. These are just necessary conditions to having a viable rollup.
So for us, I think we stand at a little different from all the other projects right now over here. So our focus is mostly on developer experience. So we want to build a system so that you have like a very Web 2 style of building Web 3 native applications, and that's what we are going towards. So it's not a chain that we are providing. It's a toolkit that we are providing. It has a bunch of library functions. So you can think of it as like how you develop React front ends or something like that. You have like a whole component system. You pick and place components, and you just place them so that it just like builds like your own state machine. So that's the thing that we are focused on, like building, making people give them access to build their own custom state machines, and those custom state machines we are calling it as micro rollups, because they are like literally what you want them to do. So if you want to do like you want to build a token transfers application, you just pick and place the components required to do that. If you're building a gaming application, you just take in like a ECS system and you just build a state machine out of that. So that's the mode that we are trying to build in and provide. Yeah.
So moving over to economics, like how do you envision rollups as a service kind of monetizing? I guess we'll start with Neil.
Well, I don't think that there's like anything realistic beyond like fixed plus variable. The question is just like, what is the variable fee charged on? Is it on like the size of the transaction, or is it based on volume or something like that? And then the question is, how much is that fixed amount? And it should be some function of the cost of running nodes. It should be some function of just like the market. It depends on like where the surplus accrues, whether it's to producers, consumers, but some variation of fixed plus variable.
So I really like the data Neil and also Matt just presented in the talk. As we know, right, I also give a talk at ECC on the first day. So the thing like we have to have the breakdown of all the rollups, either for the general purpose rollup or the application specific rollup. So in general, it's like they all discussed, right? So 3 parts. One, the execution cost, so you can charge these part of fees from the users, right? To cover your L2 operator costs, and probably also sometime when you post the data either to DA or to the L1. So these kind of average cost. Beyond that, they are also like regularly post like data to DA, right? So you, for games, like probably they always prefer like cheaper price. So then it's Celestia, EigenDA, and AVO probably are the better solution. But in the end, like I believe probably for all of us, we are trying to make it as modular as possible. For developers and project, they can choose what kind of solutions or pricing plan they want. But for either it's like sort of the normal pricing plan, different tiers, or we make it like pay as you go. But in the end, it's sort of like after the cost from the running the infrastructure plus the service fees, we can charge from these developers or projects. Beyond that, I think one good thing like for all of us that if some of these rollups are quite successful, by running these sequencers or executions, right, we can sort of have some premium on the L2 fees, either from the users or from the projects. Yeah.
Right, so how many different pricing plans do you guys have then?
No, I just give one example. It's sort of like the multiple ways, right? Like you can try pricing plan or this pay-as-you-go. It's different like models. But in general, we need to cover the cost for the L2, infrastructure.
Right, yeah, there's a lower bound on the cost.
Yeah.
Wait, so if you're talking about like hypothetical pricing plans, I'm curious like what your project currently is charging.
For me, to be honest, it really depends on the like sort of customer. So I can give you one example, like because we are providing like different types of products, right? One is so-called flash layer. So for some NFT mint and also some games, they spin off the flash layer for a few hours, and then they tear down. We roll up all the NFT back to the L1, like Ethereum, Polygon. So in that case, it's like a one-time charge for this flash layer. And the another one is like a relatively like a persistent one. So in that case, it sort of like depends on the number of sequencers you choose and also the DA. So on our side, we can charge like sort of the infrastructure cost for the number of nodes you run. But at the same time, if it's really successful, there's a premium like sort of from the fees we can get, something like that. But still, right, it really case by case. Some game providers, we work with them. They charge nothing from the users. Yeah, they really charge nothing. So it's a zero gas we provide, and basically in that case we can only charge the fees from the game providers. Yeah, it's really case by case at the moment.
Yeah, so gasless transactions are interesting because how do you prevent spam with that specific architecture?
So for these games, right, they have the whitelist. Yeah. Have a whitelist for users.
There's some kind of built-in
something like that.
Basically.
So that's why I say it's really case by case. A lot of these Web2 applications, probably Stacker has similar experience. So their requirements are quite different from the crypto native like applications. They don't really know how to install MetaMask. They don't really care, like you tell them like 15 seconds, 2 seconds, they don't care. They just want 100 milliseconds. Yeah, so what can you do? We have to make it very fast, but at the same time, need to fulfill their demands on all this stuff. That's why it's just some examples, but in the long run, definitely we can choose our customers, right? If we're becoming very big.
Yeah, well, I guess like once you have a self-service thing though, then you can't do it so like case by case. You have to have some like standard pricing.
Yeah, if I might jump in here, I think like one of the interesting things about the RaaS space in general is like any given pricing structure has like certain kind of failure modes, right? Like if you're charging like, a flat fee for hosting, maybe a small amount per transaction, you might end up securing like billions of TVL, making like a few grand a month. On the other end, like, if you're trying to charge based on TVL or bridge volume, you might be supporting like an on-chain game with no activity for very little. So I think like pricing models, like it does sort of need to be a little bit bespoke when you're thinking about different types of applications. And like really, like at least for us, like our North Star is just like we want to price it so that the user feels like they're getting a fair deal, like with the value we're providing, and that might be different for different types of applications.
Yeah, that's an astute point about the failure modes of pricing models, and actually offering different pricing models makes that problem worse because then like the amount you make is the minimum of all of those. You end up with like it's like not a great outcome actually. You have to kind of accept the failure mode of your pricing model.
Well, it's like something of like an iterated game, right? Like yes. They're like you could find like someone could act adversarially here, but like you could just like presumably you're actually providing value to them. They have some value, that they're willing to pay for.
Well, I think like you can at least assume that people are economically rational, right? They're going to pick the best deal for their application. So if you have like two pricing structures, people always pick the one for their specific application that's more favorable for that app.
Sure, but like if like the company ultimately has the decision. Like the power to make a decision there, right?
Yeah.
So you're
saying
like us,
take the one that's
Rollups as a no, I'm saying that the Rollups as a service company has the decision of how to deal with.
Oh, right. Yeah. You don't have to offer multiple options.
Yeah. It's just like typical enterprise sales, right?
Also, like, it's a question from you guys, like how we see things differently on the experiment side. But how do you feel like the companies running the application, like putting it the charges onto the user? Like, how do you see that happen? It's just like, what are your thoughts on that?
Oh, that's a good question. I think in certain cases it makes sense. Like you mean basically charging users transaction fees. Like, it makes sense in general. We as a company, we're very skeptical on business models that are entirely dependent on that, on user paid transaction fees, just because there's like pretty massive incentive misalignment there, right? Like, you know, there are some folks like working in the space who are like, you know, they're taking some percentage of fees that users are making. And like, it makes sense now. And you'll see a lot of like VC tweets talk about this with like Optimism or Arbitrum, right? I don't know if anyone in the audience has seen these tweets. Like, you know, once 4844 gets merged in, like the margins that Optimism and Arbitrum are going to make are like going to go to the moon. Like, what's actually going to happen? Fees are going to come down. Margins aren't going to go up, right? Margins are probably going to stay roughly the same.
Well, it depends on like how that surplus is distributed, right? When costs go down for a business, they can also make more money, or it can be completely passed on to the customer.
That's true. But like historically, what we've seen is that these get competed down to like to very little.
I think that's because Optimism and Arbitrum though offer commodity block space. Like the user or the dApp developer doesn't care about whether they're deploying to one of those or the other, and therefore like they compete directly, right?
Yeah, that's correct. It depends on how you view like the rollups as a service space. Like, do you view like on some level there's differentiation? I think like we know that like when users talk to one of us, they're talking to like most of us, and so like on some level there's commoditization.
Yeah, I agree with that. Yeah, the biggest benefits, which is economics, are common to all chains.
All right. Let's move on to developer pain points. What are some of the, you know, common pain points that, you know, teams that you work with bring up, and kind of how do you plan on solving them? And then also I want to leave some time for questions from our audience after this question.
It's got to be liquidity fragmentation, I think, and interoperability. And that's a tough one to like answer, because for a lot of apps, the right answer is that a rollup at this point is not quite right for it. If it really needs to do heavy composition, especially atomic composition, and even through shared sequencers. Espresso had this awesome workshop yesterday on shared sequencers, and they gave this toy example about a bank, and the bank contract is on 2 chains. It shares a sequencer, so that sequencer produces full blocks for each of the 2 chains. And what you want to do is you want to put USDC on one side and get DAI out of the other. And the tricky part is making sure that it doesn't fail, and it doesn't like, you don't put USDC on one side and the DAI doesn't come out on the other side, or vice versa. DAI comes out and USDC does not go in. And that basically relies on the builder providing a block which is correct, because the builder can execute all the transactions. They know if the block they submitted is going to revert or not. So you want to make sure that builder is acting honestly. So then they said, oh, well, you can just have the builder put up some stake. You can slash the builder. And that, to me, that was like a fun example. But after the talk, at first I was like, that seems reasonable. But then for like an hour after the talk, I was like, there's so many failure cases for that actually. Because I mean, if the bank could lose out, and there's just like collusion issues, the stake size, it was like the devil's in the details there. And also, how do you prove the transaction failure? Do you like use the L1 for? But maybe this is a tangent. But my point is that atomic composability is really hard to achieve between rollups. So as a result, you basically have to kind of focus on apps that don't rely on that so much across chains.
Okay, I will continue using the real cases like we handle recently. I think the major like issues right now is still about technical issues. We have some back to the like sort of the partner, right? They ask us to have this kind of latency. You can have a try. It's like you must provide this less than 100 millisecond, and basically you play a fully on-chain game, every move on-chain, but at the same time it's seamless and no latency. That kind of the ridiculous requirement like asked by our partner. So the deal is like, can you achieve it? If you cannot achieve it, then forget about it. So we have to spend a lot of time, a few months, to really like optimize and re-implement the execution layer ourselves to make it like EVM compatible, but to achieve this less than 100 millisecond latency. But this is something like an extreme case, right? One case like this. Another case that we also got some crypto native partners. They want like super decentralized like sort of roll-up system. They don't care about latency, but they want it as decentralized as possible and as secure as possible. Better you have a lot of sequencers, but at the same time you must have a proof system. Otherwise we won't use it, because this one is used for public good or something like that. So it's really from one extreme to another extreme. Like this includes a lot of these technical development to tackle a lot of technical challenges which the existing general purpose L2 haven't like solved yet. But as a sort of like, I mean, a provider, we have to solve this technical question probably ahead of the big players in L2 space. It's just like that's why I highlight there are a lot of technical challenges here. But do you think it's worth it? I believe so, because we all dream like probably for the next 10 years it's a world for Web3, right? So we want to handle like billions of users to use blockchain for in the normal application. So in that case, latency, we need to solve it. Decentralization, security, we also need to solve it. These are all the great properties for blockchain. But at the same time, you can see, right, I feel like we are still in the early stage. It's not like we are talking about RaaS and we feel like we already have 4 great companies, but at the same time, there are a lot of new problems we need to solve. And I believe it's still early, and we really need together fix like all these solutions for that, yeah.
So also we see developer experience, like building in Web3 itself as a developer experience problem, and that is also something we would want to optimize for. So like if you're building a game, you write some component in Solidity, then you write a front end in some other language, and then you connect them, and like they just like it's just hard. The integration is just hard, and also like you mentioned, like the latency issue. So we kind of categorize it as 2 different things: the developer experience and the user experience, and we kind of like optimizing for both. So you get like both like the Web 2 experience for building Web 3. Like I've been saying that over and over. So that's the kind of thing that we are solving for on the experience side of thing. It's not just the developer experience, but also the user experience that needs to go along with while building applications.
Yeah, I want to leave some time for questions, so I won't rehash what they said.
All right. Do we have any questions from the audience? No.
In the case where you have applications that are seen as killer applications, do you expect that you have to compete between the 4 of you and offer sort of concessions to them to get them to build on you instead of some of the other people that are there?
I think there are cases when a rollup framework is uniquely suited to serve a particular application. And to me, things like virtual machine compatibility actually they actually represent a reduction in fixed cost or one-time cost for a user to use your RaaS. For example, like if you have SVM compatibility, technically a chain or a dApp coming from Solana doesn't have to use you, right? They could use an EVM chain, rebuild all their smart contracts in EVM. And that's what's funny. When I remember when Starkware was writing the contracts for DYDX and Cairo, people were dunking on that a lot. But actually, they were to me, Starkware was doing exactly the right thing. All they were doing was, it could have been built by DYDX, or it could be built by Starkware, but that's just some cost that's being incurred by someone. They're just saying, we're not going to pass it on to you. We're gonna incur it ourselves. So I thought that made sense. But yeah, there are cases where yeah, definitely we'll be talking with a few different, like they'll even just tell us, hey, we're talking to these other folks. These are the models that they've given us. Like, could you just like highlight the differences rather than giving the whole rehash?
Yeah, I think it's, I mean, you mentioned concessions. I think people are less focused on concessions when it comes to like pricing and business model than they are on like which service makes the most sense for them. Like this is for a lot of applications, like the biggest infrastructural architectural decision they will like ever make, at least for like that version of the product. And so like typically we find it's like, it's more on the fundamentals than on like price or anything else.
Should I just shout? Thanks. On some level, obviously you're all kind of competing with each other, but I wanted to ask who you view as your biggest competitors, maybe in kind of an unexpected way. You know, is it, no, hang on. Pick someone to cage fight amongst the 4 of you. No, is it like app developers looking at like the Cosmos ecosystem to have more modularity and control over their stacks? Is it other L1s? Like, what are the alternatives that your customers are looking at outside of launching their own rollups?
it depends on the stage of development that the application is in. It depends on the vertical and things like that. But overwhelmingly, the competitor is actually the status quo, just whatever they're already doing. Because it just is cost for them, but they have to put in a lot of effort to switch to another chain. They're not necessarily even going to have their own chain. I find that usually it's not between like Cosmos L1 versus Rollup. I find that that's not as common as I would have expected. And I actually thought that we'd be competing with Solana more initially, just because they're also a high throughput chain. Then I guess Solana just kind of fell out of favor, became totally irrelevant. Oh, they are. No, I think it's Solana. I'm super like long, like Tolly and those guys. I think they're really smart. Yeah, but that's just reality, like who we typically find we're talking to.
Yeah, I think to his point, like the stage of which the project is at, it's the most important thing. So some may want to spin off of an existing L1 protocol to a Rollup as a service, or some projects which are just starting out might just pick a chain to just build off of, or a framework to build off of. So I think that's very important.
All right, I think we're out of time now, but let's give a big round of applause to our panelists.
And a round of applause to our moderator, please.
Thank you. Hey, good job. Nice.
Yeah. Great hanging out. Great. Yeah. I think it's like on RaaS, because like I feel like we'll eventually work together. Yeah. Yeah.
More of a. I can take it.
Thanks.
I can take that. I can also take the clicker. Awesome. All right. All right, testing. Can you hear me? All right, and we're back. All right, please settle in, take your seats. Thank you for sticking around. We've got about 1 more hour and 1 last segment of speakers here coming up. Please settle in if you're still in the room. Take the conversations outside in the peanut gallery. Thank you. All right, we've got 1 more segment here of talks before happy hour, and it's going to be great. So settle in. Thank you. It's going to be on interoperability in the modular world. And first up, we're going to be hearing from Jim Chang on the role of relayers in the modular ecosystem. So Jim, come on up.
Well, thanks for the Celestia team and the Maven team and all the other sponsors for having me up here. Really excited to be talking about something that I don't think many people actually talk about in the interoperability space, and that's relayers, and how relayers are incredibly important to kind of the cross-chain ecosystem, but also incredibly important as we scale into a modular world, and there's more and more kind of modular layers that need more coordination. And before I start, just a little bit about me. I'm Jim. I'm the co-founder of Catalyst, which is a cross-chain liquidity network. If you guys were here for the RaaS panel earlier, they're talking a lot about liquidity and interoperability and how that's really important to kind of this rollup as an ecosystem world, and so we're trying to solve that. I'm also a DeFi and DAO builder, and so I've been building this space for coming up on 6 years now. Most recently, I was a product manager at Aave, and I've contributed to a few DAOs like Pleaser and Gitcoin as well. So kind of have loved and known this space for a long time. And I'm also a cross-chain enthusiast, which I don't really know what that means, but I read a lot of blog posts. A little bit about Catalyst, although we're not going to talk too much about it today. We call it permissionless cross-chain liquidity for the modular future. Basically what that means is we have sovereign liquidity that lives on different rollups, and they're able to actually coordinate permissionless cross-chain transfers with one another. And we can connect all ecosystems. So not just EVM, not just Celestia, not just Move. We can connect all of it quite trivially. And we do that through integrals and other kind of complicated math, but not going to kind of go over the details of that today. Instead, we're going to talk about relayers and why they're important. And so a little bit of context. I have liked relayers for a few years now. I think it's probably the unsung hero of really, cross-chain and interoperability broadly. Relayers are called a lot of different names. You can call them agents, solvers, underwriters, what have you. But basically, it's just an entity that moves packets and coordinates any sort of off-chain data in between two different blockchains. And so pretty important in the context of moving between blockchains, as you can tell. But why are relayers important, and why are they going to be even more important? It's because of the modular blockchain stack, right? I think all of you guys are familiar with modular blockchains, hence why you're here. Splitting up all these different kind of tasks that a monolithic blockchain does into 3 separate tasks. But I think now there is a bit of an evolution on the thinking of it, and it's less about, there's 3 different tasks, but it becomes 4 different tasks, right? You have transaction ordering, using shared sequencers. And so now there's 4 parts of the modular blockchain stack. But what do we have here? If you guys were here earlier in the week and you guys attended Polygon 2 Day, you would have seen that Polygon kind of unveiled their stack, and their modular blockchain stack has a few other names. They have things like staking and proving and interoperability. And so if you look at it holistically and you see kind of the modularity of blockchains and more specialization, it starts to look a little bit more like this. And so we started off with 3 things that modular blockchains could do. Now it became 4 things, now it becomes 6 things or 7 things, right? You have proving, you might have liquidity / staking / restaking, you might have interoperability, and that gets a little complicated, right? And I think what becomes more complicated about it is as there's more and more modularization and more specialization of these blockchains, there's more complexity in the verification, right? If you're trying to send a transaction from one chain or another, or one rollup to another, you actually have to verify all the different pieces to ensure that this is a valid transaction, right? To verify the state verification. And so it used to be, okay, just moving from chain A to chain B, but when you go to a monolithic blockchain, you have to make sure there's DA proof. With a shared sequencer, you have to make sure there is a transaction ordering proof as well. And it gets more complicated. Now you need an execution proof, you need a settlement proof, you need interoperability. All of these things need verification. And how do you do that? I think the simplest way to do it is just to have native verification, i.e. you have, light clients that are pointed to one another. And so if I were to have to send one transaction in this new modular world, I probably have to have 6 forms of verification. And that gets very complicated very quickly. And how do we, pass all those light client header updates to all those different layers? How do we actually coordinate the communication between these, execution layers and one another? It's with relayers. And so you're starting to see, okay, wait, relayers are super important. They're going to become more important, and they're kind of everywhere. And so is it all relayers when you look at the modular blockchain stack? Not quite, but yes. And I would say it always has been. And so at Catalyst, when we think about building cross-chain solutions, we think it's really important to build a really good relayer system. In fact, we've had the privilege of working with every interoperability protocol, assessing their relayer systems, and seeing that it's not quite good enough. And so we kind of took it upon ourselves to think about, okay, what is a really good relayer system, and how do we bake in the incentives for a good relayer system into this cross-chain sovereign liquidity network that we're building at Catalyst. So a little bit of a public good, a little bit of a side quest, so to speak, but something that we love and feel very nerd sniped by. And so what are good requirements for a relayer system? One, calls always arrive. It's good when you have things queued up in the outbox and you actually receive those messages. Two, pricing is transparent and fair. You actually know what you're going to be charged and you know what the margins are going to be charged. Right now, I think a lot of relayers are public goods in the sense that they're loss leaders. You have foundations that run them at a loss, but I think at scale, you probably want to bake in some economics to it. And then lastly, relaying is sufficiently decentralized. And it's not decentralization for decentralization's sake. There's actually a really important reason why we need that, and I can talk about that a little bit later in the presentation. And so the first thing, double clicking, we think a lot about what are the big questions behind designing a really important relaying system. And then when you break down, the requirement of having calls always arriving, you realize that there's kind of two pieces to it. Calls need to arrive, but calls need to arrive quickly, right? They need to arrive within a reasonable time span, or else you add latency, and therefore, what is even the point of having this happen? And so at Catalyst, we were kind of under the assumption that things were just relayed, right? They just happen. And if you're in testnet, that might be maybe the case. But if you're in production, if you're on mainnet, not typically the case, right? And so a little bit frustrating there. And so we realized that calls don't always arrive within a reasonable time span. So how do we incentivize this, right? Are we building a system in which relayers are penalized for not having timely delivery of messages? Or are we building a system in which it's more of a kind of a willingness to pay? Users have a willingness to pay, some sort of bid-ask system in order for relayers to be relayed. We're kind of still designing the system. And the second piece is, what if calls don't arrive in a timely manner, right? And so calls should be able to be canceled or timed out. But what happens when a message gets stuck? Do we need to implement some sort of recovery system? Do we need to implement some sort of bidding system? How do you design a mechanism in which people understand, or users rather understand, or applications understand when relayers are taking too long and you just need to pull the whole plug and try it again? And so that's something that's really kind of top of mind for us when we think about designing a good relayer system at Catalyst. The second piece is pricing being transparent and fair. Like I said before, relaying is free right now. Well, not free, but free for the user. And it's being paid by someone, and it's usually the core teams of these interoperability protocols or the foundations or subsidized by the validators or what have you. But I think in the end state, it's really important to have some sort of economic system for this. And so when you're implementing an economic system, you want it to be fair. You want it to be transparent. And people want to know how these routes are actually be priced. And so there's a couple ways you can actually think about pricing a route for a relayer system. You can have it be an algorithm, right? You go, okay, here's all these different factors of, this is what the gas limit is, this is what the gas price is, this is what the consumption is, this is what the congestion of the network is. You spit out a number, right? And people just take it, that's totally fine. Another system is having some sort of bid-ask kind of order book, so to speak. And so users have willingness to pay, relayers have willingness to accept certain services within a certain threshold. And so it starts looking a little bit more like an order book, which has, of course, MEV implications that I'll talk about in a second. Or you can have user-determined bounties, right? And so I think this one's pretty popular within the IBC ecosystem. You have a standard called ICS-29 that has this kind of user escrowed bounty where you're saying, hey, the user knows how much they want to pay for a cross-chain packet. And they'll put it up, and then the relayer will take it, right? And kind of the criticism of that is like, how do users know? How do the users know they're going to pay $1 or $2? It's kind of hard to say, and you're kind of leaving a lot of money on the table in that regard. The second piece is prepaid versus pay at the end, right? Are you going to kind of load up a balance and have someone withdraw from it? Are you going to actually kind of pay them at the end once they do this delivery? If so, there's all sorts of implications, right? One is, what token do you pay it in? Do you pay it in the origin chain? Do you pay it in destination chain? Do you pay it in USDC? What is the price risk of these relayers? And if there is kind of a price risk, how is that fairly priced, right? What is kind of the oracle in order to have some sort of mid-market price in order to do the swap? Let's say if it's from USDC to ETH, or it's from ETH to Matic, or what have you. And so you're starting to see that, like, okay, so a very, very simple kind of idea becomes very complicated very quickly. You're like, oh yeah, like, we should price relayers. And now you go down this rabbit hole and you say, okay, actually, it's pretty difficult to do so, right? And then the last piece is, how is gas handled, right? How is gas estimated, paid for on a destination? And as I'm going to talk about in 2 slides, it's actually a pretty big trust assumption that you have no matter what kind of system that you're architecting. And so what are the assumptions on that last piece, right? So the most important question when you think about gas estimation is, who is doing the gas estimation? Who's calculating that? And so calculating gas on an origin chain is pretty straightforward, right? It's what any kind of client does or interface does. But doing it for the destination chain gets a little tricky, right? And so you can obviously have some sort of trusted solution. You can ping an RPC, or you can have some sort of somewhat trusted solution. You can use some sort of gas oracle. But the question always is, who's making the gas oracle? Are they taking the margin on the quote? If so, how much is it? It's totally fine, but I would say from our experience of using all of these different primitives is that it's pretty opaque. Someone's making money, the user doesn't know, and that is not really ideal for us as we're designing our relayer system. And there's also trust assumptions on the delivery, right? Let's say everything's perfect. You have this perfect price that everyone feels very comfortable with. You're leaving no kind of leakage in this economic system. You're still trusting someone, right? And so many protocols, they pride themselves. They're like, yes, we have an 1 of n relaying assumption. But the reality is, it's not 1 of n. It's typically more of a 1-to-1. And why do I say that? It's because users have to trust the relayer that they're paying at any given time. And so if you find a relayer, you want to pay them, they're going to send the message, you give them the money. How do you know they send the message, right? Oh, I think as a kind of caveat, you could probably pay a lot of different relayers. But now instead of charging $1 to deliver 1 message, you are holding up $5 for 1 of those 5 relayers to deliver a message. And so I think the takeaway here is lots of trust assumptions on this relayer delivering the message, and there needs to be some sort of mitigation for that. And so I'm posing a lot of questions with no answers, but this is probably the closest answer that we have so far. And we call it conditional payments. And so it's basically a one-time payment on the source chain with some transparent pricing in mind. And we try to make it as trust minimized as possible. And so the flow for this is as so. And so there's a price quote that's generated for the relayer, right? Let's say we're using some sort of top-down systemic pricing algorithm. We actually use Catalyst as this kind of price oracle, and so we're able to calculate how much gas is on a destination chain and what is the actual fair rate between the origin and destination chain gas tokens for the swap. The user's payment is then escrowed on the source chain with a time decay. And so there's incentive for these relayers to go very quickly in order to actually capture the full amount of this escrow. And then a relayer must return with some information from the destination chain in order for the escrow to be released. And so we're talking about round trips here, not just one direction, but one direction and then sending an acknowledgement back that something actually happened with the necessary Merkle proof in order to prove so. And it's a 1 of n design because this bounty is open for anyone to claim. And so we think that this is a pretty good start on what we think is a much more trust minimized and much more kind of robust and transparent relaying system. And then over time, we do want to overlay MEV to this. And so like I said, one way you could do pricing is have some sort of kind of bid-ask system or an order book system, which begs the question, where does the MEV kind of come into that? And so I think the holy grail that people like to talk about when they talk about relayers, and when I say people, I mean me and 4 other people in a Telegram group, because no one's really talking about this, is OFA, which is order flow auctions, right? As folks may be familiar with mempools and flashbots and private mempools. And so OFA, and so you think about this, there's an OFA for an origin chain, and they're actually queued up in some sort of auction. And then you have these relayers actually bidding for this order flow, right? And why would they do that? Because then they have the exclusive right to be the relayer for that order flow, and they extract what we call REV, which is just relayer extractable value. And they're able to bundle this order flow and have some sort of sandwiching, as what Vaibhav from Socket kind of talks about in this screenshot here in the right, and they can extract value from it, right? And there's this kind of additional element that we call censorship MEV, which is, okay, what is the willingness to pay of a user if their transaction that spans 2 different domains has a lot of MEV to be extracted if all the relayers coordinate and say, hey, we're actually not going to pass this message, right? And so a good example of that is that you have a position that's about to be liquidated on Aave, you have some collateral, it lives on a different chain. The relayer recognizes that and says, hey, you're only paying me $1 for this $100,000 liquidation position. I think you need to be charging me a little bit more, or else we're not going to be delivering that message. And so really, really big design space as we look at censorship MEV and relayer extractable value. And again, me and 4 other people on Telegram just nerding out about it. So the short answer is yes, MEV is going to be really important for incentivizing relayers and having sustainable economics for relayers, but we're not quite there yet in terms of having sufficient transaction volume or messaging volume in order to justify it. And we think that there needs to be a really kind of robust way of doing what we call self-relaying, which is if there's no MEV being generated by this specific message, you gotta have to relay your own message, right? Because in this paradigm, no one really wants to deliver your packet if you're not generating sort of economic value on their behalf. And so before I get to the last piece, I just want to say, we're thinking a lot about exactly what a super robust relayer system looks like. We care a lot about the timely delivery of these messages. We care a lot about the transparent pricing and the incentivization and overall the future proofing by including MEV into this. But lastly, and I almost think most importantly, we want to think about the sufficient decentralization of these things. And so again, some interop protocols have this kind of one-to-one relaying message delivery. It could be overtly, like layer 0, right, where even before you deliver a message, you have to specify a relayer. Or it could be more tacitly, where you have this kind of one-to-one payment assumption. You already pay the relayer, you hope they do something, but you don't know for certain, like what I talked about before. Or you have this kind of one of n system that's slightly more robust, but the n is really small because realistically, it's just these core teams that are running relayers, and so the n is more 2, 3, 4, or what have you, and not quite as robust as what one of n sounds like when people say one of n for a mechanism design. And then self-relaying can always be a fallback. I think it needs to be much, much more robust. I think this is a very similar narrative to what the Rollup folks call forced inclusion for rollups, right? There's censorship from the sequencer. You want to kind of submit it into the settlement layer. I think this is a pretty good analogy. I think self-relaying needs to be much, much more robust and have a lot more research behind it. And we at Catalyst think a lot about that. Think a lot about all the different pieces of a relayer system. And why is it important to us? Because ultimately, we think that healthy relaying will equal a healthy modular world. It's really hard to have modularity, really hard to have state verification between DA layer, transaction ordering layer, execution layer, and eventually all the other, fun layers that kind of come out in the future, like a staking layer, proving layer, what have you. They need relayers, right? And so not necessarily the core focus of Catalyst. Our core focus is liquidity, which is something, again, that all the RaaS participants in the last panel said was top of mind for them as a major pain point. But relaying and decreasing the latency and decreasing the trust assumptions between moving liquidity between rollups is super important for us too. Therefore, we think a lot about relaying, and we want to make it a mission for us in terms of research and a public good perspective to push forward the thinking on relaying research. So thank you guys so much for your time. Thank you. Feel free to follow Catalyst for more updates on that. Thanks.
Thank you so much, Jim. That was awesome. And up next, we'll be hearing from John of Hyperlane on more on interoperability in the modular world with a different take, a different approach.
Thank you, Jill. All right, let's get to it. Let's see, how do we go? You can see my face, and you can see it live, and you can see it on a picture, which we need to do something to get the slides started. Oh, there we go. I had a lot of slide skipping. All right, let's get to it. So today we're going to talk about modular interoperability, modular blockchains and interoperability, specifically permissionless interoperability. So if you think about why you guys are all here today, we are here at the Modular Summit because for whatever reason, and we'll get into that very specific reason, we think that the modular construction is an ideal solution to a lot of the issues that we face with blockchains. So over the next 20 minutes or so, we're going to get into that. We're going to cover the different moving parts, what needs to happen, what is feasible, and what is not. And so at Hyperlane, we like to talk about this concept of the interchain highway. What's that? It's kind of like a big word. It's something that we like to think of as a safe, somewhat fast path to connect between the ever-increasing and ever-expanding universe of chains. And the modular universe is one where we're going to have an increasing number of smaller chains, smaller than the monoliths that we've become accustomed to over the last few years. Specifically, we're going to talk about how permissionless interoperability and modular security help us create this concept of the interchain highway. So with blockchains, we have these really cool internet computers, right? They let us do all sorts of things, from starting with Bitcoin that gave us sovereign and permissionless money, moving on to Ethereum that gave us permissionless access to computation, right? I think it's one of the coolest things in the world that pretty much anyone here can access this permissionless substrate and run any computations they want on it. There's some magic in that. But with these internet computers, the way that they do this magic, it's primarily by introducing the concept of scarcity into the digital domain. We've never really had scarcity in the digital domain before blockchains became as common as they have. And this visualization here we have on the screen is something I really like. It treats each block as a bus, and I think this is a really effective visualization. Because if you think of a block, well, there's almost so much space in it. And if a bus has a certain amount of seats, so does a block has its size. Well, so every little person here trying to get on the bus, it's an incoming transaction. And they take up a seat. But unlike a bus that has a fixed number of seats, and once it's full, our buses introduce a mechanism of surge pricing. And so what does it mean for the bus to get filled up? It means that the thing that by and large all of us are here to bring about, right? Like to increase the amount of demand for these internet computers. Well, if we end up looking like the bus on the right side, right? We got a lot of passengers to get on. We're going to introduce this surge pricing. And so this is when that magical scarcity introduces a big, big problem. And all of us probably sometime in the last years have felt the anguish that comes from the surge pricing, right? When you're trying to do a transaction and suddenly you're met with like a $70 fee on Ethereum just to do that 21,000 gas of a basic transfer on ETH, right? The gas just gets too damn high. And modular blockchains seem like an ideal solution for this. Again, if we're here, it's probably because we think there is some efficacy in this premise of, we need more buses, we need more seats, and instead of just creating one massive bus that would be some magic monolithic chain, we're going to have a whole slew of smaller buses and smaller bus lines. Think of each one of these as being a new roll-up, a new chain. And that's where something like Hyperlane comes in, right? So here at the Modular Summit, we're talking about all the different ways that it's becoming easier and easier and easier to launch your own chain, to launch your own roll-up. In fact, with some of the participants who are here today, folks like Caldera and Conduit and Eclipse and AltLayer, they're making it as easy to create your own chain, such that you could really get something going within 10, 15 minutes. But if you've done that in 10, 15 minutes, how do you connect to everybody else? You need something that you can support yourself. And this, again, is where Hyperlane come in. I like to think of Hyperlane as something that, through its introduction of permissionless interoperability, acts as the final layer, the layer that completes the modular blockchain stack. Right? If we broke up execution, settlement, consensus, and data availability, for us to actually have practical benefits from that, our modular chains need to be able to talk to each other. If to enable that talking to each other, you need to go and convince someone on a permissioned interoperability team to add your chain, right? So you spun up your new chain in 10 minutes, but then you need to spend the next 10 weeks convincing someone to add you. That doesn't really cut it. And that's to the extent that folks have been playing around in the Cosmos ecosystem. The magic of IBC is its permissionless nature. It's the fact that you can spin up a Tendermint chain, you can spin up a chain in the Cosmos ecosystem, and through IBC, you don't have to ask anybody for permission. But it's become harder and harder. You can't really do that outside of the confines of IBC. And so we need to find a way to extend those confines. And there's a number of people working on this problem. So what is this problem really? When it comes to modular blockchains, it's this problem of permissioned interoperability. It's the fact that you need an interoperability provider to add you, to add your chain, so that your chain can communicate with other chains on their network. I think, and certainly other people might disagree, but the reason for this is that by and large, most interoperability protocols, they have coupled the product that they're providing, right? The ability to communicate between chains, or the messaging interface, they've tightly coupled it with the security model. They've made those two effectively into just one thing. But it doesn't have to be that way, right? It could certainly be decoupled. You can have that product, the way to communicate between chains, that interface on one hand, and you can have security be provisioned on the other hand. And that's what we do with Hyperlane. We really believe that modular chains need modular security. So we're going to get more into the specifics of that, but at a high level, I imagine most of you have had this experience of going to your bank. And when you try to get a nominal sum, say a few $100s out, the ATM will let you do that with just your PIN number. Don't really ask any questions beyond that. Try to do something a little bit more intense. Try to withdraw $40,000, $50,000. Try to make a large wire. Or if you dare, try and close your account at the bank and get all the money out of it in that same day. They're going to run you through a much more serious line of interrogation. They're going to want to see your ID. They're going to want to know who else is on the account with you. They're going to ask you, do you recognize the last 10 transactions? See your social security number, and if you're in the US. So what is the bank really doing? The bank is looking at the context of what you're trying to do, and they're running you through a different security protocol. And that seems to make sense. Most people don't really object too heavily when the bank is trying to run them through a much more stringent process, when their action is going to have a much more significant impact on the account. Don't really do that in crypto. Crypto, you try to move $100 or you try to move $100 million, we run you through the same exact system. Might want to think about why that is. It's something that often doesn't really get questioned. For us, we didn't think that necessarily needs to be that way. And so the introduction of modular security really lets us do that. And so we could talk briefly about different forms of interoperability to understand this concept a little bit better. The best way to verify state, if you can, is to leverage what some people call native verification. In this case, you're just leveraging the existing consensus between the connected chains. I'd say IBC is probably the gold standard in interoperability until today. And IBC gives you native verification. When you connect two chains through IBC, you're really just trusting the two chains that you're being connected, which generally is a fine assumption, right? Like if you're connecting between, say, Ethereum and Arbitrum, let's say, or say Ethereum and Avalanche, if you're using both of those chains, you're probably comfortable with the security models on both. So the fact that you don't need to introduce anything else is terrific. But the issue with native verification, it is that you need to, it's a very costly method because you're basically replicating the consensus of one chain on another. And doing it in a place that was not constructed for that, as is the case in the EVM world, is incredibly costly. The other mode is external verification. Not too complex, right? So we're still trusting our A and our B, our Ethereum and our Avalanche, but now we need to introduce someone in the middle. And hence the name, external verification. So this kind of looks and feels like an Oracle. If you're familiar with the Oracle problem, I imagine most of the people here are. And that's because, right, like external verification for interoperability, really it's just a narrow scope of the Oracle problem. Instead of oracleizing any type of information in the world, you're just oracleizing state from another chain. That makes it a slightly easier problem to solve, but it's still, at the end of the day, it introduces a third element of trust. And this is where a lot of things can certainly go wrong. So now, let's move on to modular blockchains, right? Again, we're here at the Modular Summit because we believe in this concept. And I personally believe that with modular blockchains, we're not going to have a singular hub. We're going to have a number of hubs from which we see an increasing number of smaller blockchains, smaller computers. Again, think of these as smaller buses, smaller bus lines. And so Ethereum becomes a hub. Celestia becomes a data availability hub. Cosmos is already a hub. Think of these little guys here in Optimism and Base and Arbitrum. And they can become little hubs too. But we're going to have these hubs everywhere and more chains that come out of them. Would be, there we go. They need a way to connect with each other. And every time you create another new little computer, another little bus, how does it communicate with everything else? So you do need permissionless interoperability. You need a way that this increasing universe of chains can connect to each other and can do that without having to ask anyone for permission, without having to ask anyone for help. We're in this space because we value our sovereignty, we value our freedoms, and we want to be able to act without being gatekept. And so a world of permissioned interoperability, where we're just waiting for people to add our chains to get this support, doesn't do much for us, doesn't do much for anybody. And this is what we built Hyperlane for. So how does it work? This little schema here shows you the life cycle of a Hyperlane message as it goes from a chain A to a chain B. Let's say again, ETH and Avalanche, ETH and, pick your poison. There are three critical parts to Hyperlane. There's our mailbox, simple contract that just sends and receives information, transfers bytes, encodes them, helps verify them. Then we have our security modules. Think of it as like some logic to run a test on, to basically say, how do I get comfortable with what's been relayed to me from a different place? To that, we could use a system of validators. We could use an optimistic system with some type of watchtower. We could use ZK magic when it becomes available, because who doesn't love ZK magic? It's the best. I'm a big fan. Or we could even use some type of committee-based approach. And lastly, we have a relayer. Relayer is open role. You just heard Jim talk about all the difficulties in relayer systems. There's a reason why they are working on it, because it's a hard problem. And the relayer in Hyperlane is no different, right? A lot of those open questions are things that every system with relayers needs to think about. So how does it really work? You have a contract or a user starting on the source chain. They send the message to the mailbox. They tell it, they have the message body, the bytes that they're trying to transfer around. In those bytes, you could reason about, oh, I want to move this asset. I want to deposit this thing in that liquidity pool. I want to borrow from this lending pool. The mailbox takes in the information about what needs to happen, where does it need to go, and then come in one of our security settings. So in Hyperlane, we talked earlier about this concept of modular security. So instead of being forced to use a specific option, you're always able to choose from a set of security modules. Don't like them? You could build your own. Not everyone wants to do this. It's not a easy or fun thing to do, but it does open the door to a security marketplace. In fact, where we are today is that external teams outside of the Hyperlane core team, are building different security modules. Talked a little bit about ZK Magic. In fact, there's one team already leveraging their ZK proof mechanism to create a Hyperlane security module. And so once your message is ready to get to the destination, the relayer comes in. And the relayer always observes the mailbox. Relayer is a fairly simplistic operation. Think of it like just a basic bot that looks at the mailbox and sees what you're trying to do. It sees that the message is there and it's waiting to be processed. It sees that maybe you're kind and you want to pay them for this service, so you've included a little tip in there for them. Maybe you didn't, and maybe then the only reason that they would relay your message is because, as Jim talked about earlier, is you might have some MEV opportunities for them to take advantage of. As they take your message to the mailbox on the destination chain, they ready it for processing. And during the processing is when the logic is tested against the interchain security module. So there, you can do some really fun stuff. We talked about the bank example, where the bank treats me different whether I try to withdraw $100 or if I'm trying to wire out 50 grand. You could configure your app in such a way that when a message is received, you reason about the message a little bit. Oh, what's this user doing? Well, they're just trying to send, say, $100 in a small swap. Great. Send it through the fastest, run it through the fastest module that we have. No need to have maximum security because it's $100. What's the worst that could happen? $100 could be lost. Someone's now trying to move $100 million. Let me ask you, anyone ever see a 9-figure transaction that wasn't actually an exploit? Rarely happens. It's always an exploit. So a transaction of that size, we can now run it through a very slow path, a very secure path, maybe the optimistic path, which doesn't allow for the message to be processed for a very long period of time set by you as the integrating app. And during that time, anyone can observe that transaction. And if it doesn't look kosher, shoot it down. You don't have to take it. And once it's passed through the ISM, the interchain security module, it's ready to go, arrives at a destination. And so what did we just see? We just saw how we use Hyperlane to communicate between chains. In the interest of time, I won't spend too much time on this slide here, but the key concept is that with Hyperlane, you can choose how you want to secure your messages. Because there is no enshrined security module, you're able to leverage economic security in the form of staking. You're able to leverage that optimistic security that we just talked about. And when you're just getting started, when the stakes are low, you could just have a multi-sig committee. And you can imagine that multi-sig option, it might actually be beneficial even when the stakes are high. Maybe there are certain actions that you want a specific set of people to have to approve. Maybe it's your team, your company. Maybe it's the key portion of your community, the folks who are emerged as the most influential players. Think of this as something that can be used like the emergency switch in MakerDAO, right? Hopefully we all know that there's an option in Maker to shut the system down. Never been used, but it's there. You might need to hit that switch one day. And so how does Hyperlane compare to kind of regular bridging? Generally speaking, most bridging today is done through this form of like an omnibus bridge. You have one contract and it takes all the assets from all the people. And they all sit in this thing and it kind of looks like a nice honeypot. And this is how we end up with more than $2 billion in different bridge exploits, because the more people use it, the more appealing it becomes because they're all there in the same place. But if we're talking about modular chains, like why do we need to have this honeypot shared between everybody? So why not use this concept of modular bridging? Why not leverage what in Hyperlane we call the warp route concept that lets you to have individualized path for each asset. And each path can have distinct security settings. So you might want to have different settings coming into your chain, whether it's USDC, or maybe when you're bridging your own native asset, you want to treat it slightly differently. And that's something that you can do once you leverage modular bridging. So what can you do with something like Hyperlane? So these are some of the obvious fun things that you can do. You can have interchain swapping, right? So why do we do bridging for the most part? Because we want to have the asset go from one place to another, and we want to do something with it at the edge. But if the thing that we want to do is swapping, you might not need to move it after all. If the thing already exists on both sides, why not just transfer the logic of that action and say, hey, John is on Ethereum, and Dave is on Avalanche. And Dave's got 500 USDC, and he's willing to use it to buy some of John's Ethereum. Well, great. So John, you get rid of your Ethereum. Dave, you get rid of your USDC. And we send that logic through something like Hyperlane. There's also the concept of interchain accounts, which will be familiar for anyone who comes from the Cosmos world. Hyperlane recreates that in a broader context. Some key differences there that we could get into if you want to talk later. You could also bring interchain oracles. So we just released this just the other day. With Hyperlane now, you can bring chain link feeds to your chain permissionlessly. So this is a problem that a lot of modular chains, a lot of rollups face because they need access to chain link data or other trusted oracles. And so you can do that. Another use case I like talking about, but I'm running out of time, so I'll be kind, is interchain margin. Now, what does the end game look for something like Hyperlane? We could think about inner rollup networking, where we have created all these rollups. Well, they need to talk to each other more easily, and like what network effects can you create from that? Then relaying services, that security module marketplace that I mentioned, and ultimately this concept of interchain intents. But that was all the time we had. So if you want to learn more, you can go on the docs, docs.hyperlanexyz. You can join our Discord at just discord/Hyperlane. Follow us on Twitter, or you can just find me here, reach out on Telegram. We're generally pretty friendly. So thank you all for having me.
Great, thank you, John. And coming up is the last panel of the day, which you can probably guess is going to be on the topic of bridging, which, as we heard in the Rollups as a Service panel, is one of the most important issues facing rollups and the modular ecosystem. So with that, I'd like to welcome Mads from Maven 11. Come on down, and I'll let you introduce the next panel. Thank you.
Hello? Perfect, thank you. Thank you for making it to the last panel of the day. I'm glad to see so many friendly faces. We have four very smart people on this panel, with a slight change. So we have Bo from Polymer. Then we have Fig from Squid. And then we have Richard from Orb Labs. And then I think we had one more. We have Jim from Catalyst. A quick change, so.
Hey, Georgios.
So I think I would like to start with a small intro, if you can do, what you're working on as well.
Yeah, I can start. Hey guys, my name is Bo. I'm a co-founder at Polymer, where we're working on extending the IBC protocol to all chains.
I'm Fig, I'm co-founder of Squid, and we're doing cross-chain swaps and transactions across the Cosmos and EVM, and soon to be many more.
I'm Richard. I'm a co-founder of Orb Labs, and we're building the chain abstraction stack.
I'm Jim, co-founder of Catalyst. We're building sovereign liquidity for the modular future.
Thank you very much. I think we often hear a lot of different words when we talk about bridging. So I think we hear transport layer, cross-chain messaging protocol, cross-chain router, token bridge. Could you sort of explain, maybe take one each, and explain what that specific topic is, that specific thing is?
I'd love to talk about the transport layer. I feel like it's something that's not really considered in Interop. I feel a lot of people talk about the state layer. They talk about security. They talk about how do you verify something that happened on one chain on another chain. The transport layer deals with encoding of the network topology of the entire network on chain. all the paths between chains, all the paths between all the smart contracts that want to talk to each other. This information needs to be encoded on chain. IBC does it. Very few, or basically no other interop protocol does that.
I can talk about routing and that's what Squid does. Essentially, routing is when you look at cross-chain just from the lens of connecting applications between chains. So we take the view that there's liquidity all over crypto that just needs to be connected, and we use general message passing and different infrastructure layers we use Axler to access that liquidity. And so a user should be able to interact with any application on any chain in just a single click. And it's a little bit like Google Maps, but if you could teleport. So we always find you the way to what you want to do, but it should happen as soon as possible.
Yeah, and I think with messaging, cross-chain messaging at least, the focus is more so passing data from one chain to another. And Bo is right. The reason why most messaging protocols don't focus on the connections is because it's possible to have connection-less interoperability, where you don't need to know the direct paths beforehand and still pass message from chain to chain. And so you find that for most messaging protocols, establishing those connections at least beforehand is not a main focus.
And I guess I can take token bridges, if I think that was something you said, right?
Yeah.
As an option. So token bridges, I think, is a pretty archaic term, at least how I define it. Where I think several years ago there was a need to move coins between their kind of home blockchain to a new one, and so bridges were kind of made as a primitive in order to enable that. And so bridges for me are some function of wrapping a token or minting a new token on these kind of new destination chains in order to get access to this token. And it's backed one-to-one to kind of this vault of the original tokens that are stored on the home chain. And so literally a bridge, right? It's like you're just kind of shooting an asset from its home to another location.
Thank you. I think what you all sort of touched upon a bit was standardization to some extent. So we already have a lot of different token standards. How do you bridge one token standard to the other? And also in messaging. So how do you view sort of standardization, and how do you think we should sort of go towards that?
My long-term view on standardization is that at some point, chain developers, if you relate them to operating system developers, are going to want to enshrine something into the blockchain kernel itself. What that is will probably be an open standard, be net neutral, be decentralized. I mean, I slightly disagree with Richard here on the need for encoding these connections on chain, because I think that if you don't encode this information on chain, you cannot prove anything about the network. In fact, you cannot prove that you have a smart contract that is bound to another smart contract across any number of chains. So I think that when these chain developers do come to make this decision, IBC is the best candidate here.
I think you're going to realize Bo and I are going to be going back and forth. We tend to have very different views on interoperability. But I think going back to standardization, I'm very pessimistic as to whether it will have all the developers aggregate underneath one standard, simply because it's in their best interest not to. If you think about a world where there's even 10% chance that there's a different interop standard that sort of like makes interoperability slightly better for some other chain that didn't choose to enshrine a particular bridge, you're probably going to want the option for that sort of standard to come to your chain. And so what we're probably going to see instead is we're going to see some sort of wrapper protocol that comes and bundles up all these interop solutions and gives applications on top of these chains the ability to move seamlessly from chain to chain. But yeah, going back to the options between connection-based or connection-less interoperability, I'm pretty sure it's still possible to make it very easy to pass messages without sort of like storing and encoding all that data on the chains that you're going to, partly because most of that data is also already encoded in the security layer, or the state layer, which what would call them. So yeah, that's the general thought there.
Any more thoughts on standardization, or?
I think what we're seeing right now is there's some projects that are just brute forcing it, right? I think we can all agree in this panel that there is like pretty kind of, there's a pretty high degree of heterogeneity in the ecosystem as it pertains to varying standards or varying protocols that not only span general message passing, but also, as we were alluding before, kind of the token level as well. And so there are projects like Socket and Livefire that are just saying, hey, like, we'll just kind of put the man hours to aggregate all these things and then abstract it in some sort of off-chain way, right? What I have been seeing is, while that works, and I'm sure will continue to work, there has been kind of a deliberate effort to make their jobs a little bit easier. And so, you know, there's this new ERC, I'm blanking on the name, that Arjun from Connects kind of offered that is kind of championing that, right? And so it's good to see a lot of the liquidity networks like Connects and, you know, our team at Catalyst included, seeing that there needs to be some sort of standardization in how we wrap tokens when we bring it to different chains. And so we allow for not only more interoperability, but also kind of more shared agreement on the security assumptions of that wrapping.
Yes, you sort of touched upon it a bit in the end here. Sort of, if I'm a dev and I'm building an application, I need to choose a question messaging protocol or a bridge or whatever it might be. What kind of trust and security assumptions should I be looking at? And what do I need to consider?
I can go. Just in the standards piece as well. I think it depends where we are in the innovation cycle, because I agree that there's going to be experimentation. If there's a chance that something's going to work, someone's going to go for it and build the product. But potentially with bridging, for example, it's quite an old technology now, and we can start to standardize it. And people are, like the Connects guy, looking at ways of like abstracting it in a way so that you can standardize it for everyone. But our job at Squid is a little bit like the aggregators, where we integrate protocols across different virtual machines, like different chains, different gas models, and we have to deal with all of that complexity. I don't know if we're anywhere close to getting standards in a lot of these places, but so there's just going to be a ton of work on our end, I think, to just deal with that for now. I think we could end up as like a temporary standard, and then hopefully the ecosystem like finds its own way to become very similar across the board. But for now, we need to make things usable, and evolution will play its course.
So will the best standard win, or are there other reasons why a standard might win?
I don't think so. I mean, Solidity is the standard now. So, and I don't think many people agree that it's like the best, and JavaScript's maybe the standard. It's gonna play into a lot of different factors, probably non-technical ones.
Okay, perfect. We had a sort of modular ecosystem day, and we obviously Celestia is a DA layer. How do you guys think that sharing a DA layer might help in bridging between rollups or chains or whatever else it might be?
Sharing a DA layer allows you to have trust minimize interoperability between those rollups. If you share the same DA layer, let's say they're optimistic rollups, you have the security of that DA layer saying that I can make this data available to anyone to be able to generate a fraud proof. That means that this economic security of the DA is shared among the rollups on top.
Yeah, and I think even going back to the general idea behind rollups. So rollups, in many cases, at least for L2 rollups in Ethereum, get the states for all things happening on Ethereum sent up to them. And so in the case where you share its DA layer, you can sort of like run light clients that sort of like look at the state coming from the DA layer and even compute a full node that computes the state of all the blocks that are basically being broadcasted down to the DA layer. And through that, you can extract the message you need. So how that differs from light clients that sort of like rely on, well, separate DA layers is you run into the problem where it's possible for the DA layer to fork, and you may have sent over a state from some other chain showing a fork that ultimately was deemed invalid. So I guess comparing shared DAs with light clients to not shared DAs with light clients, what you have is just a slightly more robust system for passing messages from chain to chain.
Perfect. Any more thoughts on that?
Yeah, I'm not going to talk about the security properties of it. I do think the benefit of sharing DA, and depending on how you use the underlying DA layer, you might also use it for canonical transaction ordering. you do allow for soft confirmations of the state verification of the messages being passed within the execution level. And so with that, you have quicker finality, right? Because you're essentially saying that because this data is made available, because either there's a canonical ordering of the transactions using the transaction ordering layer of this DA layer, or even if you're not doing that, you still have the data made available so that you can have fraud proofs or so that you can reconstruct some of these validity proofs. You are basically allowing for soft confirmations at the cadence in which blocks are produced at the DA level. And so for Celestia, like several seconds, right? And so that is a sufficient user experience, even if there's latency introduced at the execution level for true finality.
Okay, perfect. Maybe more of a question for Fig and Jim here as well. I think you've talked a little bit about the UX problems that we run into with bridging. And how do you foresee how do we fix this? Can AA help? Can intent help? Like what kind of future do you foresee in terms of UX?
I mean, the data availability is, what everyone was just talking about is a good example of UX where we just found out that, I didn't know this, that OP, the optimism token is minted on the optimism rollup and not on L1. And so there's a bridging problem, like how do you bridge OP without it being like fragmented now, because they could have just minted it on Ethereum and then suddenly you have all these canonical versions via the enshrined bridges, but it's going to be a mess. And I think you're going to need these, that's what we do, we have these abstraction layers where you can just get whatever token you need for an application, and even if the application is supporting the wrong token, but technically you can get that token, use the app in one click. And intents are this idea that you just have something that you want to do and you send it off into the world and someone magically solves it. And I think what we're doing is sort of like a proto-intent system where we're the only solver, but and we have a feature called Boost, which we're really excited about. We just launched in the last week, which allows you to essentially declare your intent on the source chain, and then that will get finalized over 20 minutes or however long the bridge takes, and anyone can fulfill that transaction on the destination chain immediately. And it's fully generalizable because it's using general message passing. It can be a swap. You can buy an NFT across chain. You can do staking across chain. And that's the user experience we want. We want people to do anything in any application in one click as soon as possible. And yeah, I feel like we've gotten there. We've started just with something which works, and then you can decentralize that more over time. And I think, yeah, really excited for intents and to integrate them into Squid as well.
Yeah, I don't have too much to add as it pertains to intents. I do agree that routing systems like Squid and the ability to have kind of a sophisticated entity provide the liquidity for fast liquidity / soft confirmations of those transactions is really awesome, right? I think that augments the UX considerably. I do think we still, even in that paradigm, well, two things I'll add. One is that I think intents are really interesting, but I don't think people talk about solvers enough. So what Fig at the Squid team and doing kind of the boosted feature, what they're doing there is really kind of starting the conversation of how do we have infrastructure that is not articulating intents, but actually fulfilling or providing the liquidity or providing the tools for these entities to fulfill those intents. So I think we need more kind of advancement and more investment focus into that piece. And I think where we come into the picture is kind of the second piece, where even in that paradigm in which we have really robust infrastructure for solvers to fulfill these intents, we still kind of face what I think is a cold start problem when you look at new chains. And so I think it's pretty kind of consensus now that there's going to be lots of rollups, right? Hundreds of thousands, if not millions. Within that kind of framework, like if you have a brand new chain, it's a really difficult problem. it's a really difficult problem to try to inject liquidity into a brand new chain that's basically a barren wasteland. And so how do you solve an intent for a new chain when there's no liquidity, right? And so that's a big research question that we think a lot about Catalyst. And so we're hoping to slot into kind of this refocus into the solver problem space.
I do think most of the conversation around intents currently focus a lot on a very defined problem, which is swapping one asset for another. But there's a big question on if intents are going to eventually become, let's say, the end game of interoperability, then we're going to need to find ways to generalize intents to almost every possible transaction. And I think that problem's extremely difficult and maybe the main bottleneck to us ever getting to this final state of interoperability, partly because intents in many ways are invariant programming. You basically have to, well, configure your system to check against maybe an infinite number of invariants to make sure you don't break things. And yeah, that's not an easy problem. So I think we're going to see a lot of maybe proto-intent systems that combine transactions and intents for quite a bit. And then eventually, perhaps after several years of thinking about the problem more, we might get to a generalizable intent system.
Anything on that, Bo?
Yeah, since we're talking about intents, I'm kind of on a tangent now, but would love to kind of talk a little bit about the work that Anoma is doing and how it can apply generally at the interoperability level. So if you think about the research that they've done to, say, allow chains to combine or take the union or the intersection of the validator set between multiple chains, bootstrap a temporary chain, they call it chimera chains, and be able to create cross-chain atomic transactions. If you were able to standardize at the networking level, so at the interoperability level, let's say IBC everywhere, hypothetically speaking, and IBC were to have access to the consensus mechanism of all these different chains, you could apply the ideas of heterogeneous Paxos and do essentially cross-chain atomic IBC transactions across all IBC-enabled chains. I think we'll see some of this, but I think it'll take like probably quite some time to get to this end state.
All right, perfect. So some of you have talked about a world of hundreds, if not thousands of different chains. Do you think we end up in a world where there's like one aggregator aggregating all kinds of different cross-chain messaging protocols, token bridges, whatever else it might be? So how do you foresee sort of aggregation working out?
Well, yeah, definitely be Squid. There'll only be one. And everyone will use the Squid SDK to build their apps, and there'll be some Squid widgets, which everyone uses in all applications everywhere. All the wallets will have us installed. So I think, yeah, I mean, it's going to be like, there'll be a few winners, I think, in all cases. Like, there might be a few interop winners, there'll be a few aggregators. It depends what you end up focusing on as well. Like, we try to not take the approach of we're aggregating everything, we're just doing swaps, and then you can pair a swap with something. So it's more like a payments layer. Maybe you have NFT aggregators, and as we find more actual use cases for crypto, then there'll be more solutions that might be the winners. But
yeah, I mean, I think aggregation theory that a lot of people talk about, either on their Mirror blog posts or you can look at like Strategery, is probably going to play out where you see kind of like a power law distribution where there's going to be a handful of short tail suppliers for aggregation, and they might say they're differentiated, but the reality, I just have to use 5 of them to get access to everything. And that's fine. I mean, I think that's just how the economics plays out.
I do have a bit of a controversial take, though. I do think the intent future, or at least the intent future envisioning, is directly counter to this aggregation future, partly because once you introduce solvers to the mix, solvers are way more sophisticated than your end user, and they will more than likely explore a wide variety of possible different places to get the assets they need to basically optimize or maximize their profits. And so we could see a world where aggregation doesn't really take place, but we have a number of liquidity networks and token bridges that people just generally go through from one to one just to make sure they get the best possible profits. And these layers will be fighting based off of, well, who has the lowest slippage, who has the cheapest gas fees, who has like the fastest times, and so on.
Right. Do you have anything to add, Bo, or?
Yes. Once again, I'm going to talk about the lower layers of the stack while everyone else talks about the upper layers. I would say that I think at the lower layers of the stack, we're going to see some consolidation, probably in the 10 to 20 year time frame. I know people don't really talk about 10 to 20 years in the crypto space, but it's about how long it took for the world to kind of converge on a roughly this, a consistent networking standard, TCP/IP. In fact, in the early 70s, 80s, there were a number of proprietary, I would say like company-owned protocols that were kind of seen as these de facto standards of the time, maybe like a layer 0, for example. And over time, they congregated, because if you're, Apple, you've implemented Apple Talk, Microsoft might not want to implement Apple Talk, but Microsoft will be a little bit more open to implementing TCP/IP per se. So I think like the world will converge to IBC in the long-term time horizon, but in the short term, we'll see a lot of aggregation at all layers.
All right, perfect. So maybe to move the thoughts towards, I think a big difference in some of you and other bridging providers as well, is the fact some might be using a state or a middle chain to verify messages. Some don't, layer 0, for example, and others as well. What is your opinions on having a state middle chain? Do you think the sort of cryptoeconomic security it provides is good or bad? Some might, say that. Or what are your opinions on that?
So I think the idea of a stake middle chain comes with some baggage. I think it comes with the baggage of generally these protocols implement some proprietary, cross-chain gateway protocol, nothing wrong with that. But some other protocol that the chain or the team that owns the chain controls. I think having middle hops in network topology makes a lot of sense. I think if you want to scale network topology and you have a lot of heterogeneous infrastructure, you do need middle hops. That being said, I think long-term, you still want to converge to a single standard, have middle hops in between. Obviously, you want these to be secure as well. Ideally, you want them to be trust minimized. If you can prove the execution of an entire path for a particular packet, then you can remove trust on these middle hops in the long-term time horizon. So I think that the stake matters a lot now, but I think as technology advances, I don't think it will matter as much for security.
I think right now there are ticking time bombs, partly because if you think about it, the whole idea is that economics will always make it, not profitable for a malicious party to basically exploit those chains. But as more and more chains connect to various chains as hubs, take like Axelar, Polymer, which are trying to become hubs for IBC, it may just end up being the case there's way too much value built on it that like even the validators don't have enough economic incentives to keep the network as robust as possible. And the only way that changes is a world where the light clients they're using for passing messages from chain to chain are no longer necessarily just checking their validators to see if they provided the right signatures, and more so running complete state transition proofs of all the transactions happening on those chains. And at the point at which you get to that particular level, they don't no longer need to be validated chains. They can just become rollups and do the exact same thing. So yeah, I think we're probably going to see a world where all the validator-based networks effectively start to do the exact same thing rollups do in order to become robust or very secure, or they're just going to implode because the economic security no longer holds.
And I'm assuming you have some thoughts on this as well, Fig.
Yeah, sure. Yeah. No, I agree with what you guys are saying, for sure. It's a temporary solution that will upgrade into a more trustless solution when the technology gets there. But for now, we need a solution that we can connect the unusual chains into other networks which are maybe more interoperable with each other, like IBC. And then IBC is developing, and over time it will get more capable. But for now, we want to connect Ethereum to the Cosmos, for example, so that the Cosmos can get some users and build up business relationships. I think the economic security, honestly, that's a ticking time bomb. But with the number of users at the moment, it's more about I think there are so many other things to be worried about with security and bridges. It's the Nomad hack, for example, was just at the smart contract layer. In fact, I think the Solana hack was it Solana? No, the wormhole hack was similar, $300 million, and it wasn't anything to do with economic security. But definitely, centralization is going to be the cause of a lot of hacks. And Axelar having 75 validators compared to, say, I won't name names, but in the 5 or 6 range in a lot of cases, it's completely different, and so much harder to hack. And then these chains become like Polymer and Axelar take on a different role in a future where everything is trustless. They can be routing hubs. They can potentially have a programming environment where you can build network logic for specific applications, like gas networks, for example, or they're a way that you can program into the networking layer, and yeah, that's it.
Yeah, one tiny rebuttal on the point of, well, the number of validators being the main thing that sort of like keeps things alive. I do think it's a combination of the validators and the stakes. And when you compare most of the chains that, well, do have these diverse sort of like validators, you still find that the stakes aggregate into some sort of like few hands. Just because, well, for the most part, you probably find that it's probably the team that's running most of the validators on chains like, Axelar. I do think the bigger point, though, that stands is for us to get to a world where we sort of are comfortable with these hubs, they're eventually going to have to change or switch to some variant of a light client system that depends almost entirely on state transition proofs as opposed to, well, the validators. That way, we sort of like move the security away from the validators and the stakes to, well, math and whether we're running the right computations.
Are you in agreement, Jim, as well?
Kind of. I do think proof of stake or leveraging economic security is not as big of a ticking time bomb as my fellow panelists may think. It's a coordination problem, right? Like, let's say you move more economic activity than the underlying stake, which, surprise, Ethereum does, right? It's like, that's where decentralization matters. It's like, okay, like, let's say you're using vanilla Tendermint, or I guess Comet BFT, they call it now. It's still a coordination problem for all these validators to collude and actually, have a erroneous state transition occur. But I do agree that we're probably going to move away from that model, not because it's a ticking time bomb, but because it's just inefficient, right? Having a committee of validators run full nodes of God knows how many chains, right? I would say you could probably, depending how beefy your nodes are, run 200 chains, like, which is higher than I think most people would probably say. But anything more than that, then it's not going to happen.
Yeah, so what you're saying is that each of the validators would have to run a full node for all the other chains they support?
Yeah, precisely.
And I guess also incentivizing sort of the validators as well could also be a problem too. We've heard a lot about CK bridging, I think, over the last couple of months and years. Do you guys have any thoughts on using CKPs in bridging, making either for trust minimization or for batching block headers or transactions into CKPs?
I'll start mainly because I'm the least qualified, so I'll give the most high-level opinion about it. I think they're important. I think there's still a lot of open questions on what that looks like when you have, heterogeneous proving schemes, when you have latency on, posting proofs on chain and verifying them. But like what Richard was saying, like, that is the end state, right? It's like, we can't be verifying the consensus, or said differently, we can't be snarking just the signatures of these validators of underlying execution layers, but we need to be actually verifying or proving the computation of the actual state transition occurring, right? I think the solution to this kind of the open questions that I'm talking about is two pieces. One is there still needs to be a hub, right? It's like heterogeneity of all these proving schemes, all these different rollups. You probably want a prover aggregator or proof aggregator, or like using some sort of recursive proof system in order to make sure that they become homogeneous, right? And you probably still need a router, honestly. Like, you can't have millions of chains all talking to each other in pairwise kind of permutations, right? And then, like what Bo was mentioning, snarking the actual path of that packet becomes really important. And then on the cost piece, I do think optimistic ZK, right? Like, I had a tweet, I was saying, like, I think everyone's talking about how off-chain is the future, which is kind of ironic. But optimistic ZK is interesting, which is where you snark something, you don't verify it on-chain, but you could verify it on-chain, and becomes like a one of n, like fraud prover kind of setup.
I feel like you probably have more.
Oh, I have a quick one. I don't have too much to say on ZK bridges other than excited for when they come live and we'll use them. But I wanted to correct, Axel Labs' team doesn't run any of the validators, and it's a permissionless network that anyone can join and run a validator. That's the big difference between it and, say, multi-chain, which just got hacked a couple weeks ago. Which literally, it was an MPC protocol where the CEO owned all the instances running all the MPC nodes, which was insane. But yeah.
Yeah, the state middle chain approach is definitely more secure than multi-sig.
Agreed, yes. On the topic of ZK clients, I would say that there's obvious performance issues that you want to work through, and that will improve over time. On the front of proving the entire execution path is something I wanted to drill into. So one advantage of encoding some of this network topology on chain is that now you have a subset of the keys that are owned by each and every particular path. So you can shard proving of the execution of one particular path and separate that away from proving the path for communication between another set of smart contracts. And you can do this on a smart contract to smart contract basis. If you don't have this information on chain, it's very difficult to scale proving.
Anything to add on that, Richard, as well?
I don't know if I completely buy that, but I think I have to think about it more. But I think, yes, light clients will be the final state of interoperability. And I think coming to this event, I realized that a lot more people think that it's further out than it actually is. I think most of the tools needed to build extensible light clients currently exist. It's just a matter of, well, assembling things like Lego blocks. And once we do that, we should be able to have light clients for most of the, I guess, popular networks and frameworks we currently use.
So if we're in a future where all chains support light clients, do we just not use smart contracts at all and just light clients for bridging?
No, we will still use perhaps some optimistic system, partly because of the latency that comes from proving these chains. I think perhaps the end state of bridging would be optimistic with light clients for dispute resolution, if anything. So imagine a world where someone, states that something happens on some chain and some people just monitor this particular proof. And if no one disputes it, then hey, we're fine. And if someone disputes it, we check the light clients to make sure that they're not lying. It makes more sense given that, until the hardware becomes really good and the proving software becomes really good, we're still going to be looking at perhaps 3, 4, 5 minutes, sometimes even up to 12 minutes worth of latency for passing messages from chain to chain. And people aren't that patient. So yeah.
I'm going to take a quick second to shill the work that we're doing at Polymer. So we're working on, since we're on the topic of optimistic ZK approach to interoperability and forming that connection, we're working on optimistic ZK IBC connections at Polymer. So we have working ZK IBC connections, and we're working on overlaying optimistic verification on top. And we expect to have that and hopefully testing in a few months. So, yeah.
Cool. So we've talked a lot about how we can solve interoperability. So in a world, a dream world, maybe 5, 10 years from now, what kind of applications are you looking forward to seeing? Like what kind of cool applications can you build when you have 1,000 seamlessly connected chains with relatively decent latency?
I think a lot about the idea of borderless finance, where everything that we own becomes kind of aggregated within one single interface, irrespective of where it lives. And this goes beyond an on-chain context, right? And so my shares of certain companies that aren't doing too well right now, or my cash assets or my real estate, it's all in the same view as my crypto assets. And there is ample liquidity in moving between all of those in whatever action I want to prefer. And so interoperability obviously is on chain right now, but I do think that there is a lot of research underway of how we kind of, whether through the use of ZK snarks or what have you, bring real world assets into it as well. And it becomes a lot more delightful, I think, to own financial assets in the meat space.
Very cool. What about you, Richard?
I think when all is said and done, the main product that we'll see enabled by interoperability will be some variant of a cross-domain intent protocol. I think the end state of interoperability will be the chains themselves sort of disappear. They only become a thing that the developers care about. Very similar to Web 2 in many ways, right? Only you care about where you deploy your application. Only you care about where your software sits. Users just care about them being serviced. And yeah, until we have that, we're probably not going to cross over that, well, million or billion mark that everyone keeps on talking about when it comes to users.
Yeah, I agree with that. We just need a way for people to build projects and be able to add. I mean, at the moment, I feel like the only use case we have is payments, but you can imagine also making the Web 2 example. I'm really excited about how you can potentially bring AI into the intent system. Like we've actually built a proof of concept in Squid, and we're working with Dora, who are in the audience on it, and they've built a thing where you can they're like a search engine, like the Google of crypto, where you just type in what you want to do, and then it goes through the Squid SDK, and it finds, say you just want to mint an NFT, it finds the NFT somewhere, builds the transaction packet so you can buy it from anywhere, and you've got your NFT. So you can potentially imagine a world where you have a Google, like just a search bar, which is your entrance into getting anything, or at least finding an application, and then interoperability allows you to access that in one click from anywhere.
I love what everyone said. Borderless finance is very important. Some of the early applications in crypto are financial and have priced out some other applications. Me personally, am very excited about gaming. I'm a huge nerd and I love computer games. So I recently saw a post. Someone had tweeted about having on-chain like a variant of Warcraft. If people are familiar with like real-time strategy games like Warcraft, StarCraft, these are kind of like your, Age of Empires as well. There's a number of them. These tend to be your like classic real-time strategy games. But having these on-chain games and be able to prove it is a very interesting use case to myself personally. I would love to play these games. I would love to be incentivized to play these games as well.
All right, very cool. I think we're running slightly beyond schedule, so I don't think this is correct. And I know there's a happy hour outside. So thank you very much for joining our great panelists today as well.
Thank you.